Assalamu alaikum to everyone. Welcome to 6th International Conference on Value Addition and Innovation in Textiles, named as COVIDEX. First, let me introduce myself. My name is Dr. Talha Hamdani, an assistant professor at National Textile University, Faisalabad. I will be responsible for moderating the upcoming sessions till afternoon. Before starting the formal session, I would like to request all of you to listen Surah Al-Alaq from Al-Quran. The recitation is also available at Quran Reader YouTube channel.
Bismillahir Rahmanir Rahim.
In the name of Allah, the entirely merciful, the especially merciful.
اقرأ باسم ربك الذي خلق.
Recite in the name of your Lord who created.
خلق الإنسان من علق.
Created man from a clinging substance.
اقرأ وربك الأكرم.
Recite, and your Lord is the most generous.
الذي علم بالقلم.
Who taught by the pen.
علم الإنسان ما لم يعلم.
Taught man that which he knew not.
كلا إن الإنسان ليطغى.
No, but indeed man transgresses.
أن رآه استغنى.
Because he sees himself self-sufficient.
إن إلى ربك الرجعى.
Indeed, to your Lord is the return.
أرأيت الذي ينهى.
Have you seen the one who forbids?
عبدا إذا صلى.
A servant when he prays.
أرأيت إن كان على الهدى.
Have you seen if he is upon guidance?
أو أمر بالتقوى.
Or enjoins righteousness?
أرأيت إن كذب وتولى.
Have you seen if he denies and turns away?
ألم يعلم بأن الله يرى.
Does he not know that Allah sees?
كلا لئن لم ينته لنسفعا بالناصية.
No, if he does not desist, we will surely drag him by the forelock.
ناصية كاذبة خاطئة.
A lying, sinning forelock.
فليدع ناديه.
Then let him call his associates.
سندع الزبانية.
We will call the angels of hell.
كلا لا تطعه واسجد واقترب.
No, do not obey him, but prostrate and draw near to Allah.
May Allah subhanahu wa ta'ala make understanding of Quran easy to us and may we follow the path of righteousness. Next, we have national anthem, which is a symbol of our country. It represents the tradition, history, and belief of a nation and its people. So I request all of you to please stand at your positions in the respect of our national anthem. Now we have Dr. Amjad Javed Saab with us. I will request him if he would like to say a few words.
Thank you, Mr. Hamdani. In the name of Allah, the most beneficent and the most merciful, I am Dr. Amjad Javed, working as Assistant Professor in National Textile University. On behalf of organizing committee, I welcome the distinguished speakers from academia, industry, business community, and our respected audience to 6th International Conference on Value Addition and Innovation in Textiles. I'm so excited to have you at this forum where after every 2 years, we have wonderful gathering seeking the ways of technical, economic, and social benefits through discussions and knowledge sharing. Owing to COVID-19 pandemic, the conference is being held online. I hope and pray that you will be in good health conditions. I believe that in next COVID-X, we shall be able to have physical gathering to share knowledge and ideas. In 2 days of conference, we can find a wonderful opportunity to listen the renowned professors working in different areas, individuals involved in policy making, and CEOs or different companies. The talks to be delivered on first day are quite interesting. These cover the topics such as challenges to the Pakistan textile industry and COVID-19 and its impacts on textile industry and fashion trends. It will help to predict the forecast and way forward to make the future directions and priorities. Functional textiles have been the focus of interest for last 2 decades, and there are interesting developments in the subject. Here, we shall be able to know about the new developments and innovations in functional textiles. In second day, there will be precious talks to explore the developments in textile-based composite materials and sustainability in textiles. Apparently, it was a difficult task to conduct the online conference as it was our first experience. I am thankful to Rector, National Textile University, Professor Dr. Tanveer Hussain for his confidence in the organizing team and endless support. I'm also thankful to Dr. Yasin Nawab, Dr. Munir Ashraf, Dr. Usman Zubair, Dr. Talha Hamdani, and organizing team for their support and efforts. Further, I want to request the participants to ask the questions in writing. The moderator will present the question to the speaker to avoid any inconvenience. At the end, I wish the participants to get maximum benefits from this 2-day event. Thank you. NTU Zindabad, Pakistan, Zindabad.
Thank you, Dr. Saab. Now I'm glad to introduce Professor Dr. Tanveer Hussain, Rector, National Textile University, Faisalabad, for a welcoming remarks, sir, please.
Bismillahirrahmanirrahim. Assalamu alaikum. I hope everyone can hear me. First of all, on behalf of National Textile University and our organizing team, I extend my deepest and warmest welcome to all the participants on this online edition of COVID-X. I'm also grateful to all the experts from academia as well as industry who will contribute in this conference. I'm extremely thankful to all the organizers and especially the participants and for making this event successful, because it was very difficult to have this conference on campus. So we are trying to make it successful online. As usual, I would like to set a basic background for this conference so that we have a context of all this. So let me begin with my presentation. I hope everybody can see my presentation. So as usual, I would like to begin with the basic latest statistics. Textile and clothing currently comprise the 5th largest commodity exported all around the world. And this is according to the latest available data, which is available at International Trade Center or WTO. The number one commodity which was exported during the last year, that is electric and electronic equipment. And number two, we had machinery or mechanical equipment. Number three, oils and fuels. And number four, automobiles. So textile and clothing is at number four. Currently, China is the largest exporter of textile and clothing in the world with an annual exports of $260 billion. So China's share in textile and clothing export is almost 30%. And this textile and clothing is the only category among the top five in which Pakistan has a significant share. That's around $13.7 billion. If we look at the top four categories, the share of Pakistan's exports is negligible. But if we want to move up the ladder of industrialization, I think it will be very important in the coming decades and years that we should move up towards machinery manufacturing and electric and electronic equipment. There's a lot of talk recently in Pakistan for promoting IT. I think that is limited to the IT services. But if we limit just IT to IT services, our share will not be that much. Currently, our share in the export of IT services are around $1.5 billion. And India's share in IT services export is more than $50 billion. So although we lag much behind in IT services, but we also should try to develop our expertise in IT as a component of machinery and electric and electronic equipment, because unless we have manufacturing sector strong and developing, our road to industrialization will not be very fast. So all the industrialized nations have focused on machinery and electronics in their progress towards becoming industrialized countries. So textile is usually the first step towards industrialization, but it should not be the last step. We should move up towards the other ladders. If you see the breakup of the textile and clothing trade, at the top we have knitted garments. So knitted garment is basically the largest sector in terms of exports worldwide. Last year, $239 billion worth of knitted garments were exported around the world, and China's share in this category was $71.4 billion, and Pakistan's share was $3.03 billion. If we combine the knitted garment and woven garments together, the total garment share is $475 billion around the world. And in this $475 billion, the share of Bangladesh is around $40 billion. So our share is just around $6 billion. So we need to move towards garment exports more and more in the coming years, because this is the largest portion of the pie. So our share can only increase in the overall textile and clothing exports if we focus more and more on the garments in the coming years. Our focus currently or in recent years have been on the home textiles. So home textile is still our largest sector, $4.07 billion. But in terms of overall world exports, the share of home textiles is very low as compared to garments. Then at number four, we have cotton, yarn, and woven fabric export around the world, $56 billion of market, and our share is $3.25 billion. So these are the four top categories in which Pakistan has significant share. And in terms of man-made filament yarn and woven fabric and man-made staple yarn and woven fabric, our share is negligible, just $45 million and $312 million, not in billions. Knitted fabric, our share is very low. Non-woven fabrics, coated fabrics, carbex, special woven fabrics, wool, and vegetable fibers other than cotton and silk fiber. Obviously, worldwide, the share is low, and our share is also very low. Now, the effect of COVID have been significant all over the globe, and International Textile Machinery, Textile Manufacturer Federation ran different surveys during the last year to judge the impact of Corona pandemic on textile turnover. And Their last survey was in December, and according to that survey, overall, on average, there was a negative 12% effect on the turnover of the textile industries all over the globe. This was average, but this is not true for all the individual countries. Some countries performed very well, and we'll see Pakistan is one of them. The outlook is not very bleak. It is seems to be very bright. So according to the survey done by the International Textile Manufacturers Federation, it is expected that by 2024, there will be almost 18% increase in the turnover of the textile industry overall. And within Southeast Asia, the increase may be up to 30%. So the outlook seems to be bright according to the survey done all over the world through different textile industries. Overall for Pakistan, the year 2020 has not been bad. It has been very good year in the end. And we can see in the blue bars are the data for 2019. And we can see the orange line, we had our lowest exports in April, but in December, our monthly exports were $1.4 billion in textile and clothing. And in January 2021, $1.3 billion. So Pakistan has recovered from Corona, and its performance currently is better as compared to the previous year. But if we compare our progress with the overall in the world, we are better off from many countries. But China also has recovered to the pre-COVID situation, pre-COVID level. So the competition from China is still there, and also competition from other countries will also remain there. If we look at the data provided by Pakistan Bureau of Statistics, they usually provide data not in terms of HS codes, but in different categories. We can see that knitwear are at the top, and garments are at number 2 in Pakistani exports. But this bedwear is at number 3. But if we combine this bedwear with towels and other made-ups, this bedwear, towel, and made-ups, these 3 categories made home textiles, and they comprise these home textiles, then this home textile will be at the top. So, but we are seeing encouraging trend in terms of garments and in knitwear. So hopefully in the coming year, Pakistan's exports will increase in knitwear and garments. And these are the value-added sectors. But now we come towards the challenges. The biggest challenge which is currently being faced by Pakistan is the production of cotton. In the best of our times, our cotton production was 11.1 million bales, and that was in 2004. And during the last year, our cotton production was just 4.5 million bales. And this bale is 480 pounds, which is larger in size as compared to Pakistani bale. So this is the biggest challenge for Pakistani textile industry, that domestic cotton production is decreasing day by day due to the unavailability of certified seed and due to substandard pesticides and fertilizers, and increasing area for the cultivation of sugarcane, etc. So there are multiple factors, but we must concentrate our attention to increase the production of cotton yield in Pakistan if we want to support our textile industry, and if we want to keep our raw material advantage vis-a-vis Bangladesh. Because Bangladesh does not have any raw materials, but their exports in garments are far, far ahead of Pakistan. But we are also losing our competitive advantage, which was the indigenous cotton raw material. Another challenge in terms of cotton is the production of sustainable cotton. So Pakistan's challenge is twofold. Not only we need to increase our productivity of cotton as such, but also we increase the proportion of sustainable cotton, because most of the famous brands all around the world, they have pledged to bring up the sustainable cotton consumption up from current level of 25% to 50% by 2025. So we not only need to increase our overall cotton production in Pakistan, but the proportion of the sustainable cotton component should also be increased to a significant portion, because the world is moving more and more into sustainable. So sustainability is the mantra these days. So we need to focus on this. These are some of the brands which have pledged to make use of sustainable cotton. And you can see companies like Adidas, IKEA, Levi's, etc., CA, Gap, they are all basically focusing on sustainable cotton sourcing in future. So if we want to be ahead in the cotton textile and clothing exports, we need sustainable cotton, not just ordinary cotton. Now, internationally, they have developed different parameters or metrics for sustainable cotton. And some of the metrics are about environmental aspects, some are about economic aspects, some are for social aspects. So in our cotton production, we need to monitor all these metrics. For example, use of hazardous pesticides, water use for irrigation, water use efficiency, topsoil, carbon content, fertilizer use, etc., average yield, etc., etc. So these are different metrics we need to take into account while production of our cotton, and we need to sensitize and educate our farmers to take care of these metrics if we want to increase the proportion of sustainable cotton in Pakistan. Now, if we look at the overall consumption of different types of fibers all over the world, the total consumption is around 111 million metric tons. And synthetic fibers comprise about 63% of all the fiber consumption worldwide. And these 63, out of the 63%, polyester accounts for 52.2%. So we can say that more than half of the fiber used in the world is polyester. And the second most important synthetic fiber is polyamide or nylons, and the rest of the synthetic fiber is 5.7%. Then we have man-made cellulosic fibers, also 6.42%. Then cotton's proportion is only 23.2%. Other plant-based proportion is 5.9%. So synthetics are currently comprising the maximum portion of the fiber consumption, but there are serious concerns on the use of synthetics worldwide. One of them is their non-biodegradability, and the other one is that they are not produced from renewable resources. So in the future, there may be a trend about the recycling of the synthetics and more use of the natural fibers or man-made cellulosic fibers, which are biodegradable and which are used from renewable resources. For example, if we look at the polyester consumption, only 14% of polyester used all over the world is recycled polyester, and the rest is not recycled. And similar to the challenge of cotton sustainability, different brands all over the world, they also have taken a challenge of increasing the polyester sustainability. And that challenge is to bring up the recycled polyester consumption up from 14% to 45%. So here lies also another a business opportunity as well, because in Pakistan, we do not produce enough recycled polyester. So if we do not indigenously produce enough recycled polyester, and there's a demand from our customers that we should give recycled polyester products to them, then we need to have our local production of recycled polyester in the coming years. So despite the biodegradability of polyester, there is still one concern which is emerging day by day. That is the emergence of microplastics from these synthetic materials. It has been found during research that when these synthetic garments are washed in domestic washing or industrial washing, microfibers, they just go down the drain and then they go into the into sea or into other water streams, and they are not good for aquatic life. So a serious concern all over the globe is developing about the use of synthetics overall, even if they are recycled. And the reason is that they shed tiny microplastics or microfibers into the water that goes into the streams, water streams, affecting the aquatic life, and it is not biodegradable. So in future, there may be more and more interest in the revival of the consumption of natural fibers or natural materials. And there's a growing interest these days about natural fibers other than cotton. For example, jute, coir, flax, sisal, rami, hemp, etc. A lot of interest has recently been noticed in the use of hemp, because hemp is being considered as much more environmentally friendly or eco-friendly fiber as compared to cotton. So in Pakistan, there's also growing interest in the use of hemp. So more natural fiber and more renewable fiber from renewable resources. Since man-made cellulosic fibers are produced from wood pulp, and wood pulp is also a renewable resource, then there will be, I think, growing interest also in the increasing use of viscose rayon, lyocell, modal, and cuprammonium rayon in the future as well. So world is trying to move away from synthetics and trying to move towards more and more towards regenerated cellulosic fibers and natural cellulosic fibers, which are biodegradable and which are produced from renewable resources. And we, as an industry, also need to focus on these areas. Another challenge is the water challenge, because it is usually believed that almost 2,700 liters of water are required to produce the cotton needed to make a single t-shirt. So clean water is a rare commodity in many parts of the world. So there's increasing concern about the wastage of clean water in industrial processing. It is believed that 1/5 of the world industrial water pollution comes from the textile dyeing industry, and 5.8 trillion liters of water is used annually in traditional dyeing processes. So around 100 and 180 liters of water is required to dye 1 kg of fiber by traditional dyeing process. So for researchers, there's also a challenge that they need to develop such methods and such machinery or equipment which requires less and less water. And these processes and this type of machinery is emerging day by day. Now we are noticing these days we have some spray dyeing machines available, some ultra low liquor ratio dyeing machines available, some mist dyeing or mist processing machines are available, digital dyeing available. So the world is moving towards the efficient use of water. Then there's a challenge of energy. For Pakistan, we now, according to the media news, we have more than the requirement of Pakistan. We have more energy that is required currently, but our energy is expensive. And it is not produced mostly from renewable resources. So what Pakistan needs is a cheap energy and also more of it from the renewable resources. Because overall, globally, there's a concern of climate change. And in future, in the coming years and decades, there'll be more and more focus on the use of increased renewable energy in all the industry. And there's a fashion pact that up to 2025, 50% of energy used in the manufacturing sector should be from the renewable resources. And we need to think about these as well. Another key trend is from movement from linear economy to circular economy. Nothing should be wasted. Everything should be reused, recycled, recovered, etc. You can repair and reuse, recondition and reuse, refurbish and reuse, remanufacture and reuse, etc. Any waste material or any garment or textile product, after use, it should be recycled, upcycled, or downcycled, and then should be reused again. Any effluent or any emission which is coming out of manufacturing process, it should be treated, and before it is disposed into the ecosystem, it should be environmentally friendly, and the more of it, if is recycled and reused or recovered, the better. So from linear economy, the world is moving towards the circular economy. So we need to change our processes in such a way that every type of waste is recovered, recycled, or reused, etc. The next big trend is the movement from fast fashion to durable fashion. It is estimated that almost $400 billion worth of clothing is wasted globally every year. And just in one country, America, 16 million tons of textile waste is generated. And that is dumped. Only 15% of it is recycled. So there is an increasing trend of more durable, long-lasting clothes and long-lasting, durable textile products rather than fast fashion products, which are meant only for the use of one season. So, so that the textile waste is not generated so much, and which would need to be dumped in the planet, and that would not be good for the planet. And then there's a trend of movement from simple innovation to sustainable innovation. And sustainable innovation covers all the steps of the value chain, starting right from the raw material. Raw material should be renewable, biodegradable, recycled, organic, etc. In production, there'll be more emphasis on reducing the energy consumption, water consumption, chemical consumption, effluent emissions, and solid waste. Packaging should be renewable and from biodegradable resources, from recycled and organic. Distribution should be eco-friendly, and usage of the product should be developed in such a way that they do not need large quantities of water or high temperature for washing. They should not need any ironing or drying at high temperature. Similarly, disposal should be dealt with by reuse and recycle or composting. And these are the sustainability metrics which are going to be important for each and every mill. So every mill needs to monitor the average product carbon footprint, sustainable material use percentage, renewable energy use percentage, energy consumption per unit garment, carbon emission per unit garment, energy consumption per kg of processing, carbon emission per kg of processing, waste to landfill, freshwater use per kg of processing, compliance with restricted substances list, and compliance with wastewater standard. These are the metrics which are becoming more and more important, and every manufacturing industry needs to monitor these parameters within the mill. Now, again, there is a trend for movement towards digitalization, and digital transformation. And every industry needs to make effort to convert all the available information in digital form. No khatas, no registers, everything paperless, all the data in digital form. That is the first stage of digital transformation, which is digitization. In the second stage, they should apply the digitized data or information to simplify their specific operations. And in the third stage, there's a digital transformation stage in which they devise new business applications that integrate all the digitized data and digitalized information. So in order to digitalize our industry, we need to embrace these new technologies such as Internet of Things, Internet of Services, Internet of People, Internet of Data, cloud computing, big data analytics, blockchain technology, cybersecurity, augmented reality, automation and industrial robotics, additive manufacturing, simulation and modeling, cyber physical systems, and semantic technology. So all these technologies are enablers for the digital transformation of our industry. So if we do not digitally transform our industry, we will be left behind in productivity and in efficiency. So the world is moving towards digital transformation, and every new machinery which is being manufactured by good European manufacturers that has built-in Industry 4.0 capability. So we need to make all our processes digitally capable, connected, so that they generate useful data, and that useful data is used for making good decisions. And these are the lessons which are learned from the pandemic crisis. According to International Textile Manufacturers Federation, the topmost lesson is that industry should improve digital capabilities. The second important lesson is they should reduce dependency on fewer customers. The third lesson is they should broaden the products on offer. Fourthly, they should strengthen the balance sheet. And then they should change the products on offer, depending upon the emerging requirement, then reduce dependency from fewer customers. So these are some of the lessons which are learned by the textile industry during the last year of pandemic. Now, I shall give you a glimpse of some of the research and development facilities at NTU so that as an industrial partner, you can know how can we help in your R&D of the future, and so that our academic partner can also know how can we collaborate. So here's a glimpse of what R&D facilities we have at NTU. Starting from the fiber manufacturing, we have a facility of melt spinning, wet spinning, and electrospinning. So in melt spinning, we have a multi-component melt spinning system where we can do research and development on synthetic fibers made from one polymer, two polymer, or multiple polymers. Wet spinning we use for the production of regenerated cellulosic fibers. We can do research on that. We have developed machinery for that. And currently we are using this for making fibers for medical textiles. Electrospinning has multiple uses. We have multiple types of electrospinning machines, and we can produce nanofibers with these machines. And these nanofibers can be used for multifarious purposes. Our yarn manufacturing department has recently got a synthetic blow room line, and which will complement our existing natural fiber blow room line. So now we have two blow room lines, and then after those we can produce ring spun yarn samples, rotor spun yarn samples, compact spun yarn samples, and multi-core facet, dual core, triple core, or hard core, or maybe soft core. Every type of yarn we can produce as a sample for the industry in our in-house labs. Weaving, we have the capability to produce fabrics from high performance fibers, carbon yarn, glass yarn, aramids, or high performance other yarns. We can produce 3D fabrics, auxatic fabrics, and we have latest Adobe and Jacquard system available, digital Jacquard. So these are available for research and development, or also for sampling of the industry, and some industry are currently using these on commercial basis. We have all type of knitting machines, starting from single jersey, interlock, rib, and socks, sweaters, and gloves. Recently, we have got a warp knitting machine as well, because Pakistan lags behind in warp knitting. We are mostly focused on weft knitting in Pakistan, but there's a huge market and product categories in warp knitting which we are missing. So we have got a tricot machine. We also got a compression knitting machine for compression hosiery and compression socks, and whole garment knitting machines. So whole range of knitting products, because knitting is the topmost product which is exported around the world. Non-woven, Pakistan also lags behind in non-wovens, and we have a pilot plant of needle punching and thermal bonding line, and we can do sampling for the industry if they are interested in exploring new businesses, non-wovens. We can provide them the R&D and sampling facilities. In dyeing, printing, and finishing, we have a whole range of sample dyeing and printing machines. Our latest addition is the digital printing and ozone fading. So ozone and mist treatment of denim, or you can say sustainable denim sample development, we can help because we have got latest Italian machinery for the garment wet processing and garment dry processing of denims. We have different softwares for your design needs of textiles and fashion designing. And in garment manufacturing, we have, I think, only one in Pakistan, 3D body scanner. So if somebody just stands in the scanner, the body measurements will be taken automatically. We have computer-aided designing, digitizing and plotting, and every type of sewing machines for sampling needs of the industry. Our composite manufacturing lab is one of the best in Pakistan, and we serve not only the sports composite sector, but also the defense composite sector or aerospace composite sector. We have different types of composite manufacturing facilities: resin transfer molding, injection molding, vacuum bag molding, composite cutter, sample profile cutter, etc., etc. And currently, we are giving services to different organizations in composite manufacturing. Our garment comfort testing lab is one of the best in the world, and we have every type of comfort testing instrument in our lab, including fabric touch tester, different modules of Kawabata evaluation system, and fabrometer. And if our industry is moving towards value-added garments, especially high-end fashion and fashion apparel, then the sensorial comfort and thermophysiological comfort property will be very, very important. Also for sportswear. So we can objectively measure in numerics the softness values, stiffness, bending rigidity, roughness values, slippery-ness, smoothness, evenness, compressibility, resilience, etc. And we are offering services to different types of industries. Again, this thermophysiological comfort is very important for sportswear, especially for our Sialkot sector and other sectors which are working on workwear and sportswear. Air permeability, water vapor permeability, moisture management, thermal resistance, thermal conductivity, warm cool feeding, and drying rate is very important. And we have just got delivery of thermal mannequin, so we can test all types of thermophysiological comfort properties. Mechanical comfort, stretch recovery, shape retention, etc. Recently, there has been increasing interest in antimicrobial textiles. So we have developed the facility for testing quantitative as well as qualitative antimicrobial tests. So if you want to develop any products in antimicrobials, then we can be helpful. Similarly, we have a testing facility for UV protection testing. We also develop nano particles for UV protection testing. So not only the material is available with us, but also its complete testing. For heat and fire resistant textiles or highly value added textiles, and there are very limited industry in Pakistan which are doing the work on heat and fire resistant testing. And we have limiting oxygen index tester, vertical flammability, horizontal flammability, also cone calorimeter. And cone calorimeter, I think this is the only one in Pakistan which we have just got. It is going to be installed very soon, and we have got its delivery. It's a very comprehensive testing equipment for testing the fire resistant properties of textiles and other materials, as well as composite materials. Cut resistant, whether you are going to develop a stab resistant vest or a cut resistant gloves, we have facility for testing. Similarly, compression hosiery testing, we have the facility. For composite testing, we have German machinery, which is state-of-the-art universal tensile testing machines. Then we have different other analytical tests such as differential scanning, calorimetry, TGA, TMA, DMA, etc. All types of physical mechanical testing, which is ISO certified, accredited lab. In analytical testing, we have XRD, scanning electron microscope, particle size analyzer, zeta potential analyzer, etc. And we can also now test restricted substances We have got gas chromatography and HPLC atomic absorption for testing the restricted chemicals which are not allowed to be used in textiles. Our key research areas include functional textiles, smart textiles, medical textiles, military apparel and protective textiles, textile reinforced composites, performance sportswear, automotive textiles, nanofibers and nanoparticles, sustainable textile production. And these are examples of few products. We have recently developed antimicrobial fibers and banana fibers, electrospun nanofibers for filtration, and wet spun tri-component polysaccharide fibers for wound dressings, 3D auxatic structures for ballistic applications, carbon woven fabrics for aerospace applications, 3D woven ship structures, parachute structures for maritime technology complex, comfortable compression hosiery for diabetic patients, 3D spacer fabric for seats and mattresses, and dyeing or processing with minimum amount of water. And these processes are commercialized and currently being used in two of the largest textile mills in Pakistan. We are also doing work on smart helmets, sports composites, composite furnitures, biodegradable sport plate, development of nanofibrous blood vessels, expert system for clothing ease protection, and multifunctional nano finishing. I thank you all very much for your patient attention. Thank you. Allah Hafiz.
Thank you very much, Professor Dr. Tanveer Hussain, for such an insightful presentation and showcasing the NTU capabilities and facilities. Our next speaker is Mr. Shahid Sattar. He is an Executive Director and Secretary General of All Pakistan Textile Mill Association, APTMA, the largest exporter group in the country. He has previously served as a member Planning Commission of Pakistan and advisor to the Ministry of Finance, Ministry of Petroleum, and Ministry of Water and Power. He will speak about challenges to the textile industry and the way forward. Sir, please.
Thank you very much, Dr. Saab. I'm really grateful आपने ये मौका दिया मुझे to speak. I don't really have much to contribute in terms of technical textiles, लेकिन I can certainly highlight the issues that we face. So, can I share my screen, please?
Yes, sure, please, sir.
क्या कर रहे हो? जी मेरी स्क्रीन आ गई नजर से?
जी सर, बिल्कुल आ गई। स्लाइड
जी
कर लेंगे तो ये और बेहतर हो जाएगी।
सॉरी, इसको क्या करूं सर?
स्लाइड शो पे कर लें सर।
स्लाइड शो पे करूं?
डिस्प्ले सेटिंग्स के अंदर अगर आप जाएंगे तो वहाँ पे स्लाइड आ जाएगी, या शायद शॉर्टकट होता है F5। जी प्लीज।
ये क्या किया? जी, is this better now?
This is perfect, sir. Please continue.
An overview of the textile sector, 8.5% share in GDP. Our export share has actually recently gone up from 60 to about 65 because other sectors have not been doing as well as the textile sector. 40% of the manufacturing sector employment. 15 million is actually an old number. The latest number I got from ILO is something like 29 million people are now working directly in textiles. And then if we, again, we have backwards, forward linkages. One linkage that is very important, which people miss, is that textiles is the user of cotton. Or cotton जो होती है, that actually distributes income and wealth to the poorest of the poor. उसकी वजह ये है कि जी जब भी picking होती है cotton की, that is carried out by women and very poor women at that, or as which is basically a support mechanism for the most disenfranchised class in Pakistan, which is women and poor women at that. Or one of the tragedies that has occurred because of the cotton crisis that we are facing is that we are not being able to support this the poor women of Pakistan as we should be. Again, the textile industry installed capacities ये हैं. उसके बाद एप्टमा के बारे में ये है जी कि we are the premier textile industry association. We were established in 57, 300 members, etc., etc. उसके बाद आ जाएं जी कि what happened, why, what are we talking about? बाकी मुल्कों के जो है ना exports have increased very exponentially, whereas our exports, if you can see, have been stagnant for at least 10 years. I mean, around the same figure. So something drastic is wrong and needs to be corrected. And the challenges and way forward, I've sort of classified them in this manner. So the first of that is uncertainty. हमारा इकोनॉमिक बिजनेस एनवायरनमेंट अनरिलायबल है. आज गवर्नमेंट एक फैसला करती है, कल कुछ और करती है, then third day they change it again. So we again we are not able to forecast what the environment, economic, or the fiscal incentives or the economic incentives will be. So, and that is actually an absolute must. अगर आपने investment करनी है, investment decisions do not happen on the basis of policies that last for 3 months or 6 months. So these investment decisions are taken on long-term policies and long-term stability. The second is lack of implementation of policies and delays in decisions. देखिए, जो policies आई भी हैं, हमारे टेक्सटाइल पॉलिसीज दो जो पिछली बनी है, उनमें इम्प्लीमेंटेशन की शरह 10 से 15% है, which means कि वो ना ही बनाते तो बेहतर था. और so whatever policy is made, that policy has to be implemented, and also that the ताकि जो investors हैं और जो textile sector है, they can look forward to a firm set of rules they can play by, which will allow them to invest, expand their production, expand their product profile, and so forth. Again, high compliance cost. SMEs जो हैं, उनको लिए compliance with the myriad rules, regulations, taxes, and so on is a real headache. और वो compliance करना उनके लिए बहुत मुश्किल है. And especially after this ये जो tax लगा है, sales tax, उसके बाद compliance सिर्फ उसकी compliance के लिए a lot of textile factories and mills have had to hire accountants or gone to consultants, and not all consultants and accountants play by the book. So or ये compliance is not only in that way. Compliance also means compliance with आपके social rules, regulations, COVID के regulations, आपकी employment के ऊपर, minimum wages and all that. So then the other thing is कि turnover tax जो है, bulk of our industry faces 1.5% turnover tax on each stage of manufacturing. Vertically integrated units जो हैं, उन पे ये 1.5% एक ही दफा लगता है. जो आपके SMEs हैं, वो तो they are spinners, weavers, dyeing, finishing, garmenting, whatever, उनके तो हर stage पे लगता है. तो जो product एक चेन में से निकल के जाता है वो 8% ऑन एवरेज ज्यादा महंगा होता है बनिस्बतन आप उनसे लें जो कि वर्टिकली इंटीग्रेटेड है. दिस इज ओनली द इम्पैक्ट ऑफ द 1.5% टर्नओवर टैक्स. इसके अलावा भी जो बड़े खिलाड़ी हैं उनको सब्सिडाइज क्रेडिट भी मिलता है, उनकी कंप्लायंस भी आसान होती है, एंड they also get access to various other things which the SMEs do not get. So basically game सारी SMEs को support करने की है if you want a real impact on the economy of Pakistan, because आपकी bulk of your employment is generated in the SME sector. Again, red tape and corruption, I need not speak about that. The poor legal enforcement. हमारे यहाँ एक जो सिविल केस है उसकी जो उसको हद तक पहुंचाने में कई साल लग जाते हैं. यू नो जो फॉरेन इन्वेस्टर्स हैं वो तो इस चीज के लिए इंतजार नहीं करेंगे. इवन लोकल इन्वेस्टर्स are unable to enforce their contracts, and which is a big no-no for any investment scenario. SMEs को के बारे में मैंने कुछ दिया जी. 90% of total enterprises are SMEs. 38% of contribution to GDP is through SMEs. 25% of exports and 80% non-agricultural labor force is employed in the SME sector. This is the importance of SMEs. Next, again, I've spoken a little bit about this before. SMEs की क्या challenge है? Financial problems हैं. Access to subsidized credit is very limited. Government schemes are not supportive. High compliance costs. Banks are reluctant to extend loans to SMEs. Banking in Pakistan is now in private hands. और वो private sector वाले, they only lend to those concerns who actually don't need the money. जो SME sector जिसको पैसे चाहिए होते हैं उसको तो पैसे lend नहीं करते. So we need to evolve a system whereby the SME sector gets a fair share of the credit. उसके लिए हमने सजेस्ट ये किया था कि गवर्नमेंट मैंडेटरी कर दे हर बैंक को कि एसएमई और सेक्टर को एक सर्टेन पोर्शन ऑफ देयर पोर्टफोलियो वो लेंड करें. लेकिन उस पे स्टेट बैंक के रिजर्वेशंस हैं कि जी हम मैंडेटरी नहीं बना सकते इस किस्म की चीज. बट आई थिंक वी स्टिल नीड टू वर्क ऑन इट, ऑन हाउ वी कैन enable SMEs to access credit in a better way. Excessive paperwork hai, access to market. SMEs ko again market access karne mein I mean they are all part of a chain, so they are not they don't have the ability to go into the international markets or even in the local markets and find out exactly and they what is required and to make changes to their production lines or products. And then SMEs do not register their products for copyrights, trademarks, patents, and so on. This is partly because of lack of knowledge and procedures. Again, if the government wants to support the SMEs, they should set up a dedicated cell which should help the SMEs to do all these things. Again, lack of systems and procedures. And again, these are all things I think which everybody understands, so I don't need to go into them. Then lack of skilled labor, and then employees high turnover ratio. SME sector में जो बंदा ट्रेन हो जाता है उसको हमारे बड़े लोग जो हैं वो फौरी तौर पे एम्प्लॉय कर लेते हैं. तो एसएमई में इसलिए टर्नओवर बहुत ज्यादा होता है. So all the time they are acting as a training ground for the bigger concerns. The bigger concerns, rather than training their own people, prefer to hire people who already understand the business through working in the SMEs. Large enterprises में जो problem इस वक्त identified हैं, which is the expensive supply of power. 30 to 40% of conversion costs are energy related, and उसके बाद delays in funds from in FBR. ये सेल्स टैक्स के ऊपर पिछले सालों में तो कई साल, कई महीने, कई व्हाटएवर नहीं मिलते थे. अब बहरहाल सिस्टम कुछ बेहतर हो गया कि फास्टर के थ्रू आपको पेमेंट हो जाती है, लेकिन उसमें भी इफ यू एनालाइज व्हाट्स हैपनिंग, दैट तकरीबन 70-80% वो क्लेम पे करते हैं, बाकी को डेफर कर देते हैं टू बी सेटल्ड यू नो थ्रू मैनुअल interventions, और वो कभी होता नहीं है. So ultimately what is happening is a large amount of money is being withheld by FBR from the sales tax that is collected, which by right should have been repaid to the enterprises. Again, हमारी जो companies हैं उस तरह, then even our large enterprises, उनकी जो product sophistication and diversification और markets में जो इतनी ज्यादा नहीं है जितनी होनी चाहिए. If you, sorry, if you analyze the innovation index, Pakistan is one of the lowest in the innovation cycle, और किसी innovation index पे आता ही नहीं है. तो innovation is what drives product sophistication, diversification, etc. So we do need to actually focus on making our workforce more educated with innovative focuses. One of the ways of doing that is supporting, fresh graduates, say from NTU, to set up their own units on niche markets and niche products, rather than going into, working for one of the existing companies. That will expand the base of products as well as, provide more innovative solutions. Again, heightened tariff rates, cost of imports को करती हैं. इसमें सबसे बड़ा जो tariff का मसला है वो आता है हमारा on PSF, on MMF material. इसके ऊपर जो MMF के ऊपर हमारे जो barriers लगे हुए हैं, protection जो दी हुई है Loteco and other plants जो यहाँ पे locally produce करते हैं, उसकी वजह से हमारे यहाँ कभी जो है ये MMF side of the business has never been developed as it should have been. Again, everybody has said this before and will say again, the world market is 70% MMF and 30% cotton. It used to be the other way around 10 years ago. Or as we grow forward, if we stick to cotton, are fighting for a share of a diminishing market, which is not a good thing. So we should be looking at expanding very rapidly into man-made fibers. There is a gas and electricity crisis in Pakistan. The unsustainable tariffs to hain hi, jo we've sort of got them to reasonably competitive tariffs over the last 2 years. But again, इस वक्त शोर फिर मच रहा है कि ये tariffs बढ़ाएं and make our tariffs much higher than our competing nations. If that happens, then our जो हमारी competitiveness established हुई है over the last 2 years, we will lose that very quickly, which would be a pity, because we are at the point where we can take off and actually start contributing significantly to additional employment, additional exports, GDP, and so on. But uske liye hame gas भी चाहिए और हमें इलेक्ट्रिसिटी भी चाहिए. अभी गैस इन्होंने कहा जी हम तो देंगे ही नहीं टू कैप्टिव पावर प्लांट्स. तो देखें, हमारी इलेक्ट्रिसिटी की जो सप्लाई है इज नॉट रिलायबल, उसमें वेरिएशंस भी हैं, उसमें स्टॉपेजेस भी आते हैं, एंड पीपल हु डिड शिफ्ट टू इलेक्ट्रिसिटी बिकॉज ऑफ दिस, ये टैरिफ इन्होंने दिया था 8 रुपए फॉर इंक्रीमेंटल कंजम्पशन, had to very quickly switch back to gas because production losses in those units went up to 10%, which is far more or many times the amount of saving in the energy. So gas supply to the industry has to be assured and continuous and at a rate which is sustainable. अगेन एक और चीज भी हमारे मुल्क में होती है, रेवेन्यू बेस्ड लोड शेडिंग होती है। रेवेन्यू बेस्ड लोड शेडिंग ये है जी कि जिस इलाके में जो जनरली रेवेन्यू कम आता है वहां पे लोड शेडिंग ज्यादा करते हैं। इवन टुडे देयर आर एरियाज ऑफ पाकिस्तान जहां पे 16 घंटे बिजली नहीं प्रोवाइड की जाती, और जो हमारे एसएमईज हैं दे आर नॉट नेसेसरली only in the big cities and big towns and so on. They are also in areas जहाँ पे load shedding बहुत ज़्यादा होती है। तो SMEs do not necessarily or usually have captive power. So SME and cottage industries don't benefit from the lower energy tariffs in government schemes because उनको तो supply मिलती ही नहीं है। Again, I will provide this presentation to all so that you can read it at your leisure. But we have issues on non-tariff measures. We have issues with smuggling. Smuggling, अगर आप markets में जाएं, तो जो आपके products हैं, textile products, if you look at them, so you will find that 50-60% of the products sold in the market are not made in Pakistan. Or when you ask कि जी ये कैसे आए, कहाँ से आए, और रसीद कोई बताए तो कोई दे ही नहीं सकता. One of the methods through how these things come into Pakistan is that on a per capita basis, Pakistan is the highest user of used clothing. 10 times that of India or Bangladesh. It's not possible कि जी हम 10 गुना ज़्यादा per capita इस्तेमाल करते हैं used clothing than India or Bangladesh. So obviously उसमें there is a huge leakage in that trade. And हमने complaint भी किया FBR को, उन्होंने कुछ raids भी किए, कुछ पकड़े भी, थान के थान आ रहे हैं as used, तो थान तो यूज नहीं हो सकता. तो this smuggling का जब तक रोकथाम नहीं होगा लोकल इंडस्ट्री और एसएमई सेक्टर स्पेशली, वो उस तरह प्रोग्रेस नहीं कर सकता. Against compliance costs, we have already talked about those. Then one of the issues that we have is कि Pakistan की cotton production is decreasing on a very severe downward curve. ये एक तरफ मैंने दिया है ग्राफ ऑफ प्रोडक्शन और एक तरफ मैंने दिया है यील्ड पर हेक्टेयर. सो अगेन पीपल टेल मी जी कि इंडिया की यील्ड हमसे कम है, लेकिन यू हैव टू कंपेयर एप्पल टू एप्पल. इंडिया में जो कॉटन काश्त है वो सारी रेनफेड एरिया में होती है, और रेनफेड एरिया की यील्ड वैसे ही कम होती है. So when you want to compare Pakistan's yield, you really have to compare that to those countries which have irrigated cotton production or cotton cropping. And this sort of decrease in yield has been as a result of various failures of government and of the sector as a whole. Because I would say कि जी हमारे APTMA as well as the textile sector has to ensure its production through backward integration into the supply chain. अगर supply chain का आप ख्याल नहीं करेंगे तो ultimately you will have these problems. Again, strengths and opportunities मैंने लिखी हैं इधर, and if we take this into account, we can and we will, इंशाल्लाह, अगर हमारी टेक्सटाइल पॉलिसी अप्रूव हो जाती है अगले 5 साल में, तो in the next 4-5 years we will double our exports and our production. So, but उसमें टेक्सटाइल अपैरल पॉलिसी 2025 जो कि पूरे हमारे पूरे सेक्टर ने मिलके बनाई है, उसकी जो चीजें हैं वो मैंने यहाँ पे लिस्ट की हैं, which is reducing the cost of doing business, financial assistance, sector specific initiatives, capacity building. And capacity building, to my mind, is the most important thing because everything else flows from that. Again, we thought, how best can we increase our exports and our entire chain through a targeted intervention. So we came up with the idea कि हम 1000 garment plants को fund करें, और उनको fund करने के लिए I mean, we provide credit to whomsoever wants the credit. So what basically this will do is very rapidly increase the usage of textiles in the final stage of garmenting. But at the same time, this will also create the pressures for increasing जो back end पे जो सारा आपने yarn, weaving, etc. बनाना है, उसके लिए भी expansion का ये सारा बनेगा. This was just some calculation for the slide shown earlier. And enablers जो हम कहते हैं जो कि are necessary so that we can in the policy 2025, जो कि which I think if given and they are fixed and nobody touches them for 5 years, we will inshallah manage to double our exports. Is if we fix our electricity price, fix our gas price, and increase in production of cotton is necessary. Polyester को हम open करें, free करें इसकी trade को, और protection जो कि दी हुई है हमने वो उसको खत्म करेंगे. The protection on some MMF staple fiber goes up to 18-20%. Obviously, this 18-20% means that basically we are saying no to that particular segment of the international market. Energy की पहले बात हो चुकी है. Liquidity, we say that liquidity should be given, provided to all our sector, and जो existing refunds हैं सारे पे हों, और जो ERF वगैरह सबको मिलना चाहिए. इसी तरह ही LTFF, long term financing, should be given to indirect exporters. Credit limit बढ़ना चाहिए क्योंकि cost बढ़ गई है. Industrial credit allocation policy, जो कि मैंने पहले बात की थी, SME sector को इतना देना जरूरी है, should be reintroduced. उसके बगैर ये हमारे banks जो हैं SME को नहीं lend करेंगे. उसके बाद fast track establishment of textile and apparel parks, and then a special task force, on revival of closed mills. देखिए, setting up new mills takes time. 1.5-2 साल तो कहीं नहीं गए कि नया मिल आप लगाने जाएं, लेकिन जो मिलें बंद हैं लेकिन चल सकती हैं, they should be allowed to open under new management. Same management को नहीं. And again, if no write-off is involved, we are not saying that any sort of loan write-off should be given to these guys. But what we are saying is कि these mills, इनके लिए कोई credit line होनी चाहिए, similar to turf, जो कि project पूरा खरीद के लोग उसको चला सकें. Again, market development is a necessary thing, اور اس میں بہت فوکس کی ضرورت ہے. اینڈ انٹرنیشنل برانڈس جو کہ پاکستان میں ایک زمانے میں they all had offices, now have offices in India and Bangladesh rather than in Pakistan. We need to attract them and to bring them back. This is all basically that I had to say. So if there are any questions, I'm happy to answer.
Thank you, Shahid Sattar Saab, for such a well-explained challenges to the textile industries and their possible potential solutions. For audience, we have a QA session at the end of the session. So keep asking your question to our respectable panelists in QA session by typing your question. So we will ask to the panelists on your behalf. Just we have left with one speaker for this session. So our next speaker is Mr. Ijaz Khokar. He is currently working as Chief Coordinator, Pakistan Ready-Made Garments Manufacturer and Exporter Association. He is also Managing Director of Ashraf Industries in Sialkot. He will share his views on garments-led exports enhancement, challenges and opportunities. Sir, please.
کی طرف سے اور پاکستان ریڈی میڈ گارمنٹ کی طرف سے NTU کا ریئلی ہم اپنی کمپلیمنٹ دیتا ہوں کہ یہ آپ نے ویبینار جو ہے ورچوئل ویبینار یہ ارینج کیا. یہ بہت اس وقت ضرورت ہے ملک کے لیے کہ فزیکل ہماری سٹنگ تو نہیں ہو سکتی, لیکن یہ جو ہم نے اس طرح کے سلسلہ اگر کنٹینیو رکھے تو آئی تھنک اٹ ول ہیلپ دا انٹرپرینیور کہ وہ اپنے جو ہے ایشوز ان کو ایڈریس کر سکے. سر میرا سبجیکٹ جو ہے آپ نے مجھے چوز دیا ہے چیلنجز اینڈ ڈیولپمنٹ آف دا گارمنٹ انڈسٹری. سب سے پہلے تو یہ ہے کہ جو بھی پالیسی بنتی تھی وہ ٹیکسٹائل پالیسی ڈکلیئر ہوتی تھی, لیکن اس دفعہ گورنمنٹ نے ہماری اپیرل سیکٹر کو امپورٹنس کو دیکھتے ہوئے انہوں نے جو پالیسی بنائی ہے اس کو ٹیکسٹائل اینڈ اپیرل پالیسی ڈکلیئر کیا ہے. دس از دی بگ اچیومنٹ کہ اپیرل جو ہے وہ مین فوکس میں آئے ہیں, کیونکہ ٹیکسٹائل از اے کوائٹ لارج سیکٹر. اس میں سے جو سب سے زیادہ ہے دیٹ از اے ویلیو ایڈڈ سیکٹر وچ از اپیرل. اپیرل از دی انجن آف ہول ٹیکسٹائل چین. اگر یہ انجن سٹرونگ ہوگا تو پوری بیک اپ چین کو پل کرے گا. تو اس کے علاوہ یہ سب سے زیادہ ٹیکس پیئر ہے, امپلائمنٹ بھی سب سے زیادہ دے رہا ہے. تو ہماری پی ایم صاحب سے جو میٹنگ ہوئی تھی اور راک داؤد صاحب سے, انہوں نے ریئلائز کیا کہ ہمیں اپیرل سیکٹر کو اسٹرینتھن کرنا ہے جس کی 90% SME ایک اسٹرینتھ ہے, اور جب تک 90% فل فلیج اس پہ رول اپنا پارٹیسپیٹ نہیں کرے گی, ہماری جو ٹیکسٹائل کی ابھی ڈاکٹر تنویر صاحب نے کہا کہ چائنا کا شیئر اتنا ہے اور پاکستان کا صرف $6 بلین ہے. ہمیں اس کی طرف دیکھنا چاہیے کہ کیوں $6 بلین پہ ہم اٹک چکے ہیں. پاکستان جو جس کے پاس کاٹن کا 4th لارجسٹ ڈکلیئر بھی کرتے تھے, اگر ہماری اس دفعہ کاٹن اتنی نہیں ہوئی لیکن still we have a certain position in the cotton growing countries. تو ہمیں دیکھنا ہے کہ پہلے انالائز کرنا پڑے گا کہ ہماری کیوں ایکسپورٹ جو ہے 6 بلین سے کراس نہیں کر سکی since last many years. اس کے لیے ہمیں سب سے پہلے جو ہے ریالٹی ہے وہ یہ ہے کہ ہمیں اپنی پروڈکٹ باسکٹ کو انلارج کرنا پڑے گا, ہمیں اپنی پروڈکٹ لائن کو ایکسپینڈ کرنا پڑے گا. اس وقت ہمارے پاس جو پروڈکٹ ہیں دیٹ از ویری لمیٹڈ ہے. ہمارے پاس ڈینم ہے, ہوم ٹیکسٹائل ہے, ٹاول ہے, اور ہم جو چیزیں بنا رہے ہیں وہ بیسک چیزیں ہیں گارمنٹس میں. اب ہمیں اپنی انڈسٹری کو نیکسٹ لیول پہ لے جانے کی ضرورت ہے, یعنی کہ گارمنٹ انڈسٹری کو ہم نیکسٹ لیول یہ میں کہتا ہوں کہ ہمیں اب کیجول ویئر, فیشن ویئر, چلڈرن ویئر, لیڈیز ویئر, جب تک یہ چیزیں ہم ایڈ اپ نہیں کریں گے اپنی انڈسٹری میں, ہماری ایکسپورٹ جو ہے $6 بلین سے کراس نہیں ہو سکتی. دس از ون تھنگ. اس کے لیے وی ہیو گیون اے ویری سالڈ پرپوزل جس کو ٹیکسٹائل پالیسی میں انہوں نے پلیس بھی کیا ہے فار نیکسٹ 5 ایئر کہ کس طرح ہم اس کو ایکسپینڈ کر سکتے ہیں. سیکنڈ ہمیں جو چیلنج ہے وہ یہ ہے کہ ہماری ٹیکسٹائل انڈسٹری نے جو اس وقت G3 G4 ٹائپ کے لیٹسٹ مٹیریل ہے لائک فنکشنل فیبرک ٹیکنیکل فیبرک وہ ہمیں پرووائڈ نہیں کر رہے. اس کے لیے ہمارے پاس کوئی چوائس نہیں ہے ادر دین کہ ہم اس کو امپورٹ کر کے ری ایکسپورٹ کریں. جب تک ہم نے یہ پرپوزل بھی دی ہے گورنمنٹ کو کہ جب تک ہماری انڈسٹری لوکل ٹیکسٹائل انڈسٹری اس پوزیشن میں نہیں آتی کہ وہ ہماری جو ورلڈ ڈیمانڈ ہے وہ فیبرک ہمیں دیں بنا کے دیں تاکہ ہم لوکل مٹیریل یوز کریں, تب تک کے لیے ہمیں امپورٹ کی سافٹ امپورٹ پالیسی فار ری ایکسپورٹ پرپز ہمیں فیسیلیٹیٹ کریں تاکہ ہم اپنا شیئر جو ہے مارکیٹ پہ جو کسٹمر ڈیمانڈ کرتا ہے اس کو ہم فلفل کر سکیں. دس از دی اونلی وے کہ ہماری ایکسپورٹ بڑھنے کے چانسز ہیں. میں ایک مثال دوں گا کہ آج سے 20-25 سال پہلے شرٹ پاکستان میں بہت ایکسپورٹ ہوتی تھی. آج شرٹ کی کوئی یونٹ ایسا نہیں ہے میں نے پاکستان میں دیکھا کہ جو شرٹ بنا کے ڈومیسٹک مارکیٹ میں تو آ رہی ہے لیکن ایکسپورٹ میں there is none of any factory which producing the shirts اور وہ ایکسپورٹ کر رہے ہوں. The reason کہ شرٹنگ مٹیریل ہمارے یہاں نہیں بن رہا, اگر بن بھی رہا ہے تو چند کمپنیاں چند ملیں بنا رہی ہیں اور وہ اتنا کاسٹلی ہے کہ ہم اس کو ایکسپورٹ نہیں کر سکتے. ہمیں کمپیٹیٹو رہنے کے لیے ہمیں فارش سے ٹائم بینگ تھوڑے عرصے کے لیے جب تک ہماری ملیں اس قابل نہیں ہوتی ہمارے پاس مٹیریل آنے چاہیے. کسٹمر کی ہمیں مارکیٹنگ کرنی ہے کسٹمر کی چوائس کے اوپر, نہ کہ ہم اس کو اپنا کہیں کہ ہم کاٹن بیس کنٹری ہے ہم کاٹن میں دے سکتے ہیں. ابھی شاید ستار صاحب نے بھی کہا کہ جو آج سے 15-20 سال پہلے 70% کاٹن کے پروڈکٹ مارکیٹ ہوتے تھے 30% مین میڈ کے, اب ریورس ہو چکا ہے. اس کے علاوہ جیسے انہوں نے کہا کہ مین میڈ فائبر میں ہمیں امپورٹ کی اس کے اوپر جو انہوں نے امبارگو لگایا ہوا ہے کاؤنٹر ویلنگ ڈیوٹی لگائی ہوئی ہے پروٹیکشن میئرز کے وہ آف ہونے چاہیے کیونکہ جتنی ہمیں کمپیٹیٹو مین میڈ فائبر ملے گا لوکل انڈسٹری شاید یہ چیزیں بنا کے گارمنٹ اپیرل انڈسٹری کو کمپیٹیٹو دے سکے اور تاکہ ہم اپنا شیئر انکریز کریں. نمبر 3 اس کے علاوہ ہمیں سکل کی ضرورت ہے, سکل ورکر کی. ہمیں مڈل مینجمنٹ کریٹ کرنی ہے جو کہ اس وقت SME کے جو میجر شارٹیج ہے کہ ان کے پاس نو ہاؤ نہیں ہے, فیکٹری فلور مینیجر نہیں ہے اچھے جو کہ ان کی پروڈکشن کو سٹریم لائن کر سکیں. ہمیں اپنی پروڈکٹیوٹی کو انہانس کرنے کے لیے ہمیں ایجوکیٹڈ ورک فورس کی ضرورت ہے. ابھی ریسنٹلی وی ہیو وزٹڈ سری لنکا ود دا PM ڈیلیگیشن. وہاں کے ہر ورکر, ایک تو یہ ہے کہ وہاں پہ 80% وومن جو ہیں وہ اپیرل انڈسٹری میں کام کر رہی ہے اور ایوری ون از اگر دیکھا جائے تو 90% مور دین 90% ایوری ورکر از اے او لیول پاس. اس کا فائدہ یہ ہے کہ وہ لیٹسٹ مشینری کو بڑا ڈیلیگیٹلی ہینڈل کرتے ہیں, اس کی مینول پڑھ کے اس کو آپریٹ کرتے ہیں اور اس وجہ سے ان کی پروڈکٹیوٹی ہمارے پاکستان کے ورکر سے ایٹ لیسٹ 60% ہائی ہے. دس از اے ویری امپورٹینٹ کہ ہم اپنے پریگمیا اس میں ایک پرو ایکٹیو رول پلے کر رہی ہے کہ ہمارا ایک انسٹیٹیوٹ ٹیکنیکل ٹریننگ انسٹیٹیوٹ کراچی میں ہے, ایک لاہور میں ہے اور تھرڈ ون وہ ان سیالکوٹ, تاکہ یہ جو ایریاز ہیں یہاں پہ ورک فورس جب تک ہم ایمپل کریٹ نہیں کریں گے, اگر گورنمنٹ کہتی ہے کہ ہمیں 1000 فیکٹری نئی پالیسی میں انہوں نے پرویژن رکھی ہے لگانے کے لیے, لیکن 1000 فیکٹری میں اگر 500 مشین ہے تو آپ جسٹ اس کو آپ فوکس کریں کہ ہمیں کتنے ہزار لیبر جو ہے وہ ٹرین کرنی ہے. فیکٹریاں چلتی ہیں ورک فورس سے, نہ کہ مشینیں انسٹال کرنے سے. تو دس از اے ویری امپورٹنٹ سیگمنٹ کہ ہمیں ورک فورس کو جتنا ہم ایکسپینڈ کر سکیں, جتنا ہم ان کو رورل ایریا سے لوگوں کو لا کے ٹریننگ دے کے ان کی فیکٹریاں لگائیں تاکہ وہ پروڈکٹیوٹی اگر انہانس ہوگی تو آپ کمپیٹیٹو ہوں گے, آپ کی ایکسپورٹ بڑھے گی. نیکسٹ چیلنجز جو ہے وہ ہمیں مارکیٹنگ کا ہے. مارکیٹنگ دیر از ایمپل آف دی ورڈ کہ جس کو ابھی تک ہم نے ایکسپلور نہیں کر سکے. ایوری ون از جو بھی پروڈیوس ہوتا ہے وہ آپ کو ایوری بڈی لسننگ می, ہلو آپ سن رہے ہیں, آواز میری آ رہی ہے آپ کو؟ جی
جی بالکل آپ کی آواز آ رہی ہے.
اچھا, تو وہ کہہ رہا تھا کہ ہمیں نئے مارکیٹنگ کو ایکسپلور کرنے کی ضرورت ہے, نئے کنٹریز کو ایکسپلور کرنے کی ضرورت ہے. اس میں ہم نے گورنمنٹ کو ایک سجیشن دی ہے کہ ایک ریس کریٹ کریں ود ان اے لوکل مینوفیکچرر, کہ ان کو اٹریکٹ کرنے کے لیے کہ جو نئے پروڈکٹ بنا کے ایکسپورٹ کریں گے ان کو آپ ایٹ لیسٹ 2-3% ایکسٹرا بینیفٹ دیں ان کو, تاکہ وہ اٹریکشن ہو اور دوسری فیکٹریاں بھی جو ہیں وہ نئے نئے پروڈکٹ ڈیولپ کر کے مارکیٹنگ کے لیے لے کے آئیں. دوسرا یہ ہے کہ جو نئی مارکیٹ میں ساؤتھ امریکہ ہے اس میں کئی ایسے کنٹریز ہیں جہاں تک ہم اپنا اپیرل کو ایکسپلور نہیں کر سکے, مارکیٹ نہیں کر سکے. اور سیکنڈ سجیشن اس کے جو نئے پروڈکٹ کے علاوہ جو نئی مارکیٹ میں ایکسپورٹ کرتی ہے کمپنی, اس کو بھی آپ تھوڑا سا اٹریکشن دیں تاکہ وہ وہاں پہ جا کے دوسرے بھی ہیں ان کو اگر اٹریکشن ہوگی تو اس طرح پاکستان کی ایکسپورٹ ان ملکوں میں جائے گی جو کہ آلریڈی جہاں پہ نہیں جا رہی. اس کے علاوہ ہمیں R&D پہ بھی توجہ کرنے کی ضرورت ہے. ہم اپنا پریگنیا میں R&D سینٹر اسٹیبلش کر رہے ہیں جس پہ ہم SME کے جو لوگ اپنے ہاں افورڈ نہیں کر سکتے R&D کے سیکشن, ان کو پریگنیا فیسیلیٹیٹ کرے گی. اس کے لیے ہم نے ایک ڈیزائن اسٹوڈیو اسٹیبلش کیا لاہور میں یونیڈو کے اسٹاف مل کے, تاکہ لوگوں کو برانڈنگ میں ہم لے کے آئیں. برانڈنگ بھی بہت ضروری ہے. یہ ایک SME کے لیے شاید بہت بڑا ایک ہوا ہو کہ بھائی کیسے برانڈ بنانا ہے. ہم نے ایجوکیٹ ان کو کرنے کے لیے ڈیزائن اسٹوڈیو بنایا جس پہ ہم ان کو لیٹسٹ ڈیزائن کر کے دیں گے. اپنے اگر کسی کے پاس کوئی آپشن آتی ہے اسپورٹس ویئر کی, ہم اس کو ڈفرینٹ آپشن دیں گے, اس کی کاسٹنگ میں اس کو ہیلپ کریں گے, اس کا برانڈ ڈیولپ کرائیں گے, تاکہ SME کو فل فورس کے ساتھ ہم سپورٹ کریں, تاکہ یہ 90% جو اسٹرینتھ ہے پاکستان کی اس کو فیلڈ میں لے کے آئے. اس کے علاوہ ہم نے ایک ریکویسٹ اور بھی گورنمنٹ کو دی ہے کہ مثلا NTU یونیورسٹی سے اور جو ہماری فیشن PIFT ہے لاہور میں, ان کے جو گریجویٹ نکلتے ہیں, our request to the government is کہ جیسے میڈیکل کالجز سے جو بھی اسٹوڈنٹ نکلتے ہیں ان کو ڈگری ایوارڈ ہوتی ہے کہ وہ ایک سرٹن پیریڈ کے لیے ہاؤس جاب کرتے ہیں ہاسپٹلس پہ. تو مائی ریکویسٹ از کہ یہ جو آپ کے ہاں سے گریجویٹ نکلتے ہیں PIFT سے نکلتے ہیں, ان کو مینڈیٹری کیا جائے کہ یہ اپیرل انڈسٹری میں یا جس اگر آپ کے پاس اسپننگ کے نکلتے ہیں یا ویونگ کے نکلتے ہیں تو ان فیکٹریز میں ایٹ لیسٹ ان کو 2 ماہ کے لیے ایک جاب کرنی چاہیے جو کہ پیڈ جاب ہوگی, فری بھی نہیں ہوگی, تاکہ وہ جو نالج ہے وہ ان کمپنیوں کو شیئر کرے. یہ اس سے کافی بہتری آ سکتی ہے میں سمجھتا ہوں, خاص طور سے PIFT کے جو گریجویٹ ہیں اگر وہ فیکٹریوں میں ہیلپ کریں, اپنا نالج شیئر کریں, تو اس سے ہماری ویلیو ایڈیشن جو ہے وہ کافی امپروو ہو سکتی ہے. تو these are the few issues کے جن کو ایڈریس کرنے کی ضرورت ہے ہمیں. جی
سر تھوڑا سا کنکلوژن کی طرف ہمیں جانا پڑے گا, ہم we are running short of time please sir.
جی تو I think these are the basic issue. میں فیکٹ اینڈ فگر سے نمبر گیم میں نہیں جانا چاہ رہا تھا. میں نے گراؤنڈ ریالٹی بتائی ہے کہ جو اس وقت چیلنج فیس ہو رہے ہیں انڈسٹری کو, جو کہ SME کی میں زیادہ ان کے لیے فیور میں ہوں کہ ان کو ہم فیلڈ میں لے کے آئیں तो ये जो ग्राउंड रियलिटी आपके साथ जाहिर की है, इन इश्यूज को अगर एड्रेस करना हम शुरू कर दें, हमारी एक्सपोर्ट तब बढ़ेगी। मशीनें लगाने से नहीं बढ़ेगी, पॉलिसी की अगर ट्रू स्पिरिट में इसकी इम्प्लीमेंटेशन होगी तब जाके बढ़ेगी। और उसके लिए सबसे बेहतर जो है कि स्टेक होल्डर के साथ जितना लाइजन स्ट्रांग होगा तब जाके इंडस्ट्री की ग्रोथ होगी। So that are my suggestions, and again I'm very grateful for NTU to holding this seminar. So thank you very much for giving me opportunity to present my viewpoint to, this webinar. Thank you very much, sir.
Thank you, Jasper. Thank you very much. As we are running short of time, we will ask only one question to the Ijaz Sahab and one question to the Shai Sattar Sahab, and we will expect a very brief answer. So my first question on behalf of the audience is to the Ijaz Sahab. Currently, a government is supporting textile industry very aggressively, especially the governments and the apparel, as you mentioned as well. So how do you forecast the government export can be enhanced, and to what extent, please?
देखिए जी, इस वक्त अपॉर्चुनिटी बहुत ज्यादा है। पाकिस्तान इस वक्त बड़े लाइमलाइट में आया है, खासतौर पे कोविड के बाद। ऑल द मेजर ब्रांड जो सोर्सिंग कर रहे थे मेन कंट्री से, चाइना से, अब वो फोकस कर रहे हैं कि उनकी सोर्सिंग जो है वो डाइवर्ट हो, एटलीस्ट 2 to 3 सोर्सिंग कंट्री बनाना चाह रहे हैं। उसमें पाकिस्तान की अपॉर्चुनिटी बहुत ज्यादा है। हमें सिर्फ ये इंश्योर करना है कि जो इस वक्त डिमांडेड फैब्रिक्स हैं वो पाकिस्तान में उनकी अवेलेबिलिटी इंश्योर करनी चाहिए। और वो एक ही सूरत में है कि हम टेम्परेरी इंपोर्ट करके फॉर एक्सपोर्ट पर्पस के लिए काम करें। इस वक्त ब्रांड जो है पाकिस्तान की तरफ काफी बिजनेस डाइवर्ट करने की जरूरत है, खासतौर पे जीएसपी जो मिला हुआ है। और इसके अलावा जो हमारे यहाँ डेवलपमेंट हो रही है, पॉलिटिकल डेवलपमेंट भी, हमें पॉलिटिकल डिप्लोमेसी को भी इनहांस करने की जरूरत है। हमें अपने हमसायों के साथ अगर करें, एशिया इज अ वेरी बिग मार्केट, वहां पे हमें एक्सप्लोर करने की जरूरत है। और अगर मटेरियल हमारे पास लेटेस्ट आने शुरू हो जाए तो आई थिंक पाकिस्तान के बहुत बेहतर चांसेस है। थैंक यू।
Thank you so much. The next very brief question to Shai Sattar Sahab is that, as you mentioned about innovation could be the way forward for textile industry. So how an industry can be an research and innovation based industry, and what are the expectations of industry from academia? Sir Shai Sattar Sahab. Shai Sattar Sahab, if you can listen, so please answer, or we may pass. I think he's not available yet now. So we conclude the session, and we will have a quick 5 minutes break, and then we will back to our first technical session around 11:15, please. So we will have a 5 minutes break.
Hello.
Yes, Professor Wang.
How are you?
Yes, fine. Thank you very much for joining us. So your screen has been shared.
Yeah, now let me stop the sharing now. I'm just trying to see if I can share it. So it seems to be working, which is very good. Yeah, so you can hear me okay?
Yes, yes.
Right, okay. So that's good. That's good. As long as you can hear me okay. So yeah. How many people are actually attending the conference, do we know?
Currently, 187 are present at the moment.
157.
87.
Oh, yeah.
187, and we had more, but due to break, some had left.
You know, that's right. That's a good number.
Yes, there are some people on Facebook and YouTube as well.
Oh, that's a modern technology. Yeah. I noticed that you are recording this. Do you need to record this?
Yes, we are recording this so that if it is needed and if all the panelists they allow, so we will share it with the students, with the audience for their record.
Right, okay. Yeah. So I need to talk for about 20-25 minutes, less than half an hour, right?
Yes.
Right, okay.
So welcome to the first technical session of the 6th International Conference on Value Addition and Innovation in Textile. So our first speaker is Professor Wang. Professor Wang is currently serving as a Pro Vice Chancellor, Future Fibers and Alfred Deakin Professor at Deakin University, Australia. Professor Wang's research interests are primarily in fiber science and technology. He is the 2005 recipient of Fiber Society Distinguished Achievement Award. Professor Wang is a fellow of Textile Institute and the president of Fiber Society in 2015. His today talk will be on waste textiles and color recycling for patient sustainability. Professor Wang, you will have 20 to 25 minutes for your presentation, and we will reserve 5 to 10 minutes for Q&A session, please. So please proceed.
Okay, thank you. Can you, I hope you can see my slides properly.
Yes, perfectly.
Great, okay. So thank you for the invitation to deliver this virtual presentation. I'd like to take this opportunity to share with you some of the recent research activities we have been undertaking in the area of textile waste and recycling, not just the waste material itself, but also the color on the material. As part of recent research, so I'm really pleased to have this opportunity to present this research findings to the audience here. As the chair introduced, I'm from the Institute for Frontier Materials at Deakin University. Deakin University, for those who do not know, is actually located in the state of Victoria in Australia, not far away from Melbourne. It's about 1 hour's distance from our university campus to the CBD, Melbourne CBD. You can see some photos here, not far away from our university campus. The Institute for Frontier Materials is the largest research institute at the university. We have about 180 PhD students and 158 staff members. A large research group undertaking research in different areas that are related to materials, and the fiber and textile is a key part of the institute. So that's just very simple introduction. And coming back to the topic I want to discuss today, just a bit of a reality check. I think most of you probably know already that the textile and fashion sector is the second most polluting industry sector in the world, just behind the petrochemicals. And less than 10% of the textile and fashion items are recycled at the moment. Some say less than 5%. So I've seen figures varying between 1 to 15%. But anyway, only a very small percentage of the waste or old textiles is actually recycled. And in the marketplace, denim is the #1 fashion item, simply because everyone wears a pair of denim, whether it's old people, young people, children, male, female, everyone basically enjoys wearing some denim. So it's a #1 fashion item on the market. Around 2 billion pairs of jeans are sold around the world each year. And many of these denim products are manufactured in developing countries, including Pakistan. So it has created a huge issue in terms of not just the volume of the product, but also in terms of the coloration process for the denim products. A few years ago, we put a proposal to the H&M Foundation for the Global Change Award, and we are very pleased that our proposal went on to receive the Global Change Award, one of the top 5 proposals out of almost 3,000 applications from over 100 countries. And this proposal was about how do we reuse old denim products. The idea is very simple, actually. So we start from an old pair of denim, as you can see on the left-hand side of the screen. And then what we did was to pulverize or convert the whole denim material into very fine powders or particles. So you can see the particles, they have the color of the original or the old denim jeans. And so the fibers are basically grounded into very fine particles, and the particles, of course, still have the color of the original denim waste material. And then we just put the colored powder onto a white piece of fabric so that we have the new white fabric colored, not with the traditional dyeing process, but with the colored particles, more like pigments, right? Like you are coating pigments onto a piece of fabric, except in this case, the pigments are small particles from old denim waste material. So that's a very, very simple idea. So the fiber material and the color are both recycled, if you like, right? So we're using both the color and the fiber material in the waste denim. Here you can see some of the jeans the project team produced. As you can see, each one of those 5 pair of denim jeans were colored. These were colored with these colored particles from waste textiles, if you like. So you can see that. We also worked with we had some help from a commercial denim manufacturer. We supplied them some colored particles from waste textiles, different colors. As you can see that we have the pink color, we have the blue color, and they were put onto white jeans. And you can see that the new colored jeans, they actually have quite good fastness and comfort attributes. Even though the color not as deep as the normal denim, because you are using a surface coating approach, you are putting a small amount of colored particles onto the surface of the fabric. So the color is not as deep as the normal denim product. And you can also make colors, different types of colors. You can see here, different types of color from different types of colored waste. Of course, you can put them onto fabrics. In this case, a company in Melbourne helped us to put those colored particles onto finishing fabrics. As you can see that all these fabrics are colored with these colored waste particles. So that's just one idea of using the waste denim products, recycling not just the fiber material, but also the color that's already on the fiber. So we don't waste the fiber and we don't waste the color. In addition, with this coloration process, we didn't have to use water. So there was no waste effluent problem. And of course, because we didn't have to use the traditional indigo dyeing process for the denims to be colored. So this is one relatively recent work. And of course, there are other options of reusing old denim products. And this is a recent photo that I've seen on TikTok on the streets in China. You can see those. I assume these are old denim jeans, and if that's the case, then that's another way of reusing or recycling the waste materials in a sort of a more fashionable way. And you can even go to the extreme. In this case, this is a web page from Karma Source. Again, I hope this is from the waste denim rather than going into the landfill. You're trying to reuse it again. I actually, a little while ago, I actually went to the web page to see if I can get some samples. And you can see here, it says sold out. So it's actually quite popular for some reason, and quite expensive as well, $168. Might be more expensive than the normal denim. So that's just one other option. But I want to move on to talk about some more recent research in terms of recycling, not just the material, but also the color. In this case, again, we use denim product, a colored one, and then we powder them. In this case, it's not very fine powdering, just like a shredding, right? And then we convert this material into fibers, continuous fibers through the wet spinning process. either to make a white fiber or a colored fiber. And making a colored fiber is more interesting because we don't have to dye the fiber again. And this work was recently reported in several publications, one in the ICS Sustainable Chemistry and Engineering, and the other two in the Journal of the Textile Institute. Both were published online last year. So it's quite recent work. And if you want to see more details of the work, you can go to those publications for details. So I'm only showing you the concept and also the results rather than all the technical details. Here is how we the process flow, the waste fabrics, shredding, and then we have some pre-treatment. Then we have the dissolution and followed by wet spinning. Depending on the sort of pre-treatment, we can either produce white fibers or we can produce colored fibers. And these are, I must say that these are cellulose or cotton fabrics, right? Cellulose waste. So we can dissolve the cellulose and then do the wet spinning again to regenerate the fibers. Here are the raw materials, denim, but we also use other fabrics, pink fabrics with known dye history. So we already know which dye was used, and also fabric with unknown dye history, simply because in a waste textile that you connect, sometimes you don't know what dye process was used to color the fabric. So fabric is with both known dye history and unknown dye history we did the experiments with. And the pretreatment, depending on the nature of the pretreatment, whether it was acid or alkaline, we can get different intensity of colors. The dissolutions, here are some details of the dissolution. We've used a combination of ionic liquid and co-solvent, DMSO, and the polymer concentration used to dissolve basically the cellulose material. And then after dissolution, we have the wet spinning. So this is a typical wet spinning process. We have this just in the laboratories. As you can see that, so we have the coagulation bath, we have the drying unit, the take-up unit here. And here you can actually see the extruded filaments in the coagulation bath, and the drawing or stretching area here, and then the filaments or the fibers wound up onto the bobbin here. The morphology of the fibers produced, as you can see, this sort of, depending on the type of treatment, you do get different morphology. In the alkaline treated solution, you can see that this type of cross-section quite similar to what you will see in a viscose fiber. We have the samples. Here you can see that this is a sort of a red or pink fabric. So this can be your normal waste material, if you like, a colored waste material. And from a colored waste material, we make a colored filament or fiber. A blue colored fabric to blue fiber, a red or yellow fabric, you get this similar sort of color in the fibers. So of course, once you have these colored fibers, you can use the fibers to make fabrics, as you can see on the right-hand side. This is a knitted fabric from the filaments produced in this way, but from a colored waste fabric. So that is the, I think, uniqueness of our work in terms of regenerating a colored fiber from a colored waste fabric. And then you can use the colored fiber to do other things, whether it's knitting or weaving. We also did a color mixing experiment. Interestingly, it's like if you yellow, red, and blue, if you mix the yellow and blue, you get the greenish color in the fiber. If you mix the red and blue, you get the purple colored fibers after the wet spinning. So that is also quite interesting. So you can manipulate the colors by changing the proportion of the color materials that are dissolved for the wet spinning process. We also did the color fastness. We want to know whether the colors would wash off. As you can see that the before and after comparison, there is some small color change, but after washing, the color is still there. And that is understandable because the color is not just on the surface, is in the whole regenerated fiber, all right? So after accelerated washing, the color pretty much stays in there. We think what we have done is only the beginning. I think there's still a lot of work to be done in this area because waste, textile and fashion waste is such a huge problem, and there's a lot of work that is still required in terms of cost reduction. If you use solvent to dissolve the cellulose material, and then the recovery of the solvent is very important to reduce the cost and also to alleviate the environmental concerns. And then the other issue is with blends, because on the market, as you know, most of the textile products are actually blends. Cotton polyester blends in particular are very prevalent. So how do you recycle a cotton polyester blend fabric, for instance, given that it's such a huge amount on the market? So there's a lot of more work to be done. We have done some initial work in terms of fiber blend. So here you can see that we simulated a fiber blend. So you have like a cotton, we have a polyester, and we mix the cotton polyester together. It's like a cotton poly blend in a textile, right? So that's the mixed blend, and then we do the dissolution process. Of course, the cotton or cellulose component is dissolved, but the polyester component is left pretty much intact. So you can see that after this, the cellulose component is dissolved, and then we can use the wet spinning process to do the wet spinning again as before. Interestingly, you can see that the initial color, this color is retained in the regenerated cellulose component. Of course, the polyester, the color stays. So with this, you can separate the cellulose component and regenerate into a colored cellulose fiber, and you leave the polyester component pretty much intact in a pure form. So that is just one initial trial. We did do a lot of other research in terms of trying to separate the cotton polyester blends in a meaningful way. So the work is still ongoing. There's a lot of work that is still required in this area. We also, so I think as I mentioned, I really want just to give you a taste of some of the recent research we have been undertaking in this area. Due to the time limit, I didn't cover all the technical details, but I would certainly encourage you to look at some of the publications on this work. And this is by no means going to solve all the problems we have. We need lots of different ideas of recycling, reusing, repurposing the waste textiles to address this huge environmental challenge faced by the sector. If we can't address the environmental challenge, there is no future. There is no future for this industry if the environmental issues are not tackled. So I just want to leave this message to you, and I would certainly welcome questions if there is any. Thank you.
Thank you very much, Professor Wong. Moving towards the QA session, we received 2 questions from the audience. So
Yeah.
first question is posted by Mia Farooq Mahmood Sahab. He asked to you, do you suggest any strategy to use recycled fibers in ring spinning instead of wet spinning?
Yeah, so the different, you can, the different approaches, there have been work done on a commercial scale in ring spinning of recycled waste. Usually that is mechanical recycling. So you basically mechanically or physically, shred or open the waste down to the individual fiber form. And those fibers will be shorter than the original fiber in the waste material. So normally what you have to do is to mix the waste fiber with some virgin fiber material to facilitate the spinning process, whether it's ring spinning or open-ended spinning. And there has been work done in this space. Some companies are actually spinning waste polyester made from those, bottles, recycled bottles and all that. So that is a different approach. It's a mechanical approach. What I discussed was more of a chemical approach. But as I said, different approaches are required to address this big problem. We need multiple different approaches to address the issues. The uniqueness of what I have just discussed is on the color aspect. So the color is actually retained, and so you have regenerated a colored fiber, which is quite different from conventional wet spinning. You produce a white fiber, and the fiber has to be dyed again into different colors, and the dyeing process can cause issues to the environment. So what was the second question?
The second question is, can we achieve localized effects on these powdered dyed denim easily using conventional techniques?
Yeah, so you can use the screen printing or fabric coating equipment. Yes.
Thank you very much, Professor Wong, and for answering those questions and for a great presentation. It was a pleasure to have you with us. Thank you very much.
Thank you. Thank you.
Our next speaker is Professor Dr. Robin Mann. He is the director of the Center for Organizational Excellence Research at the School of Engineering and Advanced Technology, Industrial Management and Innovation. His research interest includes benchmarking, business excellence, best practices, innovations, and business improvement. He will share his views on fast-tracking productivity in Pakistan via business excellence. Professor Dr. Robin Mann.
Okay, firstly, thank you very much for the invitation, in particular to Dr. Yasser Nawab for inviting me to present at this great conference. Just to say that, first of all, my expertise is not in the textile industry. I mean, I do love wearing denim, as the previous speaker talked about, but I'm certainly not an expert in the textile industry, but I am an expert in sort of business improvement, business excellence, and productivity. I'm just going to share my slides with you right now. Just hold on. Okay, so hopefully you can see my slides. So I'm going to be talking about fast-tracking productivity in Pakistan via business excellence. And so I hope that you can relate this to the textile industry. Just so you know, yeah, I am based in New Zealand and in the North Island of New Zealand. I actually run sort of an institute called the Centre for Organisational Excellence Research. This is actually, just so you know, this is where I live. I've been to Pakistan as well. We've got very dramatic scenery in New Zealand, as you have in Pakistan. So these are the three sort of institutes or organisations I run, which fall under the umbrella of the Centre for Organisational Excellence Research. So we do research on how organisations can become more productive and more successful. I also run a company which shares best practices and sort of innovations in how organisations can improve their performance. And as part of that, we provide sort of best practice reports on specific areas. And for instance, one best practice report that we produced this year was relating to the recovery from the COVID pandemic. Also, in terms of our consultancy, we provide lots of assistance in terms of how organizations can raise their productivity and excellence inside their organization. And we also run major events like the International Best Practice Competition. And this is something actually that is available and open to all Pakistan organizations. So it would be great for anybody listening to this presentation to consider entering their organization for this competition. And it gives you the opportunity to share particular best practice that you have inside your organization, whether it's with respect to your manufacturing process or how you manage your human resources or how you focus on the needs of your customers. So do have a look at that website afterwards, and I hope my slides will be available to you after the presentation as well. One of the other things that I do with my consultancy is work with countries around the world to help them to elevate the performance of organizations with respect to their level of productivity and excellence. So in recent years, well, in 2019, I worked with Bangladesh and Mongolia with their national productivity organizations. And at the end of last year and this year, I've been working with the National Productivity Organization of Pakistan. And so it's been trying to look at how they could provide a greater role in leading the productivity movement in Pakistan, because over time, as I'm sure you're aware, Pakistan's growth rate in terms of productivity has not been as good as we would have hoped. And so this graph is quite complicated, but you can see Pakistan down here, and you can see where Pakistan was in 1970. There's lots of groups of companies at a reasonably low productivity growth rate in the early 1970s. And you can see Pakistan's growth rate in terms of labor productivity has not grown substantially since 1970. Whilst you see other countries which are at a similar level have leapfrogged ahead of Pakistan. So you can see that, for instance, Thailand, which is at a similar rate to Pakistan in 1970, is now almost double the productivity rate. We have exemplar countries like Korea, which was slightly above Pakistan in 1970, but not much better, and is dramatically better currently, and also the Republic of China, Taiwan. So there's obviously something potentially we could learn from those countries in how to raise productivity. We can look at labour productivity, but we can also look at what's called total factor productivity. Therefore, also include the impact of innovation and technology and how that contributes to productivity. And so total factor productivity includes both labour productivity and capital productivity. And you can see here that on this graph, the red graph shows how the growth rate of total factor productivity has changed year by year by year. But on average, it's or the trend is showing that it's declined since the early 1970s. What's interesting is that the growth rate of total factor productivity mirrors the growth rate of gross domestic product. And Pakistan's growth rate for gross domestic product has also, as you can see, deteriorated over time. And this is really an indicator, you know, of the wealth of a particular country. So this shows clearly there is a problem and this needs to be addressed. And I believe the textile industry contributes about 8 to 9% of the gross domestic product for Pakistan. So it's an area that if we can address productivity in the textile industry, it's going to have a major impact right across the country. In simple terms, what is productivity at a very sort of basic level is trying to get more out of a business than you put in. So it's trying to use your resources extremely efficiently so that you can add greater value to your stakeholders. So it's really output over input, trying to achieve more with less. So this is what organizations need to strive to achieve. With respect to, let's just go back to this slide here. Okay, it's a bit difficult to see this slide. I thought that this slide was going to, first of all, show the model behind this square in the center. But what you can see behind this box, which is difficult to see because it's a little bit disguised, but it's what's called a business excellence model. It's a model that organizations can use to understand how to improve their productivity. If I just leap ahead to my other slides, I can show this more clearly. So let's just go to this now. So this is the actual model here. And this model was developed in the late 1980s and was used in the United States to drive its competitiveness in response to the challenge from Japan and Korea. So this model basically describes what an organization should be doing. It should have great leadership inside the organization. It obviously needs a clear strategy, a clear direction of where it needs to go in the future. It's got to have customers, otherwise it's not a business. And so it needs to deliver to the needs of those customers. And obviously those customer needs change over time. So the organization needs to be responsive to those changes. The organization also needs to ensure it has fantastic workforce and people working inside their organization. So it needs to train those people appropriately. It needs to recruit, the best people available and provide recognition and reward to those people so that they stay inside the organization. In addition, an organization needs to have good processes in place. If it's a manufacturing organization or in the textile industry, it needs to have good appropriate equipment for people to be able to do the jobs appropriately. That needs to be maintained appropriately. So there needs to be clear procedures, good technology, and continually innovating to make sure, again, you're responding to the changing needs of your customers. In addition to that, you need to be measuring where you are as an organization in terms of your performance. You need to be measuring your current capabilities in terms of your knowledge of the marketplace and where you can go in the future in terms of your direction. So there needs to be a good information flow between all these various processes. So just in a very sort of couple of minutes, I've outlined really the main attributes or components of an organization for it to succeed. What's interesting is that, I say, you can capture this information through what's called these business excellence models. And these models not only consist of your business enablers to become successful, but also show what your results are too. Your results relate to what you're striving to achieve for your customers. Therefore, you want to have happy customers who come back again and again to buy your products. You need to have good financial results for your shareholders. You need to be making a positive impact on the environment rather than polluting the environment. So you need to be responsive to the needs of the local community. And also you need to have happy people inside your organization so that they stay inside the organization. So results looks across all the stakeholder needs here. So if I go back to that other slide at the beginning of my presentation, which is here, it really reflects what is productivity. I mean, productivity is inputs and outputs. And this is what this model reflects: the inputs, your systems and processes, and the results you achieve. And so from an industry perspective, looking at the textile industry as a whole, we need to be looking at, how strong are the current inputs of productivity inside each organization, and what's the aggregate of those across all organizations, and how can we improve them as an industry so that we improve the outputs, the results. So ultimately, this is what, as an industry, you need to be focusing on, is how can you improve those inputs for every single organization that's operating the textile industry to improve the outputs. And that's how we'll improve the situation for those individual organizations, but for the industry as a whole and for the economy as a whole. So when you're thinking about this and how to raise productivity inside a country, you've got to be thinking about how, for instance, can you help them on, how can you help organizations on that journey? Therefore, how can you bring awareness of good practices? How can you assist them on that journey through providing appropriate training or access to technology or access to relevant support? And then also, how can you recognize outstanding organizations, because they can become role models for other organizations to follow? So in a sense, what you need as an industry is good ways of assessing what the current state of the industry is at. So you need assessment tools to be able to assess how healthy individual organizations are and how healthy the industry is as a whole. And secondly, you need to provide that industry with capability building services, which will be things like conferences like this, sharing best practices, but also maybe more proactive or interventions as well, where you go inside organizations to support them, to assist them to change technology or change their managerial approach. So there are lots of sort of generic types of activities you can undertake to improve an industry. And this is just an example of just lots of different tools and approaches that can be used, from training to conferences, to providing funding for encouraging new innovations in an industry. But what you also need to think about when you think of those models, which are those holistic sort of business excellence and productivity models, is what support are you providing for each component of productivity? Therefore, what are you providing to the leadership of those organizations in terms of assistance? What are you providing in terms of helping them to ensure how to plan appropriately, to deliver value to the customers, etc.? So for each of these elements, you need to put in place for the industry support mechanisms to elevate performance. So just to quickly summarize, from what is a business excellence. I mean, business excellence evolved really from quality management, which then progressed to what's called total quality management, which is really a philosophy of how you manage organizations, and there were certain tools and techniques available to assist organizations become more productive. And then that has evolved further into these business excellence models. And the business excellence models make it very clear, what is productivity and how to improve productivity. So when we talk about excellence, it is about achieving fantastic stakeholder results. This is a prime purpose. You use these models to drive performance, to deliver fantastic results for your shareholders, employers, your customers, and to the community as a whole. And my understanding is that in Pakistan, the understanding of business excellence models is really not there. I mean, there has been some attempts in the past by the National Productivity Organization and various other institutions to raise knowledge of this particular approach, but it's not been successful for a number of reasons, for political reasons. But hopefully in the future, through the work of the National Productivity Organization, or in fact through some leadership from the textile industry, you can help to aid understanding in this particular area. Whilst I describe the model as this, there is a lot more detail to it. So behind those categories, there are category items, and these go into further and further depth in terms of the activities that are expected in order to bring about improvements inside an organization. So really, the emphasis is on educating organizations on these models and how to improve their performance with respect to these models. So they're holistic and they go into a lot of detail. You could also describe these models as like the umbrella within which all of the quality tools and systems fit within. So you can see here, the business excellence is the overarching term. You can see the various categories shown here at the top of this slide. And then you can see various interventions or tools and techniques you can use to improve performance with respect to those various areas. And I suspect that in the textile industry, many of these different individual tools and techniques are used, but they haven't been brought together as an holistic approach. So this is what's most important to do, to make sure you have an holistic approach that's aligned to your strategies of your individual organizations. The great thing about these models is that they can assess the maturity of organizations using a point scoring system. So if we assessed an average organization in Pakistan using this approach, I suspect the organization would score about 150 points or even slightly less against one of these frameworks. This is based on my knowledge of Pakistan companies. You're going to get some organizations which are leading the industry, in the textile industry, and I suspect they'll be scoring around 400 points. For a world-class organization, will be scoring 600 plus points. It's very hard to score higher than 600 points. So the opportunity is to spread knowledge of these business excellence frameworks, get them to be used by organizations, and generally raise the score of those organizations against this framework over time. And in that way, we'll be assured that the productivity of organizations is improving. So there's lots of research done on the use of these models and how they drive improvement. So there's lots of validity about this. There's a lot of credibility. So for instance, this graph here is showing that if an organization improves its management systems and processes with respect to these models, it's sort of guaranteed they're going to improve their stakeholder results. So how do organizations use these models? Well, the easiest way is to be assessed against them. And there are different assessment approaches where you can have experts come in and assess the maturity of an organization, but there are also some very simple self-assessment tools that can be used, which are very simple questionnaires, which can be used, which require no guidance to be used, or there can be more sophisticated, facilitated assessments where they got more rigorous questions, which are asking the organization about what they do and their level of performance. And the whole reason organizations would use this approach is once they've done a self-assessment or an external assessment, It would identify their areas of strength, what they're good at with respect to all those categories, and it would identify their opportunities for improvement. And so once they know that information, they can then put in place action plans and make sure that they're integrated with their strategies for the future. I think there is often a reliance or a thinking in, especially in developing countries, that the biggest solution that's required is technological innovation. Really, that's not the case. I mean, the biggest impact on productivity, the immediate impact, is by having the leadership teams and the senior management upskilling, improving their skills. That has the most immediate effect on improving productivity inside an organization. And later on, through their knowledge, they can introduce appropriate technology and innovation. And, through using these approaches, organizations can get a scorecard, and you can also get a scorecard for a whole industry as well. If every organization or a large cluster of organizations are using this particular approach. So just to summarize, I think a potential approach you could use in the textile industry would be to introduce a facilitated assessment approach where as many organizations as possible are encouraged to assess their level of performance against these models. And those ones which score over, say, a certain number of points, for instance, 300 points, could be then considered or recognized as an excellence class organization. So you could say this is a textile excellence class organization for the textile industry. So with the desire to get as many organizations in the industry reaching that level of performance, and then you'd then work with those organizations for some of them to become world-class and scoring over 600 points. So in this way, you could drive change inside the industry, provide a simple self-assessment tools to assess organizations initially, facilitate that assessment as well to have more accuracy in terms of the scoring, and ultimately for award recognition, you would have really quite a rigorous approach. But this can provide a roadmap. So just to summarize, just 5 minutes, the final five minutes, what the challenge is for the industry or for Pakistan as a whole is that if you have one organization which excels and become world class, that's not going to make a major difference. What you do want is really all of them utilizing this approach. And from a national perspective, schools using this approach, the airline industry is using this approach, the hospitals, the police, all the government and agriculture. And this is how you then start to address the macro issues facing a country if all organizations start using this approach. And this is what's been happening in other countries around the world. So in Singapore, they, for instance, would say that if you can't escape business excellence, every organization will be using this approach to drive improvements from schools all the way to funeral parlors before you die. Every organization will be using these business excellence models. And the beauty about these models is that they support the Sustainable Development Goals. They're heavily aligned to those. So this is a way we can build a healthy, wealthy, and safe and sustainable world. So if you look at the transformation of Singapore, and Singapore is probably the leader in terms of embedding this sort of approach inside their country. You can see Singapore is now in the top 10 in the world for most international metrics. Following their path is United Arab Emirates, which is a huge emphasis on excellence and productivity using this model, where it's mandatory for every government organization to use this approach. And on average now in that industry, most organizations, on average, for most international indicators, the UAE is about 20 in the world now, but in the next 5 to 10 years, for most international indicators, they'll be in the top 10 in the world. And where Pakistan at the moment, as I'm sure you know, is rating over 100 in the world for most international indicators. This is not a bad thing. It means there's a great opportunity for improvement, and you can improve quickly if you use a sensible approach. This is the views of the Crown Prince, of the Prime Minister of the United Arab Emirates. He says the program of excellence and using these models is a driving force for the whole transformation of the United Arab Emirates. And not only once you have these models in place, that they help you to identify best practices right across the textile industry, right across the whole of Pakistan through organizations using this model. And also you can identify best practices then around the world. And therefore you can then use techniques like benchmarking to improve from other countries around the world to ensure that your practices inside your country are become leading edge. So hopefully from this presentation, I will have brought your awareness to this use of business excellence models as a productivity model that could be used inside the textile industry. So my hope is that Pakistan will be the next country to use this approach. Over 70 countries in the world use this as a driver for improvement. So I hope this has been of use. And if you have any questions, I'd be pleased to answer them. Thank you very much indeed.
Thank you, Professor Dr. Mann, for a very comprehensive presentation on fast-tracking productivity in Pakistan via business excellence. We have few questions from the audience. I hope you have already covered their answer, but see if you can add more information for a better and easier understanding to the participant. The first question is posted by Muhammad Harfan. He asked, what solid initiative government is taking to improve the productivity and the middle management trainings to mitigate the requirements of the current and future challenges in both contexts, SMEs and the big apparel and textile units? So see if you can have a better explanation to this one.
Yeah, I can't really answer that from a Pakistan perspective. What I can let you know is that there's an initiative starting this year through the National Productivity Organization to lead the development of a national productivity master plan. And that master plan will engage all the key sort of players in terms of the Pakistan industry to become involved in developing that master plan, but then also implementing it. And obviously a key component of that will be around, you know, the productivity and middle management training.
Thank you very much. The next question posted by Ms. Javeria Beg is very simple. She is interested to know the particular name of this organizational productivity model. I think you already covered, but if you would like to again answer this question.
The model I showed you there is the model which was developed in the United States. It's called the Baldrige Criteria for Performance Excellence. There are two major business excellence models in the world. One is developed in Europe called the EFQM Excellence Model, and the other one is the Baldrige Criteria Performance Excellence. And that is a model, the Baldrige one is the one that's primarily used throughout Asia, and is the one that's been followed in the past by some Pakistan companies.
And thank you. The last question I would like to ask on behalf of our industry. So how can we implement business excellence model in my industry, say any industry? So is there a very brief answer to this question?
I'm not sure there's a brief answer. I think that the simplest way is it would be to do a self-assessment against the model, and there are some simple tools which are just questionnaire surveys for you to do an assessment against this model, which will ask you questions with regards to the various categories of excellence. And just going through that self-assessment will give you an understanding of what business excellence is about. And just going through that assessment will also enable you to think about what practices or interventions you need to put in place to improve your performance with respect to those models. So the models themselves are not prescriptive. They don't tell you what to do. They really ask you questions. But they ask intelligent questions. and then it's encouraging you to find the answers through learning from other organizations or learning from best practices. So for instance, it might ask a question, for instance, what about your work environment, the culture inside the organization. How do you try to retain staff in the long term to make your staff happy inside the organization? And so I'd be asking, what approaches do you have to do that? And if you don't have approaches in place, it's encouraging you to put an approach in place.
Thank you very much, Professor Dr. Mon, for a very comprehensive presentation and a very interactive talk. It was really a pleasure to have you with us. Thank you very much, Professor Mon.
Okay, thank you very much indeed. Thank you.
So our next speaker is Professor Dr. Tahir Hussain Shah. He is currently serving as a consultant and professor of polymeric materials and technical textiles at National Textile University, Faisalabad. He will enlighten us about the impact of COVID-19 crisis on textile education and industry. So please, Professor Dr. Tahir Hussain Shah.
Let me get the slides. How do you go to slides later? Let me get. Trying to. Let me try to get this slides. Trying to share the slides.
Currently, we can see your desktop, sir.
I'm trying to see my desktop. Let me see. Yes, I've got it. It's there now, yeah?
Yeah, if you can make a slideshow, sir, please.
Okay.
Yes, perfectly, we can see a complete slideshow.
See the slides now. Okay. Can I start now?
Yes, please, sir.
Right, thank you very much. I think that was a very revealing lecture by Professor Mann. I think I totally agree with him. I think he's highlighted some of the problems, but I think what he highlighted is there's a great opportunity to do a lot of work in Pakistan at the moment. Okay, so let me get on with my lecture. I think my lecture is very generic. The impact of textile of COVID-19 crisis on textile education and industry, textile industry, especially in Pakistan. Now, my lecture is going to be fairly generic. I think there are 3 or 4 lecturers who are going to talk about more specific areas, like Professor Salih's lecture, Majidullah's lectures on fashion, and also the Dr. Khatri's lecture in the specific impact of COVID-19 on textile industry. Now, I've been following this pandemic for many reasons. Of course, the most important reason is that is having an incredibly hard, sort of strong impact on our lives. Now, let me see the emergence of COVID pandemic has had a dramatic impact on our livelihoods and our lives across the globe. The measures taken to contain the spread of this pandemic to the mortality and the infection has really taken a severe toll on the economics of the whole planet. The virus, after its emergence,
what people say is in China, but that is still to be proven, has spread globally in a short span of time, and within 3 months, it has brought the whole world to a standstill on its knees. Now, the uncertainty, the real extent and duration of this pandemic are causing widespread concerns in all spheres of life. So we are not really certain, where it's heading and when it's we're going to control it. And there are pundits who are saying that COVID-19 will never be eradicated, and therefore we are in it for, at least for our living our lives. This has led to sections of industrial sectors fearing outright economic collapses and ultimately shutdown of the industrial activity, and that is the doomsday scenario. Education, including the textile higher education, has been afflicted by the pandemic, and all the industrial sectors have been affected, including one of the largest sectors, that is the textile sector. The COVID-19 pandemic could trigger the biggest economic contraction in the modern history. In fact, it has already probably has done so. The pandemic has affected all industrial sectors, including textile industry. The governments and industry organizations have increased the awareness levels of workers and developed SOPs for safe working conditions. Some industries have taken initiatives to reduce the number of workers to ensure social distancing, provide additional transportation services to the same, to work, and temperature measurements and hand washes, and of course, cleanliness have become probably norm, especially in the more developed countries. Distribution of PPEs, use of PPEs has become compulsory. The global textile clothing industry is facing a crisis unlike it has never faced before. The COVID-19 pandemic is spreading human suffering, damaging economics, and disrupting people's lives across the globe. The quarantine measures, illness, and salary reductions have also affected the consumer demand. Globalized textile industry is also struggling with severe sports side disruption, and of course workers are staying at home, leading to disruption in supply chains through closures of factories and closure of retail stores. The concerns have been raised among the factory workers owners about the nature of the garment operation structure, and we know that maintaining social distance in factory setting is proving to be difficult for many factories. Because often the operational structures of production lines require a certain amount of proximity among production lines, so people have to work sometimes fairly closely. Global fashion brands are closing down their stores, leading to a few, some cases, complete halt in demand for production from brands at the factory levels. In turn, it has led to many businesses to close. Others have moved to product innovate. In fact, some people have innovated and added value to their products, and they have moved to products that are required locally. So the winners and losers. Apparel textile manufacturers are struggling to get necessary supplies, and consumer spending on non-essential clothing has decreased. The impending economic crisis is expected to have a huge impact on fashion industry in 2020 and beyond. In fact, we have already seen the impact of this. While many businesses struggling during the pandemic, others may emerge stronger. And for the retailers such as Amazon have been adding staff to handle their increased demands. Of course, online business have gone up. Move towards digital online business is taking place. So I think we are moving, I don't know whether safely, but surely towards the digital world. Impact on major brands. This is actually a snapshot taken 2020. Sales in China fell by 80%. Ralph Lauren, of course, they won that. Their businesses dropped by 70 million within a short period of time in early stages of the pandemic. Gap expects that the sales will be down to to I think something like by 100 million US dollar. Inditex has closed nearly 4,000 stores in 39 markets, and therefore over 50% of the total decrease. So I think there is that's a snapshot. Now the average reported capacity utilization rate decreased by 30% in the first quarter of 2020 relative to the same quarter in 2019. 54% of the factories surveyed expected decrease of their revenues by 20%. Many factories have already reduced working hours for employees in response to production slowdowns, increased concern about employees' retention as well. Now, 58% of the manufacturers are willing to repurpose the production towards to other goods, especially medical related goods, face masks, towels, bed linens, and patient gowns, etc. So medical textiles are really the major materials that are being produced in many countries. They will need support on sourcing machinery, raw materials, and foreign exchange and training workers. Of course, if we are moving with new product lines, then of course these are the new requirements of the future textile industry. And there's a major survey carried out about the fashion executive, and their forecast, I think most of them, rather in terms of value, mid-market or premium luxury, you will see that they're expecting the worst to come yet. It's not just regional, it's across North America, Europe, and Asia, same story. And of course, there are on the top some optimists who still think things are going to be better. Now, let's hope that's the case. In European countries, of course, because where the pandemic has taken strong footing, and that is where it has reflected the impact on the textile industry, the sharp drop in textiles and clothing product sales. And I'm sitting in Manchester. I'm quarantining. I've just come back from Pakistan, and for last 10 days, I've been sitting in my home and just, of course, talking to people over the phone. Things are not that good here. In European Union, the textile and apparel sector faced nearly 50% drop in sales for 2020, and these figures could be worse for 2021, and we have to see that. And of course, the impact has been disproportionate and especially in the developed countries, and you will see particularly the SME sector has really been affected greatly, and that is the sector which actually drives the economy of the country and of the countries in the West, and that has really suffered, and there is tremendous concerns about the SME sector. If you see a survey which shows these are figures from the Office of National Statistics in UK, and it shows you, if you look at the text clothing, you will see that there is a big dip. I mean, like any other products, there's a big dip during when the pandemic was at the peak, because people were not visiting shops, and shops were closed, and the whole activity actually came to standstill. So you see there's a big dip here in the clothing. The only winner was here, as we expected, alcoholic drinks and beverages, and people were trying to be happy, and just so that is the only area which has gone up. There has been some recovery in all areas, but of course we still have not reached the level of which is 100% of the which is February 2020 level. So we still have not reached that level. Now, of course, as I said, company size does matter, and smaller companies have really taken the brunt of the COVID pandemic. Larger industries tend to survive because they have resources, and of course, there's a survey that more than 70% micro businesses, which have fewer than 10 workers, were pausing their operations or temporarily closed in last October, as compared to 6% of the larger firms of 250 and more employees. One area where this was very noticeable is the service industry. Service industry really of course, that is there are no sectors which is independent, all interdependent. So service industry has been affected more than any other industry in the West. So larger business, as I said, probably outperformed the SMEs, and of course, according to the Bank of England, the pandemic reduced flows of economic for many companies, with smaller companies more likely than larger companies to operate in sectors that have been affected more by the pandemic. So supply chain, in terms of perspective for reduced demand, of course, that is we know that in terms of reduced demand is because the supplies have been low as well, and of course demand has been very low. For the moment, European American retailers, which are Chinese destinations, of course, are still canceling orders with China. The cancelled orders are caused for concerns, and many source countries in Pakistan probably is not immune to it. What I see is probably Pakistan probably has come out of this better than most countries. Shippers are increasing, invoking force majeure clauses within their contracts to halt their payments. And of course, the Sustainable Textile Asian Region Network has really taken action on this. This includes Pakistan and Bangladesh and China, etc. And they've taken action on it, and they said, and they have urged the brands, retailers, to consider the impact that their purchasing decision is going to have on the countries affected by coronavirus and small workers and businesses in the supply chain. Therefore, they should honor their contracts. That's what they are actually asking the brand owners to do. Disruption in production, because it's same thing. Just this one point is important. One of the possibilities is that production of fashion goods could be moved to the sourcing countries that are less affected by the pandemic and are resuming production activities faster than others. So for this Asian region has been the area where people are sourcing now. Most developing countries do not have financial means, health systems, or social safety nets to respond to COVID pandemic crisis and its economic impacts. So therefore, in this context, World Bank has and IMF are offering packages to support these businesses, especially in the emerging markets. So here's a snapshot in it's really history of China textile output mills. We see that it has really it's going up all the way till 2019, and the growth rate was was also picking up until the pandemic hit, and in the first 45 days of pandemic it decreased by 15%, and in the next up to 60 days the output was less than decreased by nearly 20%. So China has recovered since then, and of course the impact of on Bangladesh actually has been quite severe. It says that they have actually nearly, I think, is 200 and let me go back. About $3 million US dollars. I think that's the revenues have gone down, and nearly more than 2 million workers have been affected. Now, in terms of Indian textile industry, it was expected to grow by 12% and reach a market of something like $220 billion US dollar by 2025. I think that has been downgraded. Now I think it's expected to shrink by 30%. The COVID expected to decelerate the overall growth projections of Indian textile industry. Pakistan, in short term, Pakistan clothing has picked up quite a lot. The medium terms, In fact, we still yet to see what's going to happen, and especially key markets across the emerging markets from the worst crisis. If Pakistan textile industry manages to seize this opportunity, and of course, in longer term, it has the potential to become one of the major players in the global textile market. It's an opportunity for Pakistan. They are increased order if they can be maintained. How are we going to do it? I think that is another question. However, the pandemic could affect the of the global textile industry, chain trade, and of course, we still are not sure which way the camel is going to turn. Now, in terms of future textile, we have, there is a lot of activity. The number of organizations have been formed. We are really focusing on smart fibers and yarns, micro nano electron technologies, biosecurity technologies, and all these can be integrated. Application to sports, smart homes and smart cities, textile for promotion of health styles, and of course, telemedicine is going to be an important area for the future where people are going to be monitored from distance. Here, wearable medical devices are going to be important, and I think the work will, will move pretty fast in this area, I presume. Okay, now role of textile sector in economic recovery post-pandemic. I think the World Economic Forum they actually think that despite this contraction, textile and apparel industry could be the key engine for growth and employment in the developing countries. And this is from the recent World Economic Forum, the summary of that. Countries building back from COVID-19 should not ignore textiles and apparel industry. It is considered a starter sector on the road to economic recovery. So when the industry expands, it provides a base to which build upon the capital and more technologically demanding industries. In fact, the textile and apparel sector can be critical to the growth of and development of strategies of many developing countries. So this is the summary of the World Economic Forum, last World Economic Forum. Now, I think action needed. I think we need to really, in terms of textile sector, we need to be flexible in production. So we need to make sure that we produce short runs and more focused runs in terms of products, reduce the financial burden on companies. And we need to look at the inventories. We need to explore the alternative means of finances. And of course, restructuring operations are going to be important in terms of production and also management. So I think Vais Khatri is talking about this Industry 4. I thought of really putting something in it, but when I saw the program, I thought I'd just mention it because this is one area which is going to be quite important. The Industry 4 refers to the use of many innovative technologies, sensors, machine learning, the Internet of Things, to seek a new type of manufacturing efficiency. Where traditional manufacturers spread production across the world and enable cheaper labor, but I think Industry 4 ensures individual machines and even entire factories can communicate with each other in real time to develop their coexistence in an optimal way. So it's the optimization of the processes and procedures. Big data analytics, machines learning, and artificial intelligence will make this possible. So again, here we are moving towards intelligent and digital world. Textile mills can choose and customize specific functions needed to be measured and mentioned to improve overall business effectiveness. Now, the impact on education, and we've seen that the textile industry in the developing countries must modernize in terms of textile production technologies, well-qualified trained manpower, the ability to innovate and diversify. How are we going to do it? The traditional textile industry must evolve in terms of time to market, flexibility, product quality, and productivity, and reduce efficiency. Move towards more promising and emerging textile technologies for countries that are water stressed, such as Pakistan, cotton production may become unsustainable not too far in the future. Must develop alternatives to cotton fibers, such as natural fibers, hemp, which I'm glad to say that Pakistani government has approved a project led by the National Textile University to allow cultivation of industrial hemp. And that is actually going to have quite a considerable impact on the new sources of fibers. And of course, we should also not ignore the use of synthetic cellulosic fibers such as lyocell. So Pakistan need to move in that. So we know that COVID-19 outbreak has caused a downturn spiral in the world economy and caused a huge impact on the education system. The sudden closure of campuses and social distancing measures to prevent community transmission has shifted face-to-face classes to online learning. So this has thrown the focus on utilizing e-learning tools and platforms for effective student engagement, which may have limitation, accessibility, and affordability for many students in developing countries. But I think, of course, this is going to have tremendous impact on the overall structure of the universities and research organizations. Impact on higher global higher education. The pandemic has exposed the shortcomings of the current higher education system and the need for more training and educators and digital technology to adopt the rapidly changing education climate in the world. In the post-pandemic situation, the use of online and virtual education may become an integral part of the higher education system. The education institution and universities need to plan the post-pandemic education and research strategy to ensure student learning outcomes and standards of education quality are maintained. And this is not going to be easy because moving from face-to-face teaching and learning, I think, to digital online is going to take time, and the quality is going to suffer. And we need to find strategy how to maintain that or even improve the quality of delivery. The universities across the globe have been affected by pandemic in terms of economics, particularly those in developed countries with high international student populations have been afflicted more than the developing countries by the pandemic.
Sir, can we please move to the concluding remarks as we are running short of time, sir, please?
Okay, I'll do that. Basically, what I'm saying is that I think that we need to work together. While just, of course, we, in terms of thriving, create thriving knowledge-based national economy depends upon the outputs of universities, and academia must work hand in hand together to cooperate and to develop these strategies. A need for recovery for the higher education sector. I'll skip that. I will move to actually the role of education revival in Pakistan textile industry. The academia must help support the industry in addressing these issues and offer a way forward for revival and development of the enterprising prosperous sector after the pandemic. The modern and state-of-the-art special universities can provide environment and facilities where innovative entrepreneurial graduates and researchers with appropriate knowledge skills and acumen and leadership can be developed. So we really need to develop specialist universities, and those universities who already are there need to modernize, and we need to make sure that we are able to deal with the challenges of future. Now, I think here's a thought for the Pakistan textile. The revival of textile industry is in Pakistan is absolute necessity, as it is the most important sector for the economic security of the country. And only through the provision of world-class education and research can we build a strong and knowledge-based, world-class, world-leading textile industry in Pakistan. So we really need to focus on this time. Just a quick last slide. Remember human freedom. I think the impact of COVID-19 is felt beyond economic sectors. The things that are under the greatest threat is our freedom and our cultural norms. While living through the COVID-19 pandemic, we must remember not to lose our freedom and humanity at any cost. Yes, it is important to live and to do well economically, but it is even more important to remain a fear-free human being. Please remember that when we are dealing with this COVID-19 crisis, pandemic or pandemic, whatever it is, we must not lose our freedom. We must remain good human beings. Thank you very much for listening to this talk. Thank you. Any question?
Yes, Professor Dr. Hussain Shah Sahab, we have one question received from Musanis Raza. He's asking, can you please advise the impact of COVID-19 for the online sales in Europe and USA?
I think in Europe, I can tell you because I'm sitting in Manchester, and Manchester still for last month and a half, all the classes have been online. So online, people have actually adopted reasonably well to online teaching, and obviously there are certain things you cannot do online, like doing research in the labs, and I think any courses that do not require physical involvement, for example, in research and development, and especially in science and technology courses are going to be affected more than anything else. But the courses which do not require laboratory work, do not require the presence and the face-to-face presence, I think they are doing pretty well. I think people have adopted. Schools are actually taking classes, online classes. Most of the schools are actually still closed. They are opening on, I think, 8th of March. They are thinking opening them, but I think they're still are thinking. But university is still not open. They're still online. And of course, it's going to depend on from subject to subject. Some subject you can teach online. Others, I think, we have to wait until things settle down and the universities and research organizations are open again. I think in UK, I think UK has really learned to how to teach online in most of the courses, but I think still we have to wait and see what happens for the months to come. Yeah.
Thank you very much, Professor Dr. Hussain Shah, for your remarks on impact of COVID crisis on technical education on industry. Although we have few more questions left, but as time is running short out, so we will skip those questions. And I would like to request our next speaker, Professor Dr. Yasir Nawab Sahab, to his talk on technical textile value chain mapping and SWOT analysis of Pakistani industry. Dr. Yasir Nawab is working as a director at School of Engineering and Technology and as a lead to composite research group at National Textile University. Today, he's going to talk about technical textile value chain mapping and SWOT analysis of Pakistani industry. So please.
Thank you, Dr. Talha, and all the organizers. As the time is short, so I will be a little quick because we are almost 20 minutes late. So in fact, what I'm going to present is a study that we concluded in last year with WWF. So it was on technical textiles value chain mapping and SWOT analysis of Pakistani industry. So I will be answering 3 questions. The first one is why Pakistan's textile exports are stagnant. There's a lot of debate since morning. Then technical textile global market very quickly. Mainly it will be focused on technical textile value chain in Pakistan, SWOT analysis of technical textile industry, and the business opportunities in technical textiles for our industry. So we are like the second most dependent country on textile with respect to export in the world. 58% contribution to textile exports. Mr. Shahid Sattar corrected it in the morning that it has increased a little bit. GDP 8.5%, employment 45%. So these are the exports up to 2019, 2020. It was the same behavior, almost the same behavior, and these are the exports of textile, which are almost stagnant. So we are standing at number 10 or 12 with 14.53 billion US dollar of exports out of 978 billion US dollar. So a quick reminder of what Professor Tanveer has presented in the morning. Other countries, their exports have grown significantly, whereas Pakistan is stagnant. The textile exports of Pakistan are stagnant. If we look in the last 10 years, so China's exports have grown 48%, Vietnam 256%, India 64%, Bangladesh 177%, and Pakistan only 28% during the last 10 years, which is the poorest performance if we compare with the regional countries. So in fact, it's a national challenge to significantly increase textile exports of Pakistan. There are several limiting factors. I'm only sharing with you the names. The first one is market diversification. We are focusing a lot on US and European Union. If we look at the market of Japan, South Korea, then the East Asia, so it's about 100 billion US dollar of textile markets, and our share is almost negligible there. Our product range is very narrow, and what we are producing, in fact, it's not very high end. Our productivity, Professor Mann, he has talked about it, so we are standing nowhere. Our branding is not good, it doesn't exist. The technology that we are using in small and medium industries, mainly it's obsolete technology. Compliances is a big issue. The small and medium industry is finding very difficult to comply with the international standards. The number of exporters are very limited. It's only a small number of exporters in the textile. Other are only working for them. Law and order situation, it plays a lot of, in fact, very important role to make the image. Cost of utilities, it's high and it's increasing in again. Continuity of policies and stability, political stability, high interest rates, and lack of foreign direct investments. So my talk is mainly focusing on these two aspects, narrow product range and low-end products. So if we look at our current product range, is conventional textiles. Pakistan's share in the global market is about 2.4%. These textiles are commodity textiles. There's a lot of market competition and profit margins are very low. So we are trying since like 6-7 years. Professor Tanveer, he has presented many times on the introduction of technical textiles. So these are performance textiles. I will not go into detail. There is a background. So Pakistan's share is about 0.3% in the $200 billion of market of technical textiles. So these are the technical textiles. These are the textiles with high performance and high profit margins. So in general, we divide technical textiles into 12 categories: mobile tech, indutech, medical textiles, textiles for homes, packaging textiles, building textiles, construction textiles, you can say, agricultural textiles, cloth tech, sports tech, geotextiles, protection textiles, and auto tech. So here is something which is interesting. There is a market of 42 billion US dollar of mobile tech. So in the mobile automobiles, we are using textiles which have market about $42 billion. Then there is industrial textiles, then sports textiles, And then there are other about in the range of $10 million market. So if we look at product wise, 60% of the technical textiles, they are woven, either woven or knitted. Most of the Pakistani markets, they are dealing with this segment, the 60% of the segment. Then we have composite materials, 20%, and then non-woven, 20%. So our presence, the presence of Pakistani industry, it was not very significant in this segment, but it's increasing with the passage of time. So if we look at technical textiles, so unlike conventional textile, the contribution of Asia Pacific is very significant. So China, India, Pacific region, they are contributing about the market share of these region is about 63%. There is a misconception about technical textiles, about fibers. Whenever we talk technical textile, it's said that these are the textiles which are made using very high-tech fibers. It's not the case. If you look at this segregation, the share of cotton is about 7%, share of other natural fibers is about 15%. So the market that we are already focusing, the machinery that we already have, it can cater 22%, and then polyester 26% of the technical textile market. So these are the different fibers that we use in technical textiles, in natural cotton, jute, hemp, flax, silk, and they are mainly used in different categories of technical textiles. We will be sharing these slides and video with you so you can have an idea that natural fibers as well, they are being used in technical textiles and for diverse applications, as well as man-made fibers. So technical textile stakeholders in Pakistan, if you look, there are large manufacturers that includes manufacturers of fibers, filaments, and then chemical manufacturers. We have polyester fiber manufacturers in Pakistan. Otherwise, other fibers we have to import. Mainly, we are a converter industry. We import the fibers. I'm talking about technical textiles. So mainly we import the fibers, or sometimes even fabric. We convert it and then we sell it to end use or to society. So in Pakistan, there are more than 200 SMEs and large-scale manufacturers. Only few are dedicated. Mostly, they are conventional textile industries who are also working on technical textiles. One very encouraging phenomena for dedicated textile manufacturers is the non-woven manufacturers. In the last 2-3 years, due to this pandemic, the number of non-woven manufacturers, it has increased. For example, needle punch manufacturers and non-woven manufacturers, they have increased up to 2, SMS 4, spun bond 9, and spun lace 1. There are 2-3 units which are already in installation. So if we look at total fiber consumption of Pakistan, the local production is about $3 billion, $2.9 billion, and we are still importing today $1.15 billion. This amount will increase in this year due to less production of cotton. So our total consumption is about $4 billion, and most of the fibers they are partially used in technical textiles as well. So if we look at overall road mapping, so we have fiber manufacturers. If you look at down, if there is 1 class, it means the number is less than 10. 11 to 20 manufacturers, 2 class, 21 to 50, 3 class, and more than 50, there are 4 class. So for yarn spinning, we have more than 50 units. These yarns are being used in technical textiles like packaging textile, protective textile, medical textiles, and home textile. Synthetic fibers are used everywhere, but the yarn spinning units, they are between 11 to 20. Similarly, there are fabric manufacturers, large scale, there are not many, mainly they are small and medium scale. Composite materials is the same, textile processing. We don't have a lot of large scale manufacturers except in dyeing and Printing, quoting is an area which is very deficient. And then in garments and stitching, we have like uh, less than 50 large-scale manufacturers of technical textiles. So here is, in fact, the trade of technical textiles by Pakistan. In these 12 categories, the global trade is 175 billion US dollar. Pakistan exports is about 447 million US dollar. It's less than $1 billion. If you look at our global share in only in build tech, our share is, you can say, not in decimal, it's more than 1%. Otherwise, we are less than 1%. In protect, it's near to 1%. Mainly, these are gloves. And Pakistan, in these categories, we are exporting about 447 million US dollar. So it means the base is there. We are still exporting. And at the same time, we are importing about 200 million US dollar. So our share is 0.5%. So in order to feed that 12 categories, we are importing fibers, yarns, and fabrics. So if we look at fibers, these are high-end fibers, it's about 40 million US dollar, technical yarns, 14 million US dollar, and technical fabrics, 62 million US dollar. So it's about 117 million US dollar of the raw material. So if someone is like only wishes to work for import substitution, so these areas, these are very important, technical fabrics and then technical yarns. So this is the picture of last 5 years only for end products. So we are like exporting around 450 plus minus 40, and the imports are about 200 million US dollar. If we go into detail, so for exports, our strengths are sports textile, protective textiles, build tech, and up to some extent, you can say medical textiles. And in imports, we are importing a lot in medical textiles. This is the portion that can be substituted very like quickly. So SWOT analysis of our technical textile industry. We have certain strengths. This low cost of doing business in Pakistan due to low cost of labor. If you compare, as most of the technical textiles, they are not in Bangladesh or the low cost labor countries. We have reliable supplies of commodity raw materials is available. There is a high local demand of diverse products as well. The exporting environment since last 2 years is developing. So we can incorporate our technical textile industry in that. The infrastructure is already very good and it's there. We have like fiber to end product infrastructure. We only modify it a little bit. There is availability of basics testing and certification. And the last one, which is very important, technical textiles mainly are knowledge textiles. So for that, you need R&D facilities and R&D support, which is available in Pakistan. NTU is one of them. We have NED, Mehran University, Butums. So they are there and they are, these are they are support, they have potential to support the industry which are situated in their areas. We have some weaknesses as well. In fact, as I mentioned earlier, the technical textiles are knowledge textiles. So if we want to produce a new product, so we need technical expertise. Then for some of the products, you need exclusive technology, which is not available. For that product specific technical expertise, these are not available as well. For some high performance fibers and yarns, they are not available in Pakistan. A capital investment in technical textiles is very high, especially for SMEs. Testing facilities for advanced testing and validation of technical materials. There are many products which are still not available in Pakistan. If we want to do this test, NTU is doing, in fact, doing great to bridge that gap, but still There are many tests which are not available. There is local demand in specialty sectors, which is not much. For example, if we talk about automobile sector, so we are producing annually 200,000 of automobile, and there's a lot of textiles which are being used in these automobiles. But what we are doing, we are importing these textiles. So we need to make policy, we need to force these auto manufacturers so that they use textiles for automobiles. They take it from the autos, they source it from the local market. So if they will be doing it, ultimately, this will boost the local industry. They will start substituting the import, and then they will be exporting as well. So we have opportunities. There is local market with some issues. Export potential is very high. And we can attract foreign direct investment as well. Our, in fact, position, geographic position is very important. And where we are sitting by using rule of origin, Chinese companies or other like companies from the region, they can invest in CPEC or in the port cities near to Pakistan, in the Pakistan, and they can use rule of origin in order to enhance their exports. There are threats as well. There is an increasing competition. If we talk about today, Bangladesh, Vietnam, they are not much, their presence is not very significant in technical textiles, but they are coming. So in 5 years, if we will not catch this train, so I fear that we will miss it. Political instability in the region, it's one of the threats. Increase in utilities and energy prices. Today in technical textiles, there is no doubt about that we are competitive. But if the cost of utilities and energy, it will be increasing. So this will not be the case. There are some materials on which there are controls of import and exports. There are a lot of duties and some materials, they are not allowed Pakistan, so government need to work on it. Depreciation of Pak rupees against US dollar for exporters is another threat. And we need to remove import tariffs on the raw material for technical textiles. The technology, as these textiles are knowledge-based textiles, and technology is changing very quickly, so we need more effort in technical textiles as compared to conventional textiles. So here are some business opportunities. I have shared only the top 10 technical textile export products in the globe. So if we look at first is sanitary towels or pads, this is a market of 116 billion US dollar. Pakistan share is only 0.02. I will make it a little like zoom. So top 8 products, 16 billion sanitary towels, then the textile for briefcase, 14 billion US dollar. You can look at Pakistan share. We are nowhere. Then mid-ups articles for 12 billion, safety airbags in flat systems, 12 billion, garments, especially of non-woven, 10 billion US dollar. We are nowhere. Special garments for professional sports persons, 8.8 billion US dollar. We are nowhere. Only 14 million of exports. Carpets, sacks and bags, it's a market of 5.4 billion US dollar. We are exporting 57. So jutes, Products Manufacturing Association, they are doing good. That's why our export share is 1.01%, but still there's a lot of potential. Track suits, ski suits, swimwear, 5 billion of market, 0.51% our share. Tarpaulin, awnings, etc., 5 billion of market, we have no share. Pharmaceutical goods such as switches, $5 billion of market, we have no share. Narrow woven fabrics, 4.5 billion market, almost no share. Seat covers, 3 billion, no share. Gloves, mittens, $2.5 billion dollar of market. Our share is about 4.88%. So this is the only product in which we are in the top 5 manufacturer in the world. So this was in fact the global market. There's a lot of space. I have presented the data at the level of a product so that you can have an idea of business opportunity very quickly. So let's come to Pakistan, what we are doing. These are our top 10 technical textile products. We are doing good in gloves, 144 million US dollar, then sacks and bags, especially of June 57, then mid-ups, dress patterns, 47, tents, etc., 46 million. All these are in millions. Compression hosiery, 33 million, track suits, 27, and so on. And in the products that we are dealing in, 3 of the products, we are in the top 5 exporters of these products. But in fact, our choice of the products is not good. What we are focusing on, their world market is very less as compared to top technical textile products. So what we are importing? We are importing sanitary pads worth $40 million. So first opportunity for import substitution. $40 million is something which is big for a local industry. We can set up like 4 or 5 plants that work on manufacturing of sanitary pads, napkins, etc. Tire cord fabrics, 15 million US dollar. In fact, for industry, for textile industry, it's strange. We are textile manufacturers and still we are importing 15 million US dollar of tire cord in order to make tires. Label and badges, 13 million US dollar. It's again an opportunity, and believe you me, this will be increasing with the passage of time as what we are expecting, our garments exports will be increasing in next 2-3 years. So this one, it will almost double in the next 2-3 years. So it's also a good business opportunity. Then pharmaceutical goods, 10 million US dollar, mid-ups, 9 million US dollar. For cases, 8 means suitcases, 8.6 million US dollar, carpets, 7.8 million US dollars, narrow fabrics, 7.5 million US dollar, weddings, 7.3 million US dollars, and again, cordage or ropes, 5.4 million US dollars. So all these can be substituted easily. The technology is available in Pakistan. The materials are available in Pakistan. The only thing that which is missing is the knowledge. So we can help, and you can help in that in order to bridge that gap. So in technical textiles, the knowledge gap is there in our conventional industry. So we can help in that in order to bridge that gap. We have National Textile Research Center, which is a state-of-the-art facility, Advanced Textile Research and Innovation Center, especially for technical textiles, woven product lab, Park Korea Technical Textile Center. We are going to initiate its second phase as well. We have non-woven coatings and all the relevant facilities. So what we can support you, it's by training the human resource, product development, in testing, in trainings, and we can help you in developing business feasibilities. Thank you very much for your attention. As I have mentioned earlier, I would like to thank WWF. The study was supported by them. The study to explore and assess the existing supply chain in textiles of Pakistan for producing and exporting technical textiles. This was only a brief of that. There's a lot of data, there's a lot of opportunities which are mentioned in this report. This will be available online and in hard form very soon. Thank you very much.
Thank you, Dr. Yasir Nawab Saab, for a very self-explanatory presentation. We have a very quick question posted by Mr. Abdul Samad Gill. He's asking what factors are limiting our growth in technical textiles. As we see from the last 5 years, it is almost at the same level.
In fact, there are many factors which are limiting. The first one is raw material. Then the know-how. The third thing, which is very important, is that how to sell and where to sell. If we know that where to sell, then the making of product, in fact, it's not a difficult task. We can do it very easily. So we need to search for the markets, and you can help in that. We know today exactly that which product can be sold where, what is the market size in Asia, in which country, what is the market size, and even what are the main importers as well.
Thank you very much, sir, for your precious time. I would like to introduce our last speaker of today's session before afternoon lunch. We have Mr. Mujibullah Khan Sahab with us. He is a Chief Executive Officer at Textiles. They provide new solutions regarding smart and technical textiles. He is one of the person who got himself updated about the latest innovations. He will talk on post-COVID fashion trends. Sir Mujibullah Khan.
Alaikum ji. Give me 1 second. Let me try to share the screen with you guys.
Walaikum assalam.
Let's talk. One second, please.
Yes.
एक second, शायद मुझसे something went wrong.
Meanwhile, if Dr. Yasir Nawab is available, we have a question for you from Mr. Adnan Riaz. He's asking, what investment cost to set up technical textiles setup to start? So if you're there,
In fact, also it depends on the product. So, for example, if we are making jute sacks or bags, so we need no new investment. If we are working on workwear, so there is no special investment needed. So it depends on the product.
Thank you very much.
Sir, can you see?
Not yet, sir. Yes, we can see your camera video.
Access ही नहीं दे रहा screen.
नीचे share screen का option होगा.
System preference मांग रहा है. मुझे access change कर सकते हैं ना? मैं दूसरे कंप्यूटर पे ले लूँ.
जी सर.
आप फरियाल तारिक को एक्सेस देंगे?
ठीक है. आजम सर. फरियाल तारिक.
Sorry about that. I think the last minute.
Access given to the Ms. Farial Tarik.
Farial Tarik.
Yes.
You got it?
maybe the Chrome browser. Yes, I think we can see perfectly the slideshow, the fusion, future fashions.
Can you hear me?
Yes, we can hear you as well.
Okay, good. Thank you for NTU for inviting me for this conference. And I will talk about the future of fashion post-COVID. And I'll talk about the trends and the scenario, which is very close to our heart, because I believe that one of the ways for Pakistan to increase their export is really understand the consumer insight and design our textile accordingly. Yeah. So, so I'll talk about the scenario. They will be, interestingly, there are, as we all understand and, observed during the presentations already made, that after the COVID, there's a growing trend. And I think COVID was a catalyst to make it happen, that more and more people will work from home. A lot of people, and less is the new luxury. That means that, because I think, and that also is an opportunity. Can you hear me? Hello?
Yes, we can hear you. Yeah.
Oh, thank you. So that also is an opportunity, because I think the world will dress down and move to more towards casual clothing, more, since more people will work from home, so home textile, towels. So that is an opportunity for Pakistan, because we are primarily into casual clothing. And the third thing, which has been, a burning issue in our part of the world, is sustainable fashion. So that's the scenario. And now I will tell you how the consumer will react to it. So, and that is the agenda for my presentation. So, and I will explain each later. Trendy fashion on the go, aesthetics, comfort, sustainability, and digital leap. So this is an overall scenario on the fashion trend in textile. Need for nostalgia, which means that not to hold now. And we are seeing this, I think we are seeing this more in Pakistan. They announced that, from 15th of March, the SOPs, they are relaxing some certain conditions. So more and more people will move towards leisure wear, spring clothes, picnic outfits, evening dresses, active wear for gyms, and different fabric patterns. So people will, try to celebrate the decrease in pandemic, which will result in optimistic aesthetics, which means that people will wear trendy clothes, a lot of colors, and we believe, which will floral prints, bright colors, psychedelic patterns. So there will be a lot of active, happy fashion coming back in the market. Because if you look at what we've been wearing at home, it's just, my pajamas and black and gray t-shirts. And masks are here to stay. So a lot of people will design masks. We are also running a campaign that to have a sustainable mask, because if these, disposable masks, the next Mount Everest will be made from these disposable masks. Third and most important, which is comfort, because people will work from home. So I will explain in my next slide more on this. So there's a very interesting, a segment being created, which is sleepwear, which is a merger of sleepwear and ready-to-wear. It's called loungewear. So because you will, and I was talking to a friend of mine in Europe, and they're saying that they were already planning to make a hybrid of work from home and office. So, and 50-60% of their workforce, and they employ quite a few 100,000 people, will work from home. So there will be a big demand surge in breathable, antimicrobial, moisture wicking, and absorbent fabric, and wrinkle free, and even I work very closely with the denim industry. They're looking at developing loungewear jeans. So for a consumer, it's an effortless clothes, which is easy to wear, easy to style, and same goes for home textile and other stuff. So in last, we've been trying to promote antimicrobial technology for last 10 years, but in last 1 year, I think it's the hottest product available in the market. Sustainable fashion, and I think a lot has been talked about it already, but sustainable fashion is really the way to go. So if you're not sustainable, no matter how good you are under threat. There are two sides of sustainable fashion. One is, the market, and the second is consumers. So on the left side, it's been, and like I said, that pandemic has been a catalyst for sustainable change within the industry in the following ways: co-friendly, sustainable, and trans-season closet, meaning there will be less season. And I think so durability is the new sustainability. You have to design clothes which last long. High street fashion is under challenge because it doesn't last long. And we somehow we were spoiled by buying a pair of jeans every Saturday. Now, I think that is under threat. So people are looking at designing clothes which last longer. Pieces that are repeated and reused in multiple ways, old wash, laser, and then post-consumer and pre-consumer waste is a great example of it. Changing practices throughout the supply chain to integrate sustainable in their core. That means that there is a challenge, but going forward, people will look at clothes which are hardcore sustainable. At the moment, there's too much happening at the fiber level, at the chemical level, at the wash level. The other thing which consumer is becoming more and more aware now is who made their clothes, how the product was made, how the material was sourced. So transparency and traceability will also be, and there are a lot of blockchain, and there's a lot of technologies and time being invested on. So it has, and Pakistan is probably lucky that way, that the way I explain to people is that we do. I mean, on one hand, people were saying that we should get more buyers coming into the country to see what we are doing, but we've been working that way for last 25 years, where we have not seen many buyers, but we are a very reliable country in terms of supply chain that way, and we should promote that more and more. Even in the COVID, one of the reasons business grew that much, that people were not happy sourcing from countries like Bangladesh or Turkey or India, where they had their buying offices, but those buying offices were closed. Here, they are used to buying for over a decade from people who they haven't even probably met. So this is one of the study which was done by PwC. That 40% of the people will suffer in their income post-pandemic, which obviously is understandable. There will be a recession. There is a recession. 89% people will spend less, and 51% people will spend less on their clothing. So in a way, this is a challenge. But I think if you look at from a Pakistan perspective, people we are in a mid-tier segment, and we are in a category which if we alter our product a little bit, we still have a demand. So in a nutshell, the consumer preference is sustainable fashion, slow fashion, circular fashion, and ethical fashion. which is pretty much self-explanatory. And if you have any question, please, you can ask at the end of my presentation. That is the biggest breakthrough which has happened. And if you look around, even in our lifestyle, where internet, or people my age, we have been there is a big breakthrough. I mean, in domestic and export. And I think recently, Government of Pakistan or State Bank also allowed online payment we can receive, and so that's probably the biggest. But for our industry, what will this make? I mean, the moment you will talk about your company, people will. You have to have a very good website. You have to have a very interactive website. You have to have a digital catwalk, virtual showrooms, effective viewing images, video content, and there is a lot software being developed around this, apps being developed around this, because if you have to have a digital emotional connect, which means that you have to be very interactive that way. Versus, if you look at even my website, it's very boring. So we are trying to make it very more interactive, because more and more people would like to see how and what we are offering. In a way, this has really challenged high fashion, because it has democratized the fashion industry. I mean, there's no exclusive fashion anymore, because everyone can participate and see the fashion. So the takeaway from my presentation, concerns are the work from home, less is more, environment awareness, but the solution is to design more and more comfortable clothing, more and more durable fashion, and sustainable fashion. So that's about it. And it's a good news for us in a way that we are in a category of casual clothing, more in t-shirts, loungewear, bottoms, denim, towel, and bedsheet, where there will be reasonable demand versus casual clothing and more. Thank you.
Thank you very much, Mujib Saab, for a very interesting talk. We have few questions from the audience. The first question is posted by Saif Kazmi. He's asking how much industries in Pakistan have moved to the 3D fashion design softwares, and he's given some few examples like CLO 3D and Optitex 3D.
I think there is what we need to do is to, and it's already been happening in my opinion. I mean, I am very closely linked to denim. I'm very closely linked to home textile. There's a hybrid happening, and people are really adopting these technologies, or at least at their stage one, where they're really they're open to these offerings. We were selling MYR. We are selling software like this, and there is a serious interest in it now.
Although there are a lot of questions, but I would like to ask one last question, which is asked by Mr. Adnan Riaz. How to follow sustainability with new trends? Also share ideas on supply chain can be sustainable.
See, that's exactly a great question, and I can take 2 hours on it. So please don't starve. So to me, I think we are at the stage where sustainability is looked as like a burden on your cost. I think we need to get out of that mindset, where we have to have a mindset where we're like, it's like iman, it's like imandari. So like, if imandari is part of your value system, then we should also adopt sustainability as our value system. We should stop because, and I understand that the market pressure, market dynamics, because on one hand they want everything sustainable, but on the other hand they want everything cost neutral. So that is creating a conflict between your actions and your deliveries. But to me, it is going to make the world better. So if you have to embrace it like in that way, there are lots of ethical sustainable models available, and I'm willing to discuss offline.
Thank you very much, Mr. Mujibullah Khan, for answering these questions and for a great presentation. It was a really pleasure to have with you with us. So this concludes the first technical session of 6th International Conference on Tradition and Innovation in Textiles. Thank you all participants for attending. We will resume. My other colleagues, Dr. Abdul Rahman and Dr. Babar Ramzan, will join you as a host. We will resume the sessions, second technical session at 2 p.m. 2 p.m. Pakistani. So for this, I conclude the webinar. Okay, Allah Hafiz.
Introduce Professor John Green. He is Associate Dean for Graduate and International Program at Jiangnan University College of Textiles and Clothing. He is working on antimicrobial textiles and polymer, functional finishing of textiles, surface modification of fibers and polymers. He will deliver a talk on antimicrobial textiles based on enhalamine hybrids. Over to you, Prof. Thank you.
Okay, so now my turn, right?
Yes, please.
Okay, thank you for the introduction. So today I'm honored to, just a second. Okay, so I was honored to share part of my research in this conference. And also thanks for the organizer to invite me. Today, my talk is antimicrobial textile based on enhalamine hybrids. I'm Xu from Jiangnan University, China. As we know, we are surrounded by microorganisms like virus, bacteria, and fungi. They exist in air, water, food, soil, and even inside our body. Some of them are beneficial to our health, but some of them harmful, which can cause infectious disease, even cause death. And there are some data back to 2018 US. They said infectious disease is third leading cause of death in the United States and the leading cause worldwide. And about 20 million people were infected in 2018, and 88,000 people died. It also cost thousands of dollars because of this disease. And this slide shows the general transmission pathway of harmful germs. If people infected with bacteria or virus, they are germ carriers. They can contaminate the environmental surface. And it sometimes cause new victims. And different material days to 90 days. For the fungi, they can live up to 60 days. For the spores, they can even longer. As for the virus, such as SARS and COVID-19, they can live in different surface up to 1 day or several days. It all depends on the original microbial concentration, chemical, physical structure of the materials in contact. There are several personal protective equipment which can protect our human being or us. Contaminated surface can be source of cross infections like masks, gloves, and gowns. Sometimes, if there is a linkage and struck through, the protection will be totally lost. Therefore, we have to be careful to wear all these protective equipment. Like last year, when I have international travel, I have to wear N95 masks, and which is very effective, protect me from the COVID-19. So I wear this mask for 1 day, about 8 hours. It's very important to protect personal workers like doctors, nurses, and patients in the hospital. It is also very important to protect the emergency responders. And it's also very important for the general public, like SARS in 2003 in China. We have to protect general person. Therefore, there is a clear need to create antimicrobial materials to enhance protections. Next, let's talk about microorganisms, textiles. Textiles have been recognized as immediate carriers of microorganisms because they have very suitable environments, and they can, such as temperature, humidity, or moisture, or it can also provide nutrition for the microorganism to grow. There are many problems caused by microorganisms. First, they can generate unpleasant odors. It can also cause discoloration of the fabric. Second, it can cause the stress loss of the fabrics. Most importantly, it can cause transmission of infectious diseases. There are many antimicrobial agents developed for textiles, such as metals and metal oxide, cotton salts, PHMB, triclosan, cantharidin, enhalemins. But some of them have drawbacks, such as environmental problems like metals and metal oxide. Some of them have bacterial resistance, short life, and lack of durability. So in our study, we tried to combine different agents and create hybrids. So we use enhalemine and zinc oxide, titanium dioxide to make hybrids composite. And then we coated them onto textile to make antimicrobial textiles. Next, I will talk a little bit about organic cyclic enhalemins. Organic cyclic enhalemins is very efficient in killing bacteria. Since in its structures, it has nitrogen and halogen bond, which can kill bacteria. Since the chlorine and bromine they are oxidative. They can oxide microorganisms. There are different structures for the enhalemins. Generally, they have amine, amide, and imide. Since they have these structures, they have different dissociation constant. So this table shows 3 structures. Like imide, they have the highest dissociation constant. For the amine, they have the lowest dissociation constant. And the killing rate is related to the dissociation constant. The killing rate of bacteria follow the imide, amide, amine, while the stability of enhalemins follows the inverse orders. So therefore, in our study, we try to design and synthesize different structures of enhalemins, which can be bonded onto textiles. Next, I will measure several advantages of enhalemin biocides. First, they are very efficient to kill bacteria in a broad spectrum against virus, bacteria, fungi. Second, they are safe to human beings and they don't have environmental problems. Third, it has long shelf life. Fourth, there is no bacterial resistance. And most importantly, finally, they can be regenerated by simply reacting with Clorox or hot bleaches. As we know, 5-membered and 6-membered enhancements are very stable infections which used in water disinfection compared with inorganic disinfectants like chlorine gas, chlorine dioxide, sodium hypochlorite. So all these 5-membered and 6-membered can be used in water disinfections. So in our lab, we try to modify these structures with function groups which can react with fibers and polymers. First, we synthesize different structures of enhancement siloxane, as shown in these slides. Since these have siloxane, it can be attached onto different substrates such as cellulose, like cotton fabric, polyester, silica gel, sand, and paint. We coated them, and when we studied the biocidal effects, the results showed all these compounds are very effective in killing bacteria. And we also put these cotton swatches into UV chamber to see the UV stability. And so in the table 2 and table 3, we can see if the sample were placed inside chamber with different time from 1 hour to 24 hours, the chlorine of the fabric will lose gradually. And when we regenerated, we found that only 1/3 chlorine can be regenerated. That means the bond between the agent and substrate are not very stable. Second, enhancement structures has nitrogen and chlorine bonds. They are not very stable under UV light. So how to solve these problems? We try to design different structures like benzene hydrogen without siloxane. As we know, benzene have conjugated bonds which are very stable. We made copolymers and then we mix them with cellulose acetate to make nanofibrous membranes. Then we put the membrane on the UV chamber to see the chlorine of the fabric. After 24 hours, we can see we still have 0.08% chlorine, which is still very effective in killing bacteria. After rechlorination, about 85% can be regenerated. That means the bond between the enhancement and substrate are very stable. Next, we try to use another polymers like hydrogen and copolymer with other polymers to make copolymers. Then we produce nanofibrous membranes to study the UV stability. We found similar results occurred with the extension of UV radiation. The chlorine loading decreased. After 24 hours, low irradiation, about 0.5% chlorine remained. After rechlorination, 100% chlorine can be regenerated. That means the chlorine and the bond between the enhancement and substrate are very, very stable. So these results are very encouraging. And we think about other inorganic compounds like zinc oxide, titanium dioxide. Since these compounds can be used self-cleaning antibacterial agent, UV protein agent. So we are thinking, can we mix with enhancements we mentioned before with these inorganic nanoparticles to make hybrids, which can be coated onto textiles for the antimicrobial efficacy purpose. So Therefore, we use these three different structures and mixed with zinc oxide or titanium dioxide. So we use different methods. So here's a list, 5 methods to make antimatter materials. First is cell gel process. So we make enhanced polymers and we add titanium dioxide into the coating solution. We coat them onto cotton fabric. We can see there are covalent bonds formed between titanium dioxide, enhanced cellulose, and cellulose. Since they form covalent bond, that means the durability is supposed to be good. Then we study the UV stability and the washing stability. We put a sample in the UV chamber of the UV irradiation. We also use standard washing test to see the durability after washing. So we have 5 cycles, 10 cycles, 25 cycles, 50 machine cycles. So we have 24 hours UV radiation. From this table, we can see after 24 hours UV radiation, we still have 0.05% chlorine loaded on the surface. After recoloration, about 70% chlorine regenerated. That means all these bonds are very stable when we add titanium dioxide into the coatings. We also look at the antimatter efficacy of the treated cotton against staph and the E. coli. We found the coated fabric can cause total inactivation of staph and E. coli within 10 and 30 minutes. And the current reduction is 6 logs. That means it's very efficient in killing bacteria. We also look at the control sample and the sample with the addition of titanium dioxide. We found that after 24 hours UV radiation, cotton coated with enhancements without chlorine on the surface, while cotton coated with enhancement at titanium dioxide still have 0.1% chlorine loading. After recoloration, control sample recovered 50%, while our sample, we have 85% recovered. Next, we try to figure out the reason why when we add titanium dioxide into the coatings, the covalent bond between our agent and substrate are very stable. So we calculate the transmit structure for the cleavage of the molding systems. First, we find molding compounds like monomer enhanced cellulose. We found there is a bond cleavage on the UV radiation. After calculation of the bond angle and bond length, we got the active enthalpy for the both systems. We found if we add titanium dioxide into the coatings, the active enthalpy is higher than the control sample, 34.8 versus 33.9. And the small difference make the bond much more stable. Next, we use deep pat dry procedure to prepare antimicrobial cellulose. So we add our synthesized enhanced polymers, PSPH, zinc oxide into the coating solution. We make self-cleaning antimicrobial cotton fabrics. From this slide, we can see the chlorine loading and the content angle give us evidence that it has anti-marker edges coated on the surface, and the surface is hydrophobic. When we put the drop of the water with dye on the surface, we can see our sample are very clean. Next, we test the antibacterial efficacy of the coated sample. We can see similar results were obtained. Within 30 minutes contact, 100% of staph and E. coli were inactivated completely. We also look at the biofilm controlling ability of the control sample and the prepared sample. The control sample cotton shows biofilm on the surface clearly, while the coated sample shows a little bit biofilm, which means the film control ability of the treated sample are very good. We also look at the UV stability of the coated sample and the sample with zinc oxide. Similar results were obtained compared with titanium dioxide. We can see the addition of zinc oxide can improve the UV stability of the chlorine of our coating. Third one is emulsion polymerization. Since the second project, we add titanium dioxide, zinc oxide into the coating solution and mix them, then coat it onto the cotton. So we are thinking, can we wrap nanoparticle inside, and outside is our enhancement polymers. And if we put UV chamber, can the system or coating improve the UV stability? So we coated them onto the cotton fabric. We found the motion stability is slightly weaker than the second and first project, but still very good. After 25 washing cycles, we still have 39% chlorine loading on the surface, and it's still very effective in killing bacteria. And the antimarker efficacy of the coated sample against staph and E. coli are still very good. So I want to go to details. Next, we look at the oxidative chlorine content on the coated surface under UV irradiation. We found the additional titanium dioxide inside the core shell structure are very effective in protecting the cleavage of the bond between the substrate agent and substrate. And over 73% chlorine can be restored. We also studied the UV radiation rechlorination cycles, and we use it and we test it, and we found it's very stable. Next, we look at the bacterial film controls. Similar result observed, and we can see the control sample. We can see the biofilm on the surface, while the bottom line there is no biofilms on the surface. Next, we look at the layer by layer technique for the coating of the enhancements of the cotton fabric. We make cationic polymers and anionic polymers. We coat them onto cotton fabric by layer techniques, and we make antimicrobial cotton fabrics. And we found the motion stability of the coated cotton are very stable. And after 20 washing cycles, almost 90% can be recovered. And also biofilm controlling ability of the treated cotton and the layer by layer treated cotton compared. Similar result observed. And after layer by layer coating, the first surface so cotton fabric are clear and without biofilm on the surface. And UV stability also showed the after UV irradiation, also the chlorine content increased. We also test the biocompatibility of the coated samples. We can see cell viability of the coated sample very good. Over 85% treated sample have live cells. Last, we use heat press technique and we add zinc oxide to cartesian films. And then we test the antimalware efficacy and UV stability. We found the prepared samples are very good at in killing bacteria. And almost 99% bacteria can be killed within 30 minutes. So next slide shows the biofilm controlling ability of the treated samples. We found and similar result obtained. If we look at the last pictures, there is no biofilm on the surface. And the UV stability also very good. I will not go to details. So here's the summary. So we prepared the enhancing and the titanium dioxide, zinc oxide hybrid composite. We coated them out to different substrates like cotton, nanofibrous membrane. We found the addition of the zinc oxide and titanium dioxide can improve the UV stability significantly. They can also improve the durability of the enhancement in killing bacteria such as Staph and E. coli. Acknowledge, I would like to thank my group members for the contribution. I also want to show my thanks to our collaborators, Professor Orlando Acevedo from University of Miami and Professor Huang from Auburn University. So thank you all for listening. Any questions?
Thank you very much, Prof. This is very informative talk. I have got a couple of questions for yourself.
Okay.
Prof, there is one question. Zinc and titanium oxide produce reactive species, oxygen reactive species under UV light. Don't they degrade in halamine? Please, could you comment on that?
Could you please repeat?
Yeah. Zinc and titanium dioxide produce reactive oxygen species under UV light. Don't they degrade and halamine? So,
okay. So you mean the titanium dioxide, zinc oxide itself can produce species that can kill bacteria, right?
Yeah, reactive oxygen species they produce under UV light.
Yes. Yeah, you're right. So for our research, we are more focused on the UV stability with the addition of zinc oxide and titanium oxide. And if we irradiate our coatings and the antimicrobial efficacy is supposed to be higher than the data we show. Right?
Okay. I have another question, Prof. Can biotechnology enzyme be used to impart the antimicrobial property instead of chemicals?
Okay, say again.
Can biotechnology enzymes be used to impart the antimicrobial property instead of chemicals? So can you?
Yes, but
please.
Yeah, that's their antimicrobial efficacy is mild. first. Second, so because the bacterial resistance, it happens to all these antimicrobial agents. But as for the unhealthy, no problem, and our system can kill most of the bacteria and fungi and virus.
Okay, okay. Another question, please. What are the alternative application for antibacterial fluid onto the textiles? Application like spray system. Could you please comment on that?
Also, as for the applications, I think protective clothes in hospitals and another application might for the emergency responders. I think sometimes they are exposed to unknown microorganisms like a virus, like especially like COVID-19. We don't know. We can, if you wear this kind of protective clothes, it can kill bacteria very short time.
Okay. Thank you very much, Prof. Thanks a lot. Thank you.
Thank you.
Thank you.
Thank you very much for the listening.
Thank you.
Thank you. Bye.
Bye. Bye. Assalamu alaikum, Prof.
Walaikum salam.
Abdul here. Hope you are okay and doing well.
Yeah, Alhamdulillah, I'm okay.
Welcome again to the conference here in NTU.
Thank you.
Yes. I just would like to introduce Professor Sapun Salid. Hope everyone knows. Professor Dr. Muhammad Sapun Salid is professor in the Department of Mechanical Engineering and Manufacturing, Faculty of Engineering, UPM. He has been awarded with Top Research Scientist, Malaysia 2019 in the field of materials and concurrent engineering. Professor Sapun Salid is working on composite materials, biocomposite, concurrent engineering, natural fiber composites, materials selection. Today, Professor will talk on contribution of biocomposites during COVID-19 pandemic. Please, Prof.
Thank you, Dr. Abdurrahman.
Thank you, Prof.
Assalamu alaikum warahmatullahi wabarakatuh. And very good afternoon and maybe good morning in some part of places in the world. Okay, thank you so much again for inviting me for the third time as a keynote speaker in your conference. I'm very happy and very glad for this continuous collaboration. Can you see the whole screen, Dr. Abdurrahman?
Yes, please. Yeah.
My PowerPoint is okay. Thank
Yes.
you. Okay. The topic, the topic that I'm trying to discuss today is the contribution of biocomposite during COVID-19 pandemic. I think the topic is very close to us, to all of us now. And the co-author of this presentation is my master student, Mr. Harusani. Okay, the outline of my lecture today is the in problem statement, biocomposite solution, and I will review some biocomposite, in fact, not just biocomposite, biomaterials during the COVID-19. And I will focus on two of our recent work that we got grant on the COVID-19. So one is on biocomposite char, as well as recycling awareness, and that in that there is some work on the biocomposite product that we developed, and finally conclusion of the work. Okay, as the introduction of my work today, despite the numerous merits attached to the use of petroleum-based plastic, they bring about severe environmental impact. Yeah, as we see from the pictures there, you know, the pollution in the ocean and also in the land due to the plastic waste, and this has posed a lot of problem globally. Non-biodegradable nature of petroleum-based plastic has posed great environmental challenges, which contributes to the rapid exhaustion of landfill. So the research that we carried out is on biopolymer composite, and hopefully this research to some extent will, contribute towards solving some of this problem. Okay, the growing environmental awareness had directed the attention of many researchers to the green materials, renewables, the term that people normally use, recyclable, sustainable, biodegradable materials. And one of the product that we focus on, the material that we focus on, natural fiber reinforced polymer composite, or in short, it is biocomposite. Natural fiber composite, the fiber is mainly from plant-based or animal-based, and the polymer, they can be from the synthetic polymer in the form of thermoset or thermoplastic. But in the recent year, the work has been geared toward working on biopolymer, which is 100% bio-based polymer composite, for that matter, has received increasing attention in industry as well as in academic, in university research. So we have been involved in this research for quite a long time, and the work that we have carried out, and more focus nowadays on the use of the forest product, forest product to form the product, the final product, the raw material is from plants and from the forest in the trees. Okay, the natural fibers, which is the fiber that grows or develop and come from natural resources like plant and animals. So why you want to choose natural fibers compared to synthetic fibers? Of course, synthetic fibers have been around for a long time, and there are, of course, a lot of good advantages that they carry. However, we focus on natural fiber as we believe that natural fiber is a good substitute for synthetic fiber in certain application. In terms of density, yes, it is lightweight, and even twice that of lower than the synthetic fiber, meaning that synthetic fiber is twice much heavier than natural fiber, and the cost. It is low cost, and in many places it is no cost at all. You can get it for free, whereas synthetic fiber, they are more expensive. They are renewables, recyclables. It's widely distributed. You'll find, especially in a tropical country like Malaysia, you find a lot of resources still being untapped. They're regarded as the agriculture residue or waste. So a lot of potential for that matter. And then the health problem, yeah, there is no health problem when you inhale, and it can be biodegradable. Whereas in synthetic fiber, we know they are non-biodegradable materials. Okay, I would like to discuss the major classification of natural fibers. Animals, they are from, for example, silks, and from hair, bulk in the form of wools, animal hair or horse hair, and even we can find natural fiber from chitosan, from the shells, from the marine environment, aquatic environment. But mostly they are from vegetable, from plant-based, either from seed, cotton, from the inner bark, for instance, in flax, hemp, jute, kenaf, rami, from the leaf like abaca. Mainly you will find it in Philippines, sisals, and from fruits like koi. And this is the common like fiber that we find worldwide. But in our country, being tropical country, we have the source of fiber from, sugar palm, from oil palm, from pineapple leaf, from banana stem, in roselle, for instance. There are a lot of resources that we can benefit from, that can take benefit from. Okay, I just want to highlight, despite my title is more on COVID-19, one say recent work or even two research work that we have carried out with the STRIDE, from MINDEF. This is the Science and Technology, Defense Science and Technology of Malaysia. And my former student, Dr. Ridwan Yahya, he was very pleased that I can introduce his work also to the audience, that he himself at STRIDE, MINDEF in Malaysia, carried a lot of research on, the topics like ballistic protection, on defense technology, composite and defense technology, and the textile composite. He has a lot of interest, and we ourselves at University Putra Malaysia have done some collaboration with Defense Science and Technology Research Institute in Malaysia. So the work that we have carried out together is on Kevlar and natural fiber reinforced polymer hybrid composite for certain product like hard plate for military body armor, and the PhD work of Dr. Ridwan was on spall liner for military vehicles. We published quite a number of papers, and we did some work and testing, and so the potential for this material is to reduce the use of synthetic fiber. This is really the core work, meaning that you want to replace the synthetic fiber, the use of synthetic fiber, like in that case Kevlar, with the secondary use in secondary armor at low impact resistant requirement by partially replacing it with natural fibers. Yeah, in this lecture, I'm focusing on kenaf as well as coconut to make hybrid composite. Okay, this is one of the work on armored vehicles spall liners. Okay, on the right hand side in market, you'll find that the spall liner is made from e-glass or S2 woven glass with polyethylene or polypropylene and aramide fiber. This is existing in the market. So our research, focus on natural fiber composite panels. Spall liner are a composite panel made with the synthetic fiber mounted to the inside of the shell structure of armored vehicle. This is what in existence. The spall liner protect personnel inside by catching spall fragments of the outer shell blown into the vehicles by the concussion of incoming ordnance before it contact them. It is used alone or in combination with metal or ceramics. So spall liner help increase crew survivability in combat. So if you look at the pictures that the figure that with and without spall liner, even of course with spall liner is better. So this is the work that we carried out with the Kevlar, but we try to reduce the percentage of Kevlar by replacing with woven kenaf. Then we come up with a hybrid laminated composite, and this is the result that we find after the ballistic test. And of course, 100% kenaf composite with the best result, but sorry, Kevlar, 100% Kevlar give the best result, but by adding some percentage of woven kenaf into that spall liner, of course the performance reduced a bit, but it can still, fulfill the standard and do the job. Okay, another work is really on with the STRIDE MINDEF in Malaysia, with University Putra Malaysia. Actually, I'm not really involved, but my staff involved in this, on the bulletproof armor vest made from parts of coconut tree, and there are some part of coconut tree. I think it's quite difficult to describe the product, the part of the tree. We call it slowdown in our country, but there's some term in English. But mixed with the hybridized with the Kevlar to form that bulletproof armor vest. And this was last year was publicized widely in the news and also in the media in Malaysia. Though I don't think so far this has been commercialized, but maybe some company have been interested in to invest or something. But I don't think they're going very far. Just I think they patent the product and they also have the IP for this. Okay, the result of the work with Stride, the one chapter we published in the book in composite solution for ballistic. It is really the joint work between National Textile University. After 2 years, now we have been working together. We managed to publish the work, between the National Textile University, the Dean, Dr. Yasir, and Dr. Khubab, with myself. And the book is going to be, available, I think, from the 1st of August. I think I just saw before I just attend this conference. So this is published by Elsevier and a good publisher. So hopefully we'll benefit from this. Okay, now the topic that I'm going to deal today is on the COVID-19, because when the COVID-19 started last year, the government invited me, the university invited me and my team to propose, 2 projects. One is from the international grant provider, and one from the Ministry of Higher Education. So basically, as we know, that coronavirus disease 2019 or COVID-19 is defined as illness caused by a novel coronavirus, which is called severe acute respiratory syndrome coronavirus 2 or SARS-CoV-2 or 2019 and CoV. It was first identified in Wuhan, China, late 2019, and spread vigorously throughout the globe until today. So this is the pictures that we normally saw, almost every day, and how the pandemic affected the people throughout the world. And then the case keep on increasing, particularly in our country. At one stage last year in July, it was reduced until a single day. There's no case in a single day, or 1 or 2 cases. But early this year, it has jumped again, until even 2,000, 3,000, in 2 to 3 days, until 5,000 cases in a day. But now yesterday it was reduced until 1,000 something. It's quite low yesterday. So we're still in lockdown in Malaysia, and see how many deaths and how many people have infected by these pandemics, and they keep on increasing throughout the globe. And fortunately, there are a lot of people also recovered. So the spike of coronavirus case has contributed to the shortage of face masks and protective personal equipment, but they are being used globally. So the increase in demand and supply of the petrochemical derived PPE. So the environment, because of this, they cause the environmental pollution, and also by chemical consumption from poor plastic waste management, as we can see in the pictures, how this turtle get affected by this, the presence of the mass that is being thrown in the river or in the ocean. Now, the scientists, the expert, they come up with a solution how to make use of this, the need for fully bio-based face mask to counter coronavirus outbreak. And some review paper, some work has started, and face mask in the new COVID-19 normal material testing and perspective. So meaning to partially solve this problem is to utilize biomaterials and biocomposite, for that matter, because I'm biocomposite man, to produce sustainable and green product. So meaning that from the waste, we try to convert into something that can be useful as far as composite or biomaterial is concerned. So bio-based materials like biocomposite, and biocomposite product have high performance, meaning that not really high, but there's comparable performance in terms of mechanical and thermally, and they are, of course, they are eco-friendly. So now, okay, I think I just moved, talk slightly different topic on the global natural fiber composite market. I think, despite the problem in the pandemic, the market until 2020, the global natural fiber composite increased annual growth rate of 5%, being accelerated, incremental growth of 1.49 billion, and the growth also increased in North America, and also in 2020 last year was 3.88%, and market impact is neutral. I mean, it's not bad in terms of market, but I'm not economic expert, so I just put it this information. Now, I think because we are talking about biocomposite in pandemic, so I review a little bit work in the past on biocomposite during the COVID-19 pandemic. So one work in Italy by I think the company agencies for SOS, Smart Operating Shelter Project. The project itself called Smart Operating Shelter Project is an innovation of fast-built mobile healthcare structure. So they developed the structure for healthcare, by biocomposite. This is some work on biocomposite during pandemics. And in that SOS project, 3 different panel typologies designed for vertical cladding of shelter, and innovative sandwich panel in a course using bio-based polyurethane, meaning that is a bio, and recycled PET foam. Eco-friendly composite laminates for external sandwich panel skin using natural fiber and bio-based polyurethane. Okay, it is not biocomposite. I think it's just biomaterial, electrospun and compression molded gluten. This may be biocomposite. Gluten used as bio-based mass raw materials. Thin film of gluten with less than 10% by weight of linosols bonded together with carbonized mat to form face mask. I mean, some do work on bio-based material are used in the face mask. And there's one work on, I think, on the use of herbal extract, such as tea tree oil, extract of olive, extract of the jackfruit seeds extract, mangosteen extract, and others. They have been sprayed on the surface of fibrous polymeric filter, which is for antimicrobial properties, and like in the previous lecture. And the herbal extract coated filter demonstrated good antimicrobial activities. For the polybio skin, so bio-based material for skin contact product, polylactic acid, and starch, cellulose, chitin to produce innovative cosmetic, biomedical, and absorbent hygiene application that are bio-based 90% or more and biodegradables. These are some work on the, at least if not the biocomposite full, but the constituent of biocomposite got involved, like polylactic acid, starch, chitin. This is the material that we use normally to make biocomposite. So this is the detail of that previous project, a previous slide, and sanitary diapers, cosmetic, beauty mask, and wound care, wound dressing. I mean, they are trying to use this for the skin product. I mean, to use some biomaterial and biocomposite. Okay, this is the work carried out by Biocomposite Center in Bangor, in UK. Of course, the center itself is a biocomposite center, but the product is, I think I didn't see it's a biocomposite yet, but it is a bio-based material from shell. I mean, the cracked shell. I mean, we normally use this as the filler for the biocomposite, which is chitosan. So they use chitosan to destroy the virus. Yeah. This is done by the Biocomposite Center, but the detail how the product was made is not known yet. I didn't go into detail, but I just saw this. I want to share it, that there are the work on chitosan also. Mainly chitosan is used as a filler, and then mixed with a certain matrix and to form biocomposite. So this one recent work during the pandemic in Bangor University. Okay, there's one work on disposable bed sheet assist in minimizing cross-infection risk emanating from linen washing. This biodegradable, hypoallergenic, allergenic, compostable, stain-resistant, and lightweight. Okay, and also this work on the 3D printing and using the biocomposite material. And fortunately, the product was developed in Kuala Lumpur, in Malaysia. And the 3D printing technology helped healthcare workers of COVID to make antibacterial biocellulose mask from biocomposite material. And it is not a Malaysian paper, but it is reported that it is being made, the product in Kuala Lumpur, not far from my house. Okay, now I want to focus, time's not much, on our research on biocomposite during COVID-19. We got the grant from the Ministry of Higher Education, 20,000 for 6 months to make the non-woven polypropylene waste into briquette char through pyrolysis system. Last year we got with the objective to for the optimum carbon char yield as a PP pyrolysis product using different pyrolysis temperature. I'm not chemical engineer, I'm mechanical engineer, but my student, he's very diligent and working on that. Within 6 months, the project was completed and was reported to the ministry last week. To determine the best ratio of carbon char, PP, and sugar palm starch, which is biopolymer for plant as metric at the ratio mentioned. We study the compressive strength as well as calorific value. Put the production of green carbon briquette product through pyrolysis green technology. And the ideal pyrolysis temperature for maximum carbon yield is 450 degrees C, supported by TGA and of the PP residue. And the best ratio for the carbon briquette is with the ratio of 90% carbon and 10% sugar palm biopolymer, which has a high mechanical strength and high calorific value. So the result of this study will promote the method of pyrolysis green technology, the production of carbon char from waste material and from the COVID-19 product to help to address the problem of waste disposal as a result of treated COVID-19 patient in a systematic and controlled manner. Okay, this is the chart. We collect the PPE from our clinic, health center. We wash and dry the collected PPE, prepare the sample, pyrolysis of PPE, produce the briquette from char, and finally, this is the product. On the left-hand side is the polypropylene powder from PPE, the gown, cloth, and the right-hand side is the product by composite. We plan to patent it, very soon, and hopefully, can leading to finally in commercialization. So char yielded from thermal cracking of non-woven polypropylene personal PPE. We got a lot that being underutilized, being thrown as a waste mixed with a sugar palm starch biopolymer. So this is how we do the process. We collect from the center and we follow the SOP, and we wash them and the clothes, and we do some pyrolysis of the waste in a furnace, and we crush them in pulverizing machine and form the powder of polypropylene, and we use the thermal decomposition was carried out, and also in a pyrolysis reactor, and in pyrolysis, which we are slow pyrolysis, and this is all chemical engineering stuff, which I'm not very expert in that. And we have char plus sugar palm starch, and we have the sugar palm char biocomposite. This is the product, and it is good for composite additive, fuel application, absorbent for water treatment. Acid treated char has higher surface area for nano filler and nano sensor application for sensor application. Okay, the second project briefly on the society awareness of the recycled COVID-19 PPE waste towards environmental sustainable green technology. It was funded by the USAID and in collaboration with the Malaysia One Health University Network. And actually, this is more on the awareness to the public. And then we make some webinar attended widely worldwide. I think more than 1,000 people attended. Speakers from France, locally, and from US, from Indonesia, giving the talk on different topics of the awareness on the waste from the COVID-19. And we have done some kind of one-stop center for the student, how they want to dispose the face mask. And we also give some, teaching and also some kind of awareness to the student, how to wear the face mask properly and what are face masks all about. And on top of that, we have developed some video, and at the end, we make the product, from the, mask, which is we can consider, of course, PP is not the synthetic polymer, but there's some cotton there, which is we can consider is as the from biomaterials, and then we cut them, and then when we have the mold with 3D printer, and then we'll put it we make the product. At the end, we can have simple product as a mask, a mark holder. So simple product, but this is from the the pandemics, COVID pandemics waste face mask. Okay, the conclusion. UPM, University Putra Malaysia, plays a role during the COVID-19 pandemic. Our research group carried out research related to recycle PPE, face masks, as well as the clothes PPE from polypropylene to make biocomposite product. In this case, the char as well as the mark stand. The biocomposite product in the form of biocomposite char from COVID-19 PPE and biopolymer have good commercialization potential. I would like to thank Dr. Yasir Nawab and others, the staff, Dr. Abdul Rahman, Dr. Javed, and others, and also Dr. Professor Tanwir Hussein, the rector, for always inviting me to be with you, and also the funder, Ministry of Higher Education in Malaysia, USAID, and my own for research grant for this project. Those 6 months for both. One project is 6 months, one project is only 1 month. It's tough time for us to deliver, but we managed to complete both projects. And Dr. Ridwan Yahya from Stripe Mindep, who want me to try to introduce Mindep to you, so that we can have collaboration. We have also good, textile, the composite center, which is headed by Dr. Ridwan Yahya in Malaysia. With that, ladies and gentlemen, again, I would like to thank you. I'm timely in 4 and 5 or 6 o'clock in Malaysian time, and to share you for the third time, research finding. Thank you so much.
Thank you very much, Prof. Thanks a lot. Prof, we have one question.
Yes.
Yeah. Can we use banana stem and banana stick for the composites? Banana
oh
stick
yeah. Yes.
They are very natural.
We have done a lot of research on banana stem, from the stem, right? There are people who work from leaf, but in our country, the one that we use is on banana stem, banana stem, we call it. So the product is lasting. There is house now, 2001. Finally a student project for banana with epoxy, and it was for telephone stand. Those days we don't have mobile that much, so it is remain intact, and also even to the extent that one company willing to invest to commercialize that product. So this is a good potential. Of course, this biopolymer, the natural fiber, you encapsulate it with the polymer. So they're going to last for long, 20 years, no problem. They have good potential, and as you know, banana is not being used that much. You throw it away. So it's good. And in fact, I suggest research in Pakistan and worldwide to work on banana as the fibers, natural fiber for polymer. Thank you.
Thank you very much, Prof. Thanks a lot. Thanks for your time and the presentation. Lecture very informative. Thank you very much. Yeah. Now I would like to invite Professor Usha Masika Bihari from France. Hello, Prof.
Hello, can you see my screen?
Yeah, I can see, yes.
And you can hear me, it's okay?
Yes, Prof. You are
okay.
You all right today?
Yeah, fine. Thank you very much for inviting me, and especially Munia Ashraf, who I have had opportunity to supervise his master thesis. And I would like also to thank Professor Salit, who presented his work on biocomposites. Really very interesting, and recycling of these masks and PPE. It's really very interesting. So today I have chosen to present a review paper that we published during COVID-19, and it's on universal masking during COVID-19 pandemics and how can textile engineering help in emergency situations. So I'm associate professor at Gemtex in France, and mainly working on eco and biotechnologies for textile functionalization and application to biological media. So, so ANSET is in France, north of France. We will have Professor François Bossu also in this conference. We are 40 professors with engineers and technicians, and about 400 students enrolled and 40 PhD students. So let us see this the review paper we published, which is also available online for free that you can download. So first of all, this COVID-19 is caused by this virus, SARS-CoV-2, which is approximately 60 to 149 nanometer in diameter, and compared to bacteria, which, for example, if we take it in E. coli bacteria, which is 2 micrometer in length. And so this virus is approximately the same diameter as HIV, but we have also got different sizes of virus. So let us today consider the COVID-19 virus. It has got a structural viral envelope, I mean the membrane, which is similar to that of bacteria with this lipid bilayer envelope, which is negatively charged, but also proteins projecting in the form of spikes, which are hydrophobic. So overall, these viruses have a hydrophobic surface, which are negatively charged. Well, they don't occur alone. They are often several viruses in water droplets or respiratory aqueous droplets. And what happens when these droplets are expelled during coughing or sneezing, they are going to travel. And while traveling, the water evaporates. And what happens? The size of the droplet decreases until it forms a droplet nuclei. So this is taken from literature work showing the dimension distribution, the coughing droplet size distribution without mask. And the dimensions of the droplets vary from 0.1 micrometer to 15 micrometers in diameter. Well, so it's quite big, 15 micrometers. And smaller droplets are brought as a cloud through the air, while large droplets travel ballistically through the air. So masks can reduce airborne transmission, and infectious aerosol particles can be released during breathing and speaking, even by infected asymptomatic patients. That's why universal masking is advised. So as far as mechanisms of filtration are concerned, the mechanism depend on the particle size. For particle size less than 300 nanometers, we have the diffusion regime, while particles higher than 300 nanometers, we have initial impaction and interception, which are shown here. But viruses and bacteria are more difficult to filter because they have got the size of most penetrating particles. Well, surgical masks, there are 3 different types, and filtration efficiencies can go up to 95% for 3 micrometer diameter viruses or bacteria, which are of this size, whereas the respirators FFP2 N95, they filter up to 94% of 200 nanometer diameter bioaerosols. Both of these are made up of melt-blown polypropylene, one or multi-layers of these melt-blown propylene, which are very fine fibers, 600 nanometers or well below, depending on the method used and on the degree of stretching. So also these fibers are charged electrostatically using corona discharge. So these are mostly positively charged polypropylene fibers, and so they are going to easily attract viruses which are negatively charged and hydrophobic. Hence, these equipment are well manufactured to to filter bacteria, but if water molecules is in between the fiber and the viruses, then the filter will lose its efficiency. That's the aging. That's why we can wear a surgical mask only 3 hours. Now the question was asked, especially when the equipment were lacking, and the question was, are cloth masks efficient? So we made a review paper and we found out that the filtration efficiency vary a lot, and the particles that have been used for filtration vary a lot also. For example, Rangasamy worked on sodium chloride sodium chloride aerosol particles varying from 30 nanometers to 1 micrometer. And Shakya worked on polystyrene, which are hydrophobic materials, having the same diameter, 30 nanometers to 2.5 micrometer. So Rangasamy showed that whatever the fabric chosen, the particles could penetrate at different degree, different fabrics, but the N95 was very good, no penetration. Shakya showed that with polystyrene particles being filtered, cloth mask, for example, cloth mask 1 was very efficient and much more efficient than surgical mask. But the best one was still the N95. Of course, nothing was given on the structure of the textile which were used for the cloth mask. Then Davies, he worked on filtration of real bioaerosols, a bacteria Bacillus atrophius, about 0.9 to 1.25 micrometers, and a bacteriophage 23 nanometers, which is the size of viruses. And he compared cotton t-shirt, tea towels, pillowcases, etc. And with surgical masks, the filtration of these bacteria, B. atrophius, was 96%, with a pressure drop of 5. When tea towel 2 layers were used, the filtration efficiency was 96%, so approximately that of a surgical mask, but the pressure drop increased from 5 to 12, meaning that if pressure drop increase, the breathability decreases. And then he also tried with 20 volunteers coughing without mask, with a homemade mask, and with a surgical mask. For example, for particles between 1 and 2 micrometer out of 100 particles being ejected, with the homemade mask, only 16 particles came out, and with the surgical mask, 6 particles. Of course, surgical masks are much more efficient, 3 times more than the homemade mask, but the homemade mask also is efficient. Then recently, just during the COVID period, Konda published another paper, and he tried to filter non-infectious aerosol particles. He used single-layered, multi-layered, and multi-hybrid layers of textiles. So here are the results with 4 different textile materials. So what is really interesting is that we can see lots of variation of filtration efficiency, but he showed that, for example, if you take 1 layer of silk, here is a filtration efficiency. So it was a silk scarf, and you just fold it into 4 layers, and the filtration efficiencies increased for all particle sizes. I mean, even in the range of less than 300 nanometers, we had very good filtration efficiency up to 80%. And then he tried complex multiple hybrid layers, mixing 1 layer of cotton with 1 layer of silk, or 1 layer of cotton with 2 layers of chiffon. So chiffon, they were very fine fabrics of blends, 90% polyester, 10% polyurethane, and also cotton and flannel based on blends. And he found that in red, you have filtration efficiency of a surgical mask. And with these blends, with these hybrid layers, multiple hybrid layers, filtration efficiency increased dramatically. So it was the same case with the other hybrid layers. So he concluded that fine fibers, tightly woven fabrics, but also electrostatic effects and fiber surface properties can have an impact on efficient filtration, but there was no science behind all these studies. So if we look at theory of triboelectric series, we can find that some materials can be positively charged when you rub one material against another. There can be some materials which can easily lose electrons and become positively charged. And once it is positively charged, it can, for example, attract easily negatively charged viruses. So maybe this is a possible explanation, but science must go more further. It must go further to find out what was the real explanation for this. Now, another point is that all the studies that I have presented were carried out at 33 liters per minute at the flow rate. Now, what will happen if we are using higher flow rate? So flow rate, if we take, for example, normal inhalation, we are about 15 liters per meter. Doing yoga, we increase it. But for forced inhalation or exhalation, we are approximately at 80 liters per minute. So in this case, only respirators can be used where low penetration occurs at a higher flow rate. In the case of a hybrid cloth mask, they are really very good for asymptomatic patients where patients are infected, but they are not coughing, no sneezing. So there is a less risk of penetration while coughing or sneezing. So it's really interesting to use these hybrid cloth masks. Now the question is how to select the proper fabric, because if you read all the articles, you will find no information, only information on the fiber nature used or in the blends, and no information on the yarn count, on the fiber diameter, fabric structure, while these are very important parameters determining the pore sizes and the porosity. No information on scoring process use, any sizing, desizing, or finishing, because these can impact on the surface properties and hence on the filtration properties also. So research must be done and robust database available. In France, there is a confidential data available for manufacturers, but the masks are just for filtering free micrometered particles, and they are not allowed for medical uses. Now, how can we enhance the protective efficiency of cloth masks? Many researchers are talking about the use of electro-spun nonwovens, but care must be taken because the pores are so tiny that the pressure drop increases very rapidly, which may hinder the breathability of the mask. And also we can engineer an antiviral textile layer. Most researchers have worked on hydrophobic polycations, mainly quaternary ammonium compounds, which make the textile positively charged and hydrophobic, which attracts the viral cell membrane, causes a rupture of the membrane and leakage of RNA and inactivation of, for example, influenza viruses. So this has already been carried out on the other viruses and can be tested on this corona COVID-19 virus. The problem is, again, the toxicity related to the products, and most of them are toxic to environment and also to human health. Now, of course, as our previous professor presented, many research work are being carried out on alternatives, bio-based materials such as tea tree oil, eucalyptus oils, or even quercetin. If you take the onion peels, which contain quercetin, this is very efficient, and research work has been published to show the efficiency of quercetin. Now, these products are, of course, self-biodegradable and won't pose problem of environmental contamination. Much more research work should be made to see how can we graft the molecule on the textile material, and are they efficient after grafting? Do they remain antiviral, and for how much time? Are they washable or not? As far as our research work is concerned, we try to functionalize polyester fibers with essential oils of vanillin, of phenol, carvacrol, and cinemaldehyde, so mostly used in spices. I mean, Asian spices. So most of them, and we try to test the antibacterial activity and textile polystyrene functionalized by diffusion method were very efficient against Staphylococcus aureus and Klebsiella pneumonia. This work has been published recently. Of course, we must test the efficiency of these essential oils on these viruses. Of course, this is just one functionalization method, but it opens doors to how different methods can be used to functionalize textiles with these bio-based materials. Now, in case of pandemic situation and of panic, we must not worry, because even if you have cooking sodium chloride salt, researchers, so this one was published in 2016, and he demonstrated that we can just soak mal-blown fibers with sodium chloride and some surfactant, that is some soap. You can take some soap which contains surfactants, and when the sodium chloride dries, you can see the pictures of the sodium and chlorine ions, and these salts are very efficient in deactivating the H1N1 influenza virus. So it has already been proved these salts are going to increase osmotic pressure when the droplets fall down, and influenza virus was damaged even after 5 minutes of incubation. Okay, so that was for antiviral layer. And another strategy, as we talk about that for respiratory, we have got respiratory droplets, and it could be very interesting also to repel the viral droplets on the outer layer of the mask. So some sort of super repellent fabric with a very slow, low sliding angle, in addition to the antiviral layers. So this work of Cato, which was published in 2019, proved that the reduced viral carryover dependent on the water repellency of materials. For example, here on this surface, we can see the fluorescent green fluorescent viruses. And here, when a non-woven polypropylene spun bond, melbourne spun bond, 5 layers, which was treated water repellent with a water repellent finish, that is without blocking the pores of the non-wovens, and we can see very small quantity of virus adhering. Whereas when we use a fabric coating on polyethylene, then the viruses do adhere. This is due to the high water repellency of the water repellent treated surgical gown. With the slide angle was smaller than the fabric coated 51. It was not very small, not 10 degrees, but we can see the efficient reduction of viral carryover. So this is very interesting, and we can think about emphasizing this super repellency using zinc oxide, like Munir did during his PhD. But when we are using mask, we must take precautions, because if particles go in air, there's a risk of inhalation of nanoparticles, which are, though, efficient in giving lotus effect. So inhaling these nanoparticles can cause risk of health problems. Also, with fluorocarbon coatings used for repellency, we have got environmental risk. So lots of work are being carried out by researchers right now, even in Europe, in USA, and in Asia, in other countries, Asian countries, etc., to find out more environmentally friendly hydrophobic water repellent coatings. So let us wait. But it has been shown that the fabric roughness has also an influence of this on this water repellency. So what should be advised is to choose also the right fabric roughness to have the least sliding angle to make the most water repellent fabric to repel virus droplets. So as conclusion, we can see that cloth mask, if the textiles structures and are properly chosen, can be efficient for asymptomatic patients with limited flow rate of 33 liter per minute. Best filtration can be achieved by multiple hybrid layers. Of course, electrostatic charges are very important in addition to fine fibers and tightly woven fabrics. These cloth masks can be enhanced in efficiency using biosourced antiviral products or even just cooking salt, as I said. And improved water repellency is important in case of virus droplets being concerned, such as in the case of COVID-19. And in the case where there is transocular contamination, face shield will bring additional protection. And if this can be made right with plastic bottles, as in the case of our pandemic situation. So if we are waiting for post-COVID, another situation, pandemic situation, we have to work on this to understand how it works, and that's all. Okay, so thank you very much. And this article can be downloaded here. So while we're discussing, I will put it in the conversation.
Thank you very much.
Thank you very much for your attention.
Thank you very much.
And if you have got any questions, I can't these participants. Is there a discussion? Yeah.
No question at the moment.
Okay.
Presentation is. So thank you very much. Thanks a lot. Thank you.
Okay.
Thank you. Now I would like to invite Professor Yaqub Aukut. Professor Dr. Yaqub Aukut is professor in the Department of Textile Engineering, Bursa Uludug University. His research areas are technical textiles, composites, polymeric materials, biomaterials, nanomaterials, biosensors. Today, Professor Yaqub will talk on using nanofibrous interfaces for enhanced electrochemical genetics. Please, Professor Yaqub, over to you. Thank you.
Thank you very much for this nice introduction.
Thank you, bro.
Can you see the presentation?
Yes, please. Yeah, I can
okay.
see.
Okay, I am going to start now. So today I would like to introduce using nanofiber interfaces for enhanced electrochemical genetic biosensors. Genetic biosensors are very popular nowadays. So it's gonna take more attention, I think. I would like to mention about the electrochemical genetic biosensors and genetic molecules to applicability for genetic biosensor application. In this presentation, actually, I used electrospin nanofiber electrodes. I would like to also talk about the electrospinning process a little bit and the transformation of the knowledge from the electrospinning process to electrochemical biosensor applications. If you look at this illustration here, there are two main genetic molecules called RNA and DNA, ribonucleic acid and deoxyribonucleic acids. As you see, there are nucleotides on these chains called cytosine, guanine, adenine, and uracil on RNA. Instead of uracil, there is a thymine in DNA. RNA molecules are a single-strand molecule. if you look at the DNA molecule, it's a double-strand molecule, which is called hybridization, to coming all those two different strands together. Basically, we are focusing on this hybridization by measuring the oxidation potential of these bases to look at if this hybridization is occurring properly or not. As you see, all the nucleotides have their own chemical structure. So this chemical structure can be oxidized at an appropriate condition. So what's happening if there is oxidation or there is a damage on the genetic molecule? It can cause loss of sickness. So we should detect as early as possible as damage to apply a proper healing process. So the genetic biosensors are very feasible and they have very promising features to work on. So basically what we are doing, we are looking at the oxidation potential of these bases by using differential pulse voltammetry, which is an electrochemical measurement technique. So let's consider this blue line is a one probe of the genetic molecule. If we look at the oxidation potential by using DPV technique, we are going to obtain a signal depending on of the bases, especially guanine base is more oxidizable bases on the genetic molecules. We are going to have a very strong peak from one single probe. If we combine this one single probe with a non-complementary strands, there will not be a hybridization between those two chains. So the signal will decrease. If we are going to have a complementary, the signal will increase again. If we, if we have a non-complementary, there will not be hybridization. The signal will not change. But if we have a complementary, there is a small mistake here. We should change this plot and this plot. Sorry about this. If we have a complementary, this signal will decrease tremendously because we cannot detect the oxidation signal from these nucleotides, as I said. So this plot and this plot should be changed. Basically, we are doing this. As you see from these plots here, this blue line obtained from one single probe with non-complementary, the signal will increase. And if you are using a one signal mismatch from the bases, it's gonna decrease just a little bit. If it hybridizes, it's gonna decrease tremendously. So up to date, people have been using just regular electrodes, like pencil graphite electrodes or screen printed electrodes. We are working on the electrospinning process. We are thinking if we are going to coat these pencil graphite electrodes with electrospun nanofibers, because the nanofibers have very high specific surface area, we can enhance the signal. We can detect just very low signals as well, as a result of the more attachment of the genetic molecules on the high surface area. So we started working to coat these graphite electrodes with nanofibers. We use different nanofibers, and still we are planning to change the properties of the electrospun nanofiber to enhance the signal property. Basically, what we are doing, we are just using pencil graphite electrodes, but today we are using different electrodes as well. But still, because we haven't published any data from nowadays work, I cannot share. All the shared data in this presentation have been published, so you can look at the papers as well. So we are putting the cylindrical graphite electrodes and we are coating the nanofibers, and directly we are using these nanofibers. As you see from this scanning electron microscopy, we properly coated the graphite electrodes with nanofibers by using electrospinning process. Not only nanofibrous surfaces, also we can produce some thin film surfaces on the shaped surfaces as well. For instance, in this work, we coated the cylindrical surface with polyvinyl alcohol nanofibers, and we used a cross-linker and we obtained a hydrogel surface, hydrogel thin film surface on the surface, as you see how thick it is. As I said, we started working on polychlorinatrial nanofibers, which is very applicable. As you see from this plot, this is the measurement result of just pencil graphite electrodes. This is the coated pencil graphite electrode with polychlorinatrial nanofibers. As you see, this signal intensity increased tremendously. Also, in one of our study, we decided to clean the surface by applying cyclic voltammetry. When we apply cyclic voltammetry to pure pencil graphite electrodes, as you see, this yellow chart is expressing this data. When we apply cyclic voltammetry treatments, the signal intensity increases just a little bit. But when we apply this cyclic voltammetry treatment with pencil graphite electrodes, with polychlorinatrial nanofibers, the signal intensity increases more. Up to some point, it starts to decrease again because it's going to damage some microstructural property of both graphite and polymeric material. So up to some point, it's applicable, actually. Basically, we are both cleaning the surface and creating some chemical groups. We can have more attraction to the genetic molecule. That's why we can increase the signal intensity more. In another study, we put some conductive polymeric materials into polychlorinatrial nanofibers to see how it's going to work. First, we put polyaniline in the electrospinning solution, and we electrospun polychlorinatrial nanofibers on the pencil graphite electrode again. We realized that the signal intensity decreased, so it didn't work actually. But when we coated the surface of the polychlorinatrial nanofibers with polyaniline, the signal intensity increase. Okay, so we tried to put those coated nanofibers in the refrigerator at minus 18 centigrade and stay a couple of days to see how the signal intensity change. We realized that up to some point it increases again, then start to decrease. Because we concluded that because the polymerization has not been completed up to we coated the polychlorinatrial nanofibers with polyaniline. So still the polymerization occurs actually. And we have nice crystalline polyaniline on the surface of the polychlorinatrial nanofibers, and the signal intensity increases more. So in another study, we use cellulosic nanofibers. We use cellulose monoacetides instead of polychlorinatrial nanofibers. Also, we put nepheon, which is another conductive material, which has a sulfonic acid groups, as you see. And we observe the results. So this is the cylindrical graphite electrodes coated with cellulose monoacetate nepheon hybrid structure. These are the solution. As you see, up to some point, we obtained a blurry solution property. So after this 50%, this is the weight percentage actually. 50% we couldn't obtain more uniform nanofibers, so we stopped working after this percentage. So as you see here, when we put nepheon into cellulose acetates, so the pure cellulose acetates give better signal intensity. So we decided to modify genetic molecule with NH group. We put NH group on a single straight DNA molecule. We saw that the signal intensity increased tremendously up to some point again, then decrease again. Okay. So if you are using a synthetic molecules, modified synthetic molecules is very applicable for this kind of applications. In another study, we also play the microstructural properties of polychlorinatrial lipids. We use aqueous sulfuric acid. We put into different concentrated sulfuric acid solution, polychlorinatrial into those solutions, and we heat treated the samples to observe what's happening to the polymeric materials. In another study, we also put sulfuric acid into electrospinning solution. So we compare those two results, As you see, we obtain very beautiful colored polyethylene nanofibers by increasing the sulfuric acid concentration. After heat treatments at 180 centigrade degree, the color is changing from yellow to dark. So when we put pure polyacrylonitrile nanofibers in different aqueous sulfuric acid solutions and stayed at different temperatures like 100, 130, 160, and 180 centigrade degree, up to 25% of aqueous sulfuric acid solution, we can hold the nanofibers in the solution. But after this point, the nanofibers were completely dissolved. So we stopped working above this concentration. As you see, we obtained very good scala, as you see from here, by increasing the temperature and concentration. We lost the nanofiber uniformity and we obtained only some dense black liquids. As I said, when we put sulfuric acid into the solution, so you can go this publication and see the detail of this study. As you see, when we stay at 180 centigrade degree, so actually we decided working on 180 centigrade degree after seeing these results. So we saw that 180 is still working. So we decided working on at the temperature as high as possible to obtain actually more carbonous structure because of the stabilization process. As you guys know, the polyacrylonitrile is converting into some leather structure. So it can enhance the electrochemical property as well. We put sulfuric acid, as you see, the signal intensity is still increasing up to some point and decrease again. So it was a very nice result. We published this work. So today also we are working on the carbon nanofibers. Actually, previously we published some work on carbon nanofiber process, but we haven't worked on the electrochemical genetic biosensor application of this. Actually, we have been working for 2 years because we haven't published the results. I didn't put the result of genetic measurement. Just I would like to show how the process is working. So basically, we are producing pure polyacrylonitrile nanofibers and putting some catalyzer into the solution and obtain some hybrid nanofibers and applying stabilization and carbonization process. Stabilization is conducted in air atmosphere and carbonization should be conducted in an inert atmosphere. Otherwise, you are going to burn out of your polymers, your nanofibers. So this is our previous, actually, we published this work. We can produce carbon nanofibers and we are working on to use these nanofibers on genetic biosensor applications. We have some results. Actually, we already submit some of our results to journals because they haven't been published. I didn't put the results. Hopefully at the next coming conferences, I'm going to share the results. Thank you very much for your attention. I would like to also mention about my team, Nefise Yavuz and Hamza Yılmaz. They are MS students working in my lab. Karima Sahtani and Ayşe Bostancı, PhD students. Also, Dr. Nilay Aladaktanik already graduated from the group. Also, the works have been funded by the Scientific and Technology Research Council of Turkey and the Scientific Research Project Union of Bursa University. I would like to also thank them. Thank you very much for your attention. If you have any questions, I would be happy to answer your question.
Thank you very much, Prof. This is a very informative presentation, lecture. I have a question, please. Although these nanofibers could be used in electrochemical devices, but the stability issues are still high. How can we increase the stability of these electrodes?
Actually, they are disposable electrodes. We cannot use those electrodes again because you are already absorbing or attaching the genetic molecules on the surface. It's disposable, okay? So we don't have reusability issue for this kind of devices.
I have another question. Can the same strategy implemented for enzyme sensitivity?
Actually, yes. There are there are lots of publication in literature. Also, we have some publication, the enzyme immobilization on the electrospot nanofiber surfaces, but we haven't worked on electrochemical applications. We are considering just to work on it, but it's a good idea. Also, as I said, there are lots of publication in literature to use of electrospot nanofibers as electrodes to determine the activity of the enzymes.
Thank you very much, Prof. Thank you.
You're welcome.
Now I would like to invite Mr. Abdul Wahab. Mr. Abdul Wahab is currently working as research assistant in functional research group at National Textile University, Faisalabad. He is here to present on behalf of functional research group. Today he will speak about functional textiles for personal protection, please. Yes, Mr. Abdul Wahab.
Thank you very much. Can you hear me?
Yes. Yeah.
Okay. Thank you very much, sir. My name is Abdul Wahab, and obviously, as the introduction says, that I am working as a researcher on with Functional Textile Research Group. And today I would talk about functional textiles for personal protection. But before going into that topic, it's mandatory to analyze the situation that we are encountering in post-COVID situations.
Can you share the screen, please? You can't see.
Sorry, sir.
The screen. Can you display it?
Is it visible now, sir?
Yeah, we can see now. Thank you.
Sorry for the inconvenience. So, so if we analyze the post-COVID situation, there are some learning points that that are helpful in making decisions about the roadmap of future research work that would be taking place all over the world as well as in Pakistan. So the emergence of viruses and bacteria cannot be ruled out. And one thing that that we know that we have to make amends with our system and the available solutions to cater with the evolving modern problems. And if we talk about in the perspective of developing and developed country, both the developing and developed countries have suffered severely from these pandemics, and lives and livelihood of people weren't safe and secure in these situations. And obviously, it point out towards making some strategy to offset these problems to occur in the future. And for this functional textile group has focused on the personal protection by means of immobilization of nanoparticles over textiles, wearable textiles. And for that, we are currently focusing on 5 frontiers in our research group. Number 1 is metallization of textiles. Number 2 is to develop photocatalysts, and number 3 is to develop functional dyes which can protect people from the hazardous effects of viruses and bacteria, and especially those people which are more vulnerable to these pathogenic organisms. And then nanoparticle immobilization and breathable coatings. So talking about the metallization of textiles for antibacterial and antiviral activities, we are currently working on electrolysis deposition techniques in which we are depositing metals over the surface of fabric, and we try to confine these nanoparticles particles into nano range so that they can interact with the ingressing viruses and bacteria and kill them on the site where they come in encounter. So the first step that we usually follow is sensitize our fabric, because fabric technically for metals, fabric is not a good substrate. So we actually have to sensitize and activate its surface by means of other metallic materials and some etching materials. And for that, we first we undergo sensitization of the fabric, and then we activate this fabric by means of promoter or catalyst material. And this catalyst material then paves way for the deposition of required metal on the surface of the surface of cotton fabric in general. So the factors that we usually we consider, that we try to optimize the concentration of different reagents, because if we talk in the perspective of commercialization and its mass scale production, the process should be number one. It should be scalable, and it could be produced on a mass scale. And second one, it should not produce so much hazardous waste during the production line, and the loading over the fabric is optimum, which can guarantee good results, and it's obviously commercializable. So we actually optimize different steps, which are actually sensitization, activation, and then electrolysis deposition technique. And after deposition, we have got 11 different samples by changing the concentrations of different metals and ingredients in the system. And in this figure, from A to figure K, the concentration of different ingredients, which are actually tin chloride, silver silver nitrate, and obviously the metal precursor, these are gradually changing. And from these UPF ultraviolet protection factor values, we can actually analyze how good the deposition has taken place over the surface of fabric. And this is actually a general indication of how good the deposition has took place, and what is needed to be done if if the deposition is not good. Obviously, we can improve our system and make sure that the coating or deposition is durable. So these are the UPF values of the prepared samples. If we look at the A sample, the UPF rating is 106, which is quite high, that it can protect ultraviolet violet radiations from passing through the cotton fabric. And in figure K, obviously it is gradually declining till 26, where the loading of metal is lowest. And after 20 washes, we have actually observed that the UPF values have increased, and in some cases remained almost same, which indicates that the coating or deposition over the fabric is durable. And these results have been shown in this figure, where UPF values before and after 11 after 20 washes of 11 samples have been shown. And in the black curve, the initial UPF values have been shown, and in the red line, the UPF values after 20 washes have been obviously plotted. So it is indicative that the coating or deposition over the surface of fabric is durable, and UPF values are not actually decreasing in any case. So one thing is sure, that the basic requirement for our deposition was to ensure that it can work for a few hundred washes, simple few washes. And these 20 washes are actually very rigorous washing, industrial washing. And if we ensure significant result for 20 industrial washes, it indicates that it can work for a normal 100 wash of our washing machine. So once we have established that the coating is durable and it can work for our application, now we have to determine what is the morphology, if we have achieved our desired morphology. and then finally we would test test it for antibacterial and obviously the antiviral activities. If the deposited material or the processed product is capable of delivering good results. And in these figures, on the left side and on the right side, these are SEM images at very high metal deposition, and it can be observed from these SEM images at 1 micrometer and 500 nanometer that these depositions are confined in nano range, and obviously these grains are well developed and almost equi-sized, which means that the coating is uniform over the surface. Deposition is uniform over the surface, and now we just have to we had to decrease its loading to the lowest level we can achieve, which is actually workable for our desired application. And these SEM images are actually for lowest metal deposition. So the grain size is almost same, and grains are crystallites are uniformly deposited over the surface of cotton fabric, and and the grains are or crystallites are uniform sized. So we established that the deposition is in nano range, so it can interact with viruses, incoming viruses and bacteria. So now it was the time to test them for antibacterial activity, and this slide shows that we tested it against S. aureus culture and E. coli culture. These are gram positive and gram negative bacteria, and if we achieved good good activity for this sample, we can actually emulate these results or mimic these results for other bacteria classes of bacteria. And for S. aureus, the first sample obviously shows a good activity in terms that there is a prominent zone of inhibition. And if we observe it, the zone of inhibition is actually narrow, but this narrowness doesn't 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 do any disservice to our purpose, because the particles are immobilized, and actually these are actually inhibiting the growth of any culture, colonial culture over the deposited fabric. So similar is the case with E. coli, where the first sample shows us a prominent zone of inhibition. So actually we have observed here that the metals that we have deposited over the surface of cotton fabric, they actually form a durable deposition, and this deposition is actually working for our antibacterial application. So talking on the second front, that is nanoparticle immobilization technique for antibacterial activity. Actually, nanoparticles can be easily synthesized, but immobilization over the surface of textiles, it's actually a tricky job here, which we have to ensure that it's working in our case. And in this case, when we used as synthesized nanoparticles, we have to take help from different coupling agents, that we modify the surface of nanoparticles and make it more coherent or more favorable for deposition over the textiles. And then we apply it by conventional pad dry and cure method, because this method is installed in every assembly line of Pakistan. And then we post process it, and if we want to ensure if we want to do a secondary deposition, that's also possible. And then we obviously apply it for antibacterial activities. So this image is a simple diagram of pad dry cure method, by which we dip a fabric into a solution of modified nanoparticles, and then we pad it, and after padding we dry and cure it, and the obtained coatings are actually favorable for our results. So there is another key area in which we are working, that is breathable polyurethane coatings and films for the comfort of protective suits. Once we develop protective suits for viruses and bacteria, but by immobilization of nanoparticles or metallation of textiles, the fabric still has to be very comfortable to wear. And also it should be breathable so that air and water can pass through these fabrics or protective coatings. So the major challenge here is to make it breathable, and so that the transmission of water vapors can take place. And obviously the transmission of water vapors will cause cooling and comfort for the person who is wearing it. And then polyurethane, what role polyurethane plays here? Polyurethane actually uh, is formed of isocyanate and polyol alternating monomers, which are actually hydrophobic in nature, and in case of moist environment, which are very feasible for the replication of viruses and bacteria. This polyurethane can actually inhibit the growth of viruses and bacteria would not set easily over the surface of this fabric, and the time of bacterial life would obviously be uh, decreasing if we apply this polyurethane over fabric as a coating. So the first step that we are doing here is we are trying to introduce breathability by microporosity, and trying to ensure its size lies in the range of 2 to 3 micrometer, and then obviously we apply it as coating or film over the surface of textiles. And then there is another area which we are working, and it's actually a very promising area, that visible light driven catalyst. So photocatalysts, as you know, that when they absorb radiation, they generate electron hole pairs, and these electron hole pair are oxidizing and reducing in nature, which can be employed for various applications, including dye degradation, water splitting, carbon dioxide conversion, and then chemical reaction, different chemical reactions. So in our case, that we know that the photocatalysts that we already have developed are usually working in the range of ultraviolet radiation, not in the visible one. But but ultraviolet radiation, the intensity of these radiations in our surrounding is very low, and if we apply those photocatalysts which are active in ultraviolet radiation, we cannot expect good results. So for that, we are actually trying to shift it to visible range light-driven photocatalysts, and a few of chemical compounds are actually can work in a range of band radiation, like in UV, visible, and IR. And and those molecules or compounds which are actually whose band gap lies in the range of 3 to 4, they can be promising photocatalysts in visible range. So titanium dioxide is one of those chemicals of those solid materials which can actually absorb radiations and generate electron hole pairs. But we are currently focusing on a number of different materials which include iron oxide nanoparticles, the GC, and graphitic carbon nitride, and then obviously titanium dioxide. And the major challenges that we are trying to cater to are, we have to reduce the band to limit the band gap of these materials in the visible range, and then we have to inhibit or prevent spontaneous recombination of electron and hole pair. And the next thing is the synthesis process is obviously complex, so we have to simplify it and synthesize materials through facile synthetic methods, and then apply it on the textiles to make them functional in the visible range of radiations. And then obviously cost is also another thing which is usually an issue for products which are to be commercialized and to be produced on the mass scale. So the target is to generate visible light driven photocatalyst nanomaterials by fissile synthesis, so that they can be put into cyclic use to reduce the overall cost for practical applications. And then these graphs are actually showing that we have developed different composites of iron oxide and graphitic carbon nitride at different temperature ranges, and then we apply and then we use them for degradation of methylene blue, it is actually an analogous method to determine if they are capable of degrading methylene blue or any other dye with the generation of electron hole pair. Then obviously we can expect good results in case of viruses and bacteria. So the material which had graphitic carbon nitride nanosheets and iron oxide nanoparticles, they have shown very good degradation capacities or probabilities for methylene blue, and the values that and the key factors which are instrumental in these applications are obviously concentration of dye and volume, and obviously mass of the powder, and time is also an indicator of how good the material is working for our application. And that's it. So and then another key area in which we are currently working on is novel functional reactive dyes for antibacterial activity. So if we talk about the reactive dyes obviously react with the textile and deposit over the surface, and then these reactive dyes are very hard to remove from the surface. But if we apply an antibacterial or antiviral active material separately, then obviously it would increase the cost of production, and we cannot expect uniform or reliable results if we keep on increasing the steps of production. So here in this work we are actually trying to merge these two steps into one, and we want to we are trying to develop new functional dyes which are capable of degrading viruses and bacteria. So in case of bacteria, we are trying to make reactive dyes in three colors, that are red, green, and blue, and then these colors can actually form any other color which we want. And the synthesis process that we are actually using here is, first we synthesize reactive dye and modify the synthesized dye with antibacterial agents and UV absorber, and then we apply these reactive dyes over the cotton fabric and run qualitative and quantitative antibacterial tests, so that we can determine how good these functional reactive dyes are working for our application. So, these are the research works that we are currently working on, and actually these areas are promising areas in uh, in uh, in case of personal protection equipment, and obviously it shows that it will obviously determine the response of uh, uh, of our governments or our institutions, research institutions, in case of any pandemics occurring in the future, and it would protect vulnerable segments of society. So this work can promise good results in future, and will obviously strengthen the disaster management mechanism of Pakistan, of our country. And obviously this work would need further collaborations with other institutions and research centers. We can obviously collaborate on these areas and and identify new areas of promising research, so that the products that are developed through this research work are applicable on mass scale and are paving way for value added production and the economic growth. So I would like to end my presentation here, and I warmly welcome any question that you have.
Thank you very much. Thanks a lot. I have a question, please. Is it possible to scale up the techniques? What will be the effect on uniformity on scaling up the process? Can you elaborate, please, for the audience?
Okay, thank you very much, sir. So if we scale up this research work that is underway in our group is actually this work has been designed taking into consideration the possibility of scaling up these materials or these functional textiles. So the synthesis methods are actually very simple, and usually they do not require very high-tech equipments, and they can be developed in solution phase or solid phase. So the uniformity of the depositions or uniform activity of these materials can be expected, and we are anticipating that the results, the activity that we would achieve from these research work would be uniform, and it can be scaled up on commercial or industrial scale.
Thank you very much. Also, there is one more question, please, to you. How about the deposition? Does the deposition will affect the color on the substrate?
Yeah.
Like
color would obviously, if we use those metal like zinc, then which are actually white or white, the color would be white. And if we use like copper and other silver metal, the metallation of fabric would actually affect the color. So if we can reduce its effect in coloration by minimizing the deposition, but obviously it cannot be ruled out that there would be no color. Obviously, functional textile would have color.
Okay, thank you very much. Your work is quite significant, and we can see the antibacterial properties in your work very significant. Regarding the pandemic, could you please tell the audience about any antiviral properties in your work?
Yeah. So the first step is to determine the antibacterial activity, and then obviously these materials are confined in nanoscale. So and they are obviously in accordance with they are in accordance with their sizes are comparable. So obviously when the viruses will try to develop actually form colonies or penetrate through these textiles, these these nanomaterials can interact on the structural level and destroy their structural integrity. So we haven't run antiviral tests yet, but we are expecting very good results in this context.
Thank you very much. Thanks a lot. Very good presentation. Thank you. Now I would like to invite Dr. Mohammad Mohsen from University of Engineering and Technology, Faisalabad. Hello, Dr. Mohsen sir.
Hello, Ji.
Can you hear me, please?
Yes, I can hear you.
Yeah, I would like to introduce Dr. Mohammad Mohsen. He is from University of Engineering and Technology, Faisalabad. He is the head of the Department of Clothes Textile Department. He is Chartered Colorist of Society of Dyers and Colorists, UK, and HSC approved PhD supervisor. He is currently serving as chairman, I told before, and he is a group leader of Textile Sustainability Research Group. He will speak about potential of nanotechnology for the growth of Pakistan's industry. Today's presentation. Over to you, Dr. Mohsen, please.
Okay, thank you very much, Dr. Abdul Rahman, for your kind introduction. I hope that you can see my screen.
Yeah, I can see.
Okay. Okay, today I will be discussing about the development of cost and performance effective bio-based antiviral mask and PPE. Although it's not only restricted to the mask and PPE section, but considering the importance nowadays, we might limit it to that point. Now, the first point is that why we need antiviral performances. And the reason is very obvious due to the deadliest virus diseases. And if we look back at the history, I just added a slide or two regarding the history. And these are not all viruses, some of the few viruses which has caused the most damage. And these are only around 100 or 110 years old, not older than that. And the most killer among them is the Spanish flu, and it has killed more humans than even the world wars. So it's estimated that 50 to 60 million people have been died due to this one. So if we move on to the other influenza, then it was Asian influenza, and the death was around 2 to 4 millions. And then if we move on to Hong Kong influenza, it was in 1968 to 1969, around the similar kind of deaths. But the thing which is quite common is that these viruses, they changing their variants and their offshoots, and they are coming back, which is not a good sign for humans. So they are not completely some sort of finished. The Russian flu is also believed some kind of their variant to their precursors. Then the SARS, the severe acute respiratory syndrome, and it was, although in the beginning in 2003 it was believed that it might have caused a lot of damage, but fortunately it only caused 800 deaths, and that was it, at least SARS. Then the swine flu influenza also caused some damage. And COVID-19, I think I don't need to go into too much details because right now every one of us is suffering from this one. And it started in November 2019 and it spread very quickly in the whole world. Now, and it's called now SARS-2, and we know that we are going through this pandemic. And it has it has led to a lot of trouble, means some kind of those actions which have never been world has seen before, like curfews, restrictions. Now, some of the few lessons which we might have learned is that government wasn't prepared to combat those pandemic. Similarly, this virology experts, they might be complacent with regard to the efficacy of their existing testing and monitoring system. And now coming to our industry, which most of us belongs to, is the textile industry also did not focus on antiviral textiles previously. And combining those factors, so far the total death is around 2.5 million, and total affected cases are 113 million. And we all know that number is increasing, and we hope that soon it will finish. Now, regarding the importance of antimicrobial, antiviral performances, since we know that the viral diseases, they are increasing with severe consequences. And the bad thing about them, like I shown in my previous slides, is the new strains and new mutations. They keep coming. And so I hope that it will not be the case for COVID-19, but history tells us that normally it is the case. Therefore, antimicrobial and antiviral textile importance is increasing. And it is not only for healthcare professionals, but it also for a number of numerous applications like home apparels and clothing. So that is not only restricted to a certain area, but it is a more wider application we are looking at. Now, if we move on to the what kind of options we have for the antimicrobial and antiviral textiles. Now, the first one, option A, could be that we select those fibers, certain fibers which do exhibit antimicrobial performances. But most of the time, the problem is their ease of availability at bulk scale, and sometimes they are comparatively less effective as compared to some of the finished or other options which are available. And I think some of my colleagues from France already has discussed some of those fibers and their blends in earlier slides, so we don't might not go too much in detail. Now, the other option could be is the application of the finishes on the already available fabrics. Now, that could be an easy route if we're talking about the bulk and when we need those kind of textiles in every week of life. So finishing could be an easy thing to do that. But the difficult part in finishing is the finishing itself. Now, unfortunately, so far, the most of the effective finishes, they either contain metals or they contain toxic amines or synthetic toxic polymers. So the picture doesn't look very good in that area as well. And then on top of it, my colleague was previously presenting some of the micro nano. So micro nano form of the finishes, they are really good, and they have shown very good results. But there are also concerns of inhaling micro nanoparticles and dust, especially when they are from certain metals or certain compound that might not be good for us, for humans to inhale. So these are certain limitations. And on top of it, the most crucial one is that most of the antimicrobial finishes, they are not antiviral, because these are two different things. Antimicrobial, there are different kind of microbes, and we need to be very specific. So normally we take in textiles gram positive and gram negative and things like that. But when we take the things like antiviral, most of the antimicrobial finishes, they are not antiviral. So that thing need to be taken care of as well. Now, some of the other drawbacks are that we normally need very high dosage of the finish. So it's not like 1 or 2%. So normally for effective results, we might need 10. And then if it is also has the metals, then it's on top of that bad thing. Then it has the micro nanoform, because no micro nanoform, they are very effective. It normally gives very good results, and that is very good part. But but that also means that we can inhale it, and it can with severe consequences. Some of the examples, like nowadays HQ white lock is very good, very effective, but high dosage is required. Certain metals are there and in microform. So and especially when the product is to be used like mask next to the mouth, then it is not a good, might not be a good option at the moment. It might be because we don't have too many options, but later on it might not be that much good thing. Then the other thing is that why not we use such fabrics or materials which can filter most of the germs or microbes, like N95 materials, not only the mask but even the fabrics, which has the efficiency of filtering particles of 0.3 micron up to the 95% or more. But the problem here is that yes, they can physically filter the germs and microbes, but they cannot kill them. So still the microbes and viruses that can be transmitted to the other person when we touch it, or use your hands, or on your eyes and face. So it can be a source itself, source of spreading those microbes, and especially the antiviral, especially the viruses. Now, so these are some pictures. These can be the potential vector for viruses. And although the mask is normally here to protect us, but if we have been exposed to the virus, then it could be that while if our hands we have been exposed through our hands, then while picking those masks, we can be source of transmitting it. Similarly, when we are putting it on our mouth, or when we are putting it down, or even discarding it, then touching our nose and eyes. So there can be plenty of ways if we have been exposed to the viruses that we can spread it. So that came to the point that we need antimicrobial and antiviral performances. Now, another bad thing about this COVID-19 or coronavirus is that it can stay alive for a much longer time than initially we have thought for. And the latest research findings, they have came to the conclusion that it can live for a few hours to days in the aerosol as well as on the different surfaces. And this study was published in New England Journal of Medicine, and it was from National Institute of Health, CDC, UCL, and other university. And the scientists have found that even the SARS-CoV-2 was detected in aerosol for up to 3 hours, up to 3 to 4 hours on copper, up to 24 hours on cardboard, and 3 days on plastic. There is another study which also suggests that up to 3 days this can live on the textile fabrics as well. So that might be the reason, that could be one of the reasons, that despite this virus having a bigger size, this coronavirus, it is spreading very quickly. So these are the potential threats. And now coming back to what we have done at Department of Textile Engineering at UT Lahore Faisalabad campus. So when this pandemic started, and then we started working on the development, and very quickly we came up with the development of 100% bio, antiviral, and antimicrobial finish. And then we also did a lot of optimization for different application conditions, as well as a range of fabrics for cotton, for polyester, PC blend, and polypropylene non-woven materials. Then we also done the pilot trials at our department. And then the crucial part was, and it took a lot of time, the testing of those from the ISO certified lab, because initially at that stage there wasn't any lab available which can do the testing, especially for antiviral. Then these are just a snapshot of the testing and from the TTI. And the thing is that you can see that this finish is where we have used this AATCC 100 method. So Astrosaurus and pneumonia microbes. So efficacy is 95 and 96%, and very good reduction of this colony of the microbes. So it does show a very good result, considering that it is 100% bio as well. But we have achieved the best result is the antiviral. Normally, like I said earlier in my presentation, that sometimes, or most of the times, most of the antimicrobial, they're not effective against antiviral. And the good thing about this our developed product is that it is very effective, and it has given the highest effect, which is the full effect, and the reading is 3.75. And as per standard, if your reading is around 2 to 3, then it is small effect, and if it is 3, then it means full effect. So you can see that our treated product has easily crossed the line with very good margin, so which reflects that it is very good antiviral testing with the full effect. And I think we are really extremely thankful to TTI for developing and providing this testing facility, especially for antiviral textile. Like I said, to my knowledge, it is the only facility in Pakistan that can do the antiviral testing, because certain level of like protocols need to be fulfilled when you are talking about the viruses and viral testing. And thanks to them, and really appreciate their CEO, GM, and other team, technical team, for providing us this opportunity, because it is always a collaboration in a healthy way that we can come up with the results. Then if we talk about the other key features of this UET's novel technology, that it can be used for cotton, polyester, PC, and non-woven. It is breathable and comfortable. And the good thing, the two key features is that it is 100% bio and organic, and it is very effective against antiviral, which very full effect, like I show you the results. It is very effective against antimicrobial. It also has some kind of advanced technology to trap and kill more microbes and viruses, and it is toxic metal and mine free. And the key thing for the full production is that it is cost and performance effective. So it is not very expensive, so it's very cheap as well. So these are some of the features of this technology. We are still working on it, improving these features. Now the question at that time could have been that what is the next step? And then normally people from the academia, they are sometimes being criticized that the technology, the research are not transferred. So what we did at that time, we have, after developing and then testing, we also developed at the labs of Textile Engineering Department at Lahore Faisalabad campus. We have developed and donated those 5,000 antiviral masks and 160 PPEs to the DHQ hospital, Faisalabad, Lahore, similarly to frontline worker, to the chancellor office, and then they distributed it to the frontline workers. We kind of play our part in serving the community regarding that as far as our innovation R&D is concerned. So now, what is the status now? We have the IP technology of IP protection. It has been applied, and that's why I couldn't tell more technically about different things, because it's still an IP is going on, and we can commercially give the license if somebody is interested, or want to use it, or want to try it. And at the end, thank you very much for your time and patience for listening me. And if you have any question, please feel free to ask.
Thank you very much, Dr. Saab. A great presentation, no doubt. One of our audience just have a question. How about developing RO membrane locally for water purification? Any research or any development? I think just he has asked.
Okay, although I couldn't hear you properly, but I think that's not the word what the presentation was all about. I think it might be with the previous participant, but regarding the membranes, if you talk about the physical filtration, I think the membranes are good depending on the particle size. So if you have a certain particle size, depending on what kind of impurities do you want to purify, membranes is always good. But after a certain time, you need to clean those membranes. So although it's not related to my topic, but yes, membranes can be produced and they can be recharged or recoated as well.
Okay, thank you very much, Dr. Saab. Thank you. Thanks a lot.
Okay, thank you very much.
Thank you. Now I would like to invite Dr. Bilal Kadir.
Assalamu alaikum.
Walaikum salam. Dr. Saab, I would like to introduce yourself to the audience. Dr. Bilal Kadir is currently serving as an assistant professor in the Department of Yarn Manufacturing here at National Textile University, Faisalabad. Dr. Bilal's research interests are focused in electrospinning, multifunctional nanowebs for the filtration, functional textiles and medical application, auxetic, functional and smart yarns. Today's presentation, Dr. Bilal is giving on potential of nanotechnology for the growth of Pakistan's industry. Please, Dr. Saab, over to you.
Thank you, Dr. Abdul Rahman. Can you see me my presentation?
Yes.
Clear now?
I can see, yes.
Okay, thank you. Bismillah ar-Rahman ar-Rahim. Today, I'm going to somehow see the potential of nanotechnology for the growth of Pakistan industry. As we all know that most of the Pakistan industry is conventional industry, and they are reluctant to adopt the new technology.
Excuse me, please. Can you enlarge the screen, please?
Wait a minute.
Full screen, please.
Display setting के अंदर है वो option. You can go, sir. You can go into the display setting and then you can choose the duplicate mode. Display setting on the top.
Display setting on the top, yeah.
You can go here, click there, and then you can display setting.
Sorry, wait a minute. I'm checking.
इधर ही बोल रहे सर, एक कहीं बोल रहे तो पता चला।
उधर ही बोल दे।
जी डॉक्टर उस्मान साहब, डिस्प्ले सेटिंग में आप क्या कह रहे थे?
sir, you can do the maximize first. Go in the slideshow mode first. Share the slide.
Okay.
Slideshow mode.
Yeah.
Okay. Then there is the second one is the display setting. Go into the display setting and choose the duplicate mode.
Duplicate mode, it's not running. Display setting and duplicate. Yeah, now you can see.
Share the screen. Share the screen. We have not shared the screen now.
Okay. Now, please, Dr. Usman.
Yes. Now, sir, again go into the display setting. Yeah.
Yeah. Now it's okay.
Yeah, it's okay now.
Okay. Thank you. Sorry for the disturbance. So I was asking about the Pakistan's industry. Pakistan industry, as most of the people here are related to the Pakistan and they belong to Pakistan. They know the Pakistan industry. They are reluctant to adopt new technologies and new things in the industry. So I will try to show the global aspect of the nanotechnology and its products, and then we will see how we can implement in Pakistan the same technologies. As most of the researchers, they know nanotechnology is the engineering of functional systems at the molecular scale. In other words, nanotechnology is the study, process, and manipulation of materials at a molecular level. Means just we see the materials on very low size. When we reduce the size of the materials, the behavior of the materials changes and their properties also changes. So, the application worldwide is increasing day by day. The researchers, the scientists, they are working on different aspects of the nanotechnology, and the product range is increasing day by day due to its versatile properties. So if we see the nanotechnology market, so we can see nanotechnology is going to use in biomedical and other defense security, energy related products, in films, in chemicals, in other materials, communication materials and equipments, computers. But important is the major portion lies in biomedical sciences, biomedical products. And the second one portion is related to the materials, which are mostly computer related materials and metals, which is related to the construction. And if we see the last 5 to 6 years market share of nanotechnology, you can see here from 2017 to 2022, share of the different products or different categories. Nanomedicine was somehow on lower side in 2017, but it's increasing day by day. And other like genetic engineering, agriculture, nanotechnology also is increasing day by day. If worldwide we see the share from 2017 and anticipation up to 2024, the market share is anticipated that it will increase a lot, and it will be doubled after 4 to 5 years. And if we see the market in Asia, you can see 52% of the market share of nanotechnology based products is Asia. And other remaining is 28.4% European market, and then North America and Africa and extra. And in specifically in Asia, we are nowhere. Japan is at the top, or USA and the second, but Japan and Korea, they are manufacturing most of the nanotechnology based products, and they are enjoying the price and other benefits of the nanotechnological based products. If we see the potential in Pakistan, so Pakistan already have well established some industries, like agriculture industry is well established in Pakistan, and second one is textile industry is established already. Medicine industry is also establishing day by day. Its increasing growth rate is much higher than before. And plastic industry is now also is going to rise in Pakistan since last 5 to 6 years. Coating and paints, we are making ourselves, and then construction, automotive, and then surgical. All these industries, they have well established their manufacturing plants, their setups, but the problem is they all are working on the conventional materials, and they are not doing work, or they are not intended to work on the nanotechnology based products, which are already has been established in other world. So if we see agriculture industry, so nanopesticides, here many companies are manufacturing pesticides, but no one is producing nanopesticides. And their effectivity, their potential, their effectiveness for the plants is much higher than the conventional pesticides. Same for nanofertilizers, agriculture, farming, pollution monitoring. These all are the areas in which we can use nanotechnology, and we can enhance our productivity, we can enhance our growth, and which obviously increase the Pakistan's GDP, our country's GDP, and their potential. Also, economical aspect will be very good. If you see in textile industry, some of the textile manufacturers, they started to use somehow nano finishes, somehow, but not all. Most of the textile industry is stick on the conventional coatings, as conventional coatings are somehow cheaper, but the stability, but the productivity and effectiveness of the conventional is somehow inferior. So in water repellent textiles, anti-static textiles, wrinkle resistant textiles, for the strength enhancement, for the UV blocking, antimicrobial, for the antibacterial, for the sensing, these all fields we can use nanotechnology based materials. Obviously, this is not this will increase somehow price of the product, but the final price, market price, will be much higher than the conventional products. I have seen many of the textile products, nanotechnology based products, their price is 4 to 5 times higher than the conventional textiles. But if we apply these finishes and these nano materials on the our fabric, our yarn, our fiber, so our product cost will maximum be 100% higher, but the profitability will be 500 times higher. So I think our manufacturers, textile manufacturers, should see this opportunity, and most of the European market and American markets, they are also now prioritizing towards the nanotechnological based products. If we see medical industry, Pakistan's medical industry like medicine, drug delivery, patches, and bandages, these we are making in Pakistan, but these are all with conventional materials. If we use 9 nanomaterials in spite of conventional materials, their efficiency, their effectiveness will be much higher. As you have already seen, the medical based products have much higher share in the medical side. And if we can be successful in producing locally these products, we can also export these products to the other countries. Nanotechnology in plastic industry. You will see plastic industry. Our plastic industry is nowadays increasing for the packaging. We need antimicrobial food packaging system, and we are using normally most of the industries using silver coatings. But if we use silver nano coating, its effectiveness will be much higher. And in other categories, UV protection, strength of the plastic material will be high, like in pipes, water pipes, gas pipes. Their strength, their flexibility, their UV protection will be much higher if we will use nanomaterials. Price increase will be not much higher if we use these materials, but the materials sustainability, materials cost, material price, and market share will be higher. If we see paint and coating industry, many worldwide, many industries, they are making nanotechnology based fire resistant coatings, paints, hydrophobic paints and coatings, self-cleaning coatings, weather protection coatings. And obviously we can make it here in Pakistan. Many of the paint and coating industry, they can use nano materials to increase their profitability. And we see construction industry from the last 2 years, our government is encouraging the construction industry. And if construction builders, they will choose the nanomaterials. Obviously, somehow cost will be increased, but on the other side, structure stability and durability will be obviously increased. We see automotive industry. Pakistan's automotive industry is also progressing since last 5 years. New companies are coming here, and they are building their plants here in Pakistan, manufacturing plants. So many applications in the automotive industry. Some of the applications are dirt repellent, anti-reflectant or scratch resistant, and easy heat transfer, and lightweight body parts. These all we can achieve with the nanomaterials, with composites, and with other using with other composites and nanomaterials. So automotive industry can also use these nanomaterials to increase their profitability. Other is our small industries. We have related to the surgical instruments. These instruments are conventional based instruments. Actually, just they do silver coatings on the surgical instruments, but we can do nano coatings which are more durable, which are more functional as compared to the conventional material. So I think our surgical industry, surgical equipment industry should also focus on the nanomaterials, which will enhance their growth. We analyze the potential of the nanotechnology in Pakistan. Our skilled labor is short nowadays. If government will make a plan to make to produce skilled labor through the academia, I think we can tackle this problem. And the other major problem of the government sector is their policies. Regulation and enforcement agencies, if they will be attentive to increase the growth of the industry, so I think industry will not be reluctant to adopt this new change. Health safety, environmental health safety problems are there if we use these materials. And if government wants, then we can also make a participation of public and private sector participation. We can make groups to enhance these type of new materials, or to build these materials, to manufacture these new materials and their application in different fields. And we see there are some advantage and disadvantage. There are some fewer disadvantages of the nanomaterials also are there. Reproducibility of the nanomaterial based equipment is, or products, is a problem. It's time consuming, obviously time consuming, but on the other side, advantages are much higher. It's most of the materials non-toxic, but some of the materials are toxic, but most of the materials non-toxic, environmental friendly. There are no expensive equipments required for these to manufacture these materials. Easy synthesis, room temperature synthesis, and scaling up is easy. Our university, National Textile University, is also trying their best to introduce new nanotechnology based products since last 4 to 5 years. And we have also produced some PhDs in these fields. So we have produced some nanotechnology based products and also marketed, and it was successful. In medical side, we are producing face masks, gowns, bandages, drug release strips. And in cosmetics, beauty masks, we are producing, but not marketed yet. And for wastewater treatment, we are making different filters. For drinking water filters, we are doing work on these things. And also for the energy side, we are working on the battery and solar cell electrodes. And here are some examples of our products: micro wizard face masks, nano wizards, and gowns for the antibacterial, antiviral properties. Thank you. Thank you, Dr. Abdurrahman and other participants.
Thank you very much.
Any question, please?
Yeah, there is one audience. He just asked the question: why we said that a nano form of any substance is more effective than a micro? Why the nano are the more effective?
Actually, when we break down any bulk material, their surface area is increased. When surface area is increased, more functional sites are there. More functional sites are there, so we can use these functional sites for our requirement, for our use. So this is just due to the higher surface area.
Okay, thank you. We have another question, please. How antibacterial characteristic is developed in textile via nanotechnology?
Sorry, I could not understand. Sorry.
How can we develop antibacterial characteristic in textiles via by nanotechnology?
Nanotechnology. Actually, many of the researchers, they are working on these fields. Nano silver coatings we are using for the textiles, nano with graphene and CNTs. These also have antibacterial properties. Many of the researchers, they used also with nano silver and with the CNTs, we can increase the antimicrobial properties of the textiles.
Okay. Okay, thank you. There is another question, please. What is the percentage increase in performance of nanoparticles in compared to that in conventional particles? For example, if we replace nano silver with conventional silver particles used in synthetic fibers like polyester?
Good. In last 3 to 4 years back, 2 or 3 researchers, they achieved very good increase in the efficiency, and it was up to 70%. And they have compared with the conventional textile and with the nanotechnology based textiles.
Okay, okay. Thank you very much, Dr. Saab. Thanks a lot.
Thank you.
Good presentation. Thank you. Now we would like to move towards short video presentation session. And this session belongs to the short presentations. And we are going to share a couple of them. One of them is development of CVC yarn by filament blending by Dr. Zulfikar Ali.
Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alameen. Wassalatu wassalamu ala Sayyidul Anbiya'i wal Mursalin wa ala alihi wa sahbihi ajma'in. I am Dr. Zulfikar Ali from Department of Textile Engineering Spinning Section, National Textile University of Islamabad, Pakistan. Today my topic of talk is development of CVC yarn by filament blending. Outline of presentation, introduction of CVC yarn, experimentation, results and discussion, and conclusions. Introduction. CVC yarns are those which consist of cotton and polyester staple fiber with cotton blend ratio of more than 50%. Normally these yarns are made by blending cotton and polyester staple fibers in blow room or in drawing section. Blow room blending is called intimate blending, while blending at drawing is called sliver blending. Here in this work, a new idea of filament blending is being introduced, which may be adopted as practice in textile industry to produce CVC yarns. Experimental. Materials: polyester filament yarn of 150 denier with 60 filaments, polyester filament yarn of 100 denier with 48 filaments, cotton polyester fiber with 38 millimeter and 1.2 denier. Machines: blow room, card, drawing, simplex, string spinning with core attachment, and auto winding will be used in order to make the CVC yarns. Design of experiment. Here you can see that 8 yarns will be produced in which cotton and polyester ratio are adjusted as per the filament denier. First of all, 70% cotton will be added to 100 denier to make the 16 yarn, and then 70% cotton with added with polyester 1.2 denier to make the 16 yarn. Similarly, 55% cotton and 45% polyester by using the polyester filament of 150 denier, and then 55 and 45% polyester staple fiber and cotton to make the 16 yarn, and then 80% cotton and 20% polyester by using polyester filament 100 denier, and then 80% cotton and 20% polyester 1.2 denier to make the 10 yarn single. Then 70% cotton and 30% polyester by using filament of 1.50 denier to make the 10 single yarn, and then 70% cotton and 30% polyester of 1.2 denier in order to make the 10 single yarn. To carry out these experiments, 4 types of mixing was prepared: cotton 100%, cotton polyester 80-20, cotton polyester 70-30, and cotton polyester 55-45. All materials were processed through blowroom, card, drawing, and simplex after adjusting the machine as per the requirement of the material and made a roping of 1 NE. At a ring frame, having core attachment, 2 yarns of 16 NE and 2 yarns of 10 NE were prepared using 100% cotton roving with polyester of 100 denier and 150 denier polyester yarn with twist multiplier of 3.2. Here in this slide you can see the ring frame with core yarn attachment. Core yarn attachment filament will be fed to the front roller through a pre-tensioning feeding system, and in this way, by specific adjustment, we can develop the CVC yarn. Specific adjustment was used to get plied yarn-like structure instead of core-type structure. Comparable normal CVC yarns of 16 single and 10 single were also prepared using blended roving of cotton polyester at the same TM. Oyster transfer rapid and oyster testers were used to measure the breaking strength, elongation, unevenness, thin places, thick places, naps, and hairiness as per standard test methods. Here in this picture, we can see the plied and core yarn structure. So we, in this study, develop plied yarn structure, which is this one, as compared to core yarn. Normally, this core yarn attachment is used to make the core yarns. Result and discussion. Here you can see the comparison of the single yarn strength. White bar of the graph show the single yarn strength of 16 and 10 NE. CVC yarns made by intimate blending by black bars are the single yarn strength of 16 hybrid or 10 hybrid yarn, which are made by using the filament. In comparison, we can see that the strength of the filament blended yarn is higher in all cases as compared to the intimate blended yarns. Comparison of elongation. Similar is the case that the elongation of all the filament blended yarn is higher as compared to the intimate blended yarns of CVC. Comparison of unevenness. Unevenness of the filament blended yarn with black bar is lower than the white bar, which is the unevenness of the intimate blended yarns, which show the better quality of the filament blended yarns. Imperfection. Actually, imperfection is the summation of thin places, thick places, and naps. This graph also shows that the 16 and 10 NE filament blended yarns have a lower imperfection as compared to the intimate blended yarns, which has higher imperfections. So quality is better. Here also, hairiness of the filament blended yarn is also lower in all the cases as compared to the intimate blended yarns of 16 and 10. From all these comparisons, we can conclude that CVC yarns may be developed by filament blending instead of intimate blending. Quality of these yarns not only comparable but also better than intimate blending. The CVC yarns can be made in a pure cotton spinning unit without installing separate blow room, card and drawing section for the polyester fibers. Thanks for your attention.
Now we have another presentation about structure and geometry of single layer and two layer stretched woven fabrics.
Ji, Assalamu alaikum. It is Dr. Zuhaib Ahmed, and today we will study the structure and geometry of single layer and two layer stretched woven fabrics. In woven structures, we know that the woven fabric geometry and structure have significant effect on their behavior, as a good reinforcement material ensures the better property of the final product. So it is necessary to understand the internal geometry of the woven structure. In single layer structures, you can see the interlacing of warp and weft yarn in single layer plain woven fabric. It's here it is its design and the repeat, and along the transverse cross section you can see the binding wave of weft yarn, and along longitudinal cross section you can see the binding wave of warp yarn. It is necessary to understand the transverse and longitudinal cross section. Similarly, we have the shape of a two-layer plain woven fabric and its wave representation, and the binding wave of weft yarn along transverse cross section and along longitudinal cross section. Why we need to study the fabric geometry? Because we can predict the maximum set of fabric, we can predict its mechanical properties, and it can help us understand the fabric performance, and we can derive the relationship between geometrical parameters such as crimp and the weave angle. We have different structural models like Pierce circular cross-sectional model, the modified elliptical model, Kemp's racetrack section, Hull's lenticular cross-sectional model. Then we have the description of binding wave in the fabric by Fourier mathematical model, schematic correspondence, and some other different models. We will not go into the details because of the shortage of the time, so I will skip it. We will see the evaluation of woven fabric geometry by Fourier series, which is one of its kind for the evaluation of the geometry. What is Fourier series? It is necessary to understand it's a combination of Fourier sine and cosine series for a function which f of x, which is periodic on an interval minus pi to pi. The Fourier series of a function is given by this formula, and where the coefficients can be found by this formula. How this works, you can see the example here. We can see the first four partial sums of the Fourier series for a square wave. We have a square wave, and when we will apply the Fourier sums, then when we will keep on adding the number of terms, it will get closer to our square wave. So this is how we can apply the Fourier series to any function. For the valuation method, mathematical expression and description of a binding wave in single layer. Suppose we have a fabric, single layer fabric, in which we have one repeat, because it's a sinusoidal periodic, we have the periodic shape in a plain single layer woven fabric, so we can correlate this to the Fourier periodic function. Here in this single layer woven fabric, we can do the linear description of this binding wave, by which we can use two straight lines, and we can use the equation of the lines to calculate its slope, as we have the heights and diameters and the distance between two yarns. We already know by using these parameters in the equations given below, we can do the approximation of this woven fabric. Similarly, we can do the approximation for the two-layer woven fabrics, in which this is the first layer and this is the second layer. We can do the approximation for the stitching area and the non-stitching area in the similar manner, using the linear description of the lines. Suppose we have a real binding wave, in which we have the coordinates of this real binding wave. We can use these real coordinates in our Fourier equation, and by using these coordinates we can approximate this real binding wave as well. How we can do the testing? We have the fabric, we can impregnate into the resin, make the cross sections of it. By analyzing the microscope, taking the images, we can analyze these cross sections. By the cross sectional images, we can calculate the real different parameters of the binding wave and its cross sections. First, we have a theoretical approximation, which is the modeling. We have a theoretical approximation using the linear function, in which we have one repeat. We can calculate the slope, we have the heights and the diameters and the space between two yarns. By using these all things into the Fourier equation, we can get the approximation of the binding wave for one repeat, and we can get the harmonic components. This is the first harmonic component, which is the height of this binding wave, then the difference between the first and second and third, and we can calculate many components as we want to. Then in the next stage we have the experimental analysis, in which we have a binding wave. By using the coordinates of this binding wave, using into the Fourier equation, we can approximate this experimental data, and you can see the approximation of this experimental data. Then we can combine these two, I will jump. Okay, then we can combine these two in this diagram, the experimental binding wave and the theoretical binding wave, and we can see the difference between these two by these harmonic components. So by this we can do the approximation of the binding wave, and we can analyze the difference. So it is possible to do the approximation for the two-layer stitched woven fabric by the same method, and the relevant articles are given here. Because of the shortage of the time, I made it quick. So thank you for your attention. Stay safe and healthy. If you have any question, you can email me at this email ID. Thank you very much.
Speakers for their presentations and lectures, very informative to all of us, and I would like to thanks to our audience as well. Today is our very important day for the conference is going to end up, and inshallah we will see again tomorrow at 9:30, I think. And Dr. Aqsa Imran and Dr. Fahim Ahmad they are going to host tomorrow's early morning session. So inshallah we will see again tomorrow 9:30. Take care. Thank you very much. Thanks a lot. Bye.